First of all, we'll be creating our storage account. Here we need to provide some resource group name. So this is the default resource group that has been created. If you want to create any other resource group, you can just click on this new and just give a name. Blob. Okay. One thing I just wanted to let you know, like whenever you are creating a storage account name, make sure the name that you are providing, okay, that should be in a small case. If you provide like any camel case name or any uppercase name, that will not be accepted, because as you can see, I have been providing like uppercase letter I've given here. So it is throwing me error that field can contain only lowercase letters and number, and name must be between 324 characters, which means you cannot have very shorter name, and even you cannot have a very longer name. Okay, it should present between 3 to 24 characters. And also you could not have any spaces in between name or any hyphen or something. You can only write numbers and the characters. That's it. Okay. So these you should consider these conditions, okay, while creating the name. And also the name that you are providing, that it should be unique globally within your region, whatever the region you're selecting.
Okay, wait. Okay, subscription, I can leave Azure subscription one by default, or do I need to?
Just give me
I
a
can just provide the subscription name, right?
no.
Any
Here you have to provide a resource group name.
for the
Subscription
subscription, I
name
can.
is already selected, right?
Okay, and here for the field, okay, I'll just add something. Select existing item. I cannot do this. Or else create new.
Just click create new and provide some name. Yes. Click OK. Yes.
And the storage
Just click.
account name, this can be the same. Okay. I'll just
I
provide.
think that would be not accepted because it is a very general name that you have provided.
Okay. Okay.
Okay, just try to give the name and let's see like whether you're getting any error or not.
Let's see how to make it accept or not. Okay. And the region is US. This I can do it. And the payment services, I will select data lake or Azure files.
First. Anyhow, it is an optional field. You can left out if you want.
Yeah.
This is
And
also
primary workload.
so you only need to fill those details which are marked with as mandatory with the, like asterisk.
So
You
we
can
can
see, right?
leave the performance as a standard, right? Recommended for most
Yes,
scenarios.
yes.
And okay, review and
Yes.
create. Or do we have any next option?
Yes.
Okay. Here in the advanced, I will leave as is for the REST APIs and enable storage account access. And anything else that needs to be hierarchical namespace.
Hierarchical namespace is selected whenever you need to create a data lake storage. Okay, so right now we are trying to create a blob storage, so we'll keep as it is. No, just keep as it is.
But if we want to do it, then we can always come and update it, right?
Yes, yes. When you click this, so the data lake storage will be created instead of creating blob storage. Okay,
Okay. Okay.
so
Okay. And blob storage allow cross-tentative replications. Do we need this?
no, that is fine. can keep this by default. Just try to understand like it is written here access tier. Okay. So as you
Yeah.
can see here, there are two access tiers still written, hot tier and the cold tier. Okay. So by default, whatever the files we are storing in, that will really go on to the hot tier. And what I mean by a hot tier. So basically, there are three kinds of access tier in the blob storage. The first one is hot, second cool, and the third one is archive. Okay, so let's suppose you have some application like e-commerce application where you have some data like product images, product videos. Okay, and you are frequently accessing those data. Okay, you might be storing them whenever you are required. You are trying to access the data from your application. So in that case, your application, your data will be stored in a hot tier of blob storage since you are frequently accessing the data. Okay, so it will be called as a hot tier. Okay, because you are frequently accessing it. Let's say you are anyhow due to some business reason. Okay, let's say you have some e-commerce application. Your product is out of stock. Okay, and you don't need that product image and description now. You need to remove them. So you might be not using those data for up to 6 months, like 180 days. Okay, so those data will automatically move to cool tier. Okay, and it is always pointed by Azure to keep this cool tier. And why this transitioning is happening? Because the data which is stored in the hot tier, it has some access, it some have some storage cost. Okay, and which is higher in comparison to cool tier. So that's why Microsoft Azure is recommending if you are keeping the data in a hot tier and you don't need on a frequent basis, so it will always recommended to move those data to the cool tier because it would have some less storage cost in comparison to hot. Okay, and let's suppose you don't need those data for up to more than 1 year or 2 years. You're not accessing those data, so you can make them archive. This will be the third one. I'll show you where you can see the archive one. Right now, we are able to see hot and cool only because since you're creating from scratch. Okay. Any queries on this?
You
Access
also,
tier?
yes, yes, hot and cool. I understood like a frequently used one and infrequently used one.
Yes. Yeah.
But what is archive? Archive is like,
Archive is like you can say bunch of files which is not being accessed on a frequent basis, but you believe that it might be required in upcoming future. Okay, so that's why you have stored it for your records. Okay, let's suppose I'm just taking example of e-commerce again.
okay,
uh, you have some product images and videos and the product is out of stock now. Okay, but you believe like might be in a coming 1 or 2 years that product will be launched again by the vendors. Okay, that's why you have stored that product images videos whenever the product will be launched again, then I'll just keep this data again on my website. Okay, so that's why you need to archive those product images and data. That's why we have third tier, that is archive tier, and which is like the very cheapest one. The storage cost is the cheapest one in comparison to hot end. Okay, you can proceed ahead, go to the next. Don't be confused with it. I'll show you where you can see the archive tier. Okay, whenever once you created the storage account.
mhm,
Meanwhile, you can just proceed ahead.
okay.
Click next. Yeah.
I think I did create.
No worries, no worries.
It. So we did that. Actually, we wanted to do the networking and the data protection, right? I think I just went
No,
forward.
that is not required. As of now, that they are like by default. So you can proceed ahead for the bill.
Okay. Okay, it might take few minutes here and
Yes.
okay, so this is I want to drink some. And I think I can. So this is just read access here.
Yeah.
So It's a
So
standard.
whatever the details you have provided, that is validated by Microsoft Azure, and now you can, yeah, you can proceed to create it. Just click create.
Okay. And the data protection for now, we have just selected the default ones, right? So this is okay. Then I
Yeah.
can go ahead and create it. So it initializes and then it creates, right? Submitting deployment.
So in the overview section, you can see in the left side, in the overview, there is an option data storage. If you can see below partner solutions, left side only. Yeah, just slowly just go down. Yeah, data storage. Yes, click that. Yeah. So here you can see there are four options are given: containers, file shares, queues, and table. So these are the four types of storage account that we have discussed in the last session, right? So in order to create a blob storage, you need to create a container first. Okay, so just click container here. And again, you need to provide some name for a container. That should be in a small case. Yeah. So you can give any name over here, my container, block, or block container, whatever you want. No, camel case are not allowed. Okay, just click create the below
Do
button.
I need to provide the access level here?
No, that is not required.
Okay. And anything in the advanced?
No, that is for encryption. That is also not required. Just click create. Okay, please go to block container. Just click on the container. What are the container you have created? Yeah, just click on that. So here you can upload any file. Okay, let's click upload button. So a side window will be open up and you can just click browse to any files from your system.
Okay, I guess I don't have any draft files or anything as such.
Mhm.
So maybe I can create a sample draft and then try to upload it. Like I cannot
Okay.
something because I have all the other stuff.
Mhm.
But let me see. Maybe I can try one more.
Any text file, you can just create a text file right now. Okay, that is not much more. Text file or any folder, anything. Okay, PDF,
Yeah.
image, Excel.
Okay, I'm just trying to see if I have a Word is okay.
Yeah, yeah.
Uh,
Word is also work. Yeah, you can go for doc file as well. Just click
okay.
upload.
So draft one, and that's not. Yeah. Okay. So in this blob storage, we can upload any files like text, videos, Excel, Word, or JSON, or any such file in the blob storage, right?
Yes, yes. Yeah. So, see, one thing just wanted to let you know, whatever the files you're uploading into this container, okay. So basically, as I said, you can upload any type of file. Okay. So in order to categorize them, in order to identify them, we have given a general name to all those files. Okay. We are not calling it a doc file, Excel file. Okay. We are calling it as a blob. Okay, so what are the files you are creating? That is called blob. And yeah, you can see the details. It is given all the like it is modified on 10:25:30 p.m. Okay, access tier, you can see the hot tier. Block type is blob. Size of the file is 21.95 KB. Okay. If
So
yeah,
how is
another
it
thing I just wanted
working
to
as
see when yes, please. Yeah, you're saying
yes,
something.
sorry for interrupting. Um, just wondered, it was like, how is it identifying that this is a hot or cold? Like, is that
By
from the
default, yeah, by default, whatever the file you are uploading, that will be go to the hot tier. And how, let's say if you want to change the tier, so how you can do that? Just go to upload again. I'll show you where you can select the option for tier. Okay, yeah, go to advanced section. Here, see access tier option. Just click on this here. So as you can see, there are four kinds of options are given: hot, cool, cold, and cool and cold are similar. So we have archive here as well. So if you want to archive any file, so while uploading the file, you can select the archive or code. Okay, so that file will be gone to that particular.
You said cool and cold are both the same
Yeah.
for infrequently accessed data and some backup scenarios.
Yes, yes, yeah.
So why do we have that option? Like any price
Uh,
difference?
yeah. So earlier, basically, that was not present. Like this is has been introduced recently by Microsoft Azure. Okay. Basically, cold. I'm not sure why, because they both work in a frequent in a similar manner. Okay. So cold is like, let's say you have kept the file between 6 months to 1 year. Okay, so whenever you have exceeding 180 days, okay, so that will be already migrated to the cool tier. But you have just kept it over there for I think for 1 year only. So that will be moved to the cold tier. Okay, so you can say like cold tier is nothing but like if you're just in between archive and cold. Okay, so that duration, time duration is called cold tier. So far, we have discussed about how we can create a blob storage. Now it's time to learn about how we can create a data lake storage. Okay. So the creation process of data lake storage and the blob storage both are similar. Okay. The only difference is that I already told you, like whenever you are wanted to create a data lake storage, you need to select an option for hierarchical namespace. So why need to set that? Basically, the definition of data lake storage is that the data that you are going to store, that will be stored in a hierarchical manner, or you can say in a folder kind of structure or in a directory structure. Okay. So whenever you want to organize your data in a hierarchical manner, then only you go for data lake storage. Okay. So let's suppose this is my PC, and if you can see in this PC, basically every data is organized in some kind of folder kind of structure. Okay, so if I'm just open this Excel content file, there, okay, no worries. So as you can see, this is my service bus queue demo folder, and here the data is organized into hierarchy. Okay, so in order, if I need to reach out this file program.cs file, so first of all, I need to go to the Aman Verma folder, then source folder, then repos, then service bus queue demo, and then I can reach out to the program.cs file. So similarly, if you want to organize your data in this particular folder kind of structure, so that you can also do it. But this is not possible in the blob storage. Okay, so I can show you how you can create this data lake storage. So go to this storage account again, and similar, you need to follow same process that you have followed for cloud storage here. Okay, so let me just give some name here, dev storage account 012, and yeah, just go to next. In the next section where you have advanced section, just click and just go to drop. So just scroll down a little bit. Here you get a option of hierarchical namespace, right? Like as you can see here, there is a name which gives a hierarchical namespace. So it is also written complemented by data lakes to the Gen2 endpoint. Enable files and directory semantics. Okay. So you need to check this checkbox if you want to create a data storage. If you want to create a blob storage, so you can just keep this as it is. Okay. Any queries on this?
No. Continue, please. Yeah.
Okay. And rest everything will be process will be the same. Okay, so we can just directly review and create. And meanwhile, it will be getting created. What I can do is I can create a one blob storage as well, just to show you comparison, like what are the difference between data lake and the blob storage. So I create one more storage account for the blob. So the show store. So our both of the storage account created. This storage account is for data lake, and this storage account for blob storage. Okay. So for the very first difference, you can identify whether this storage account for data lake or whether this storage account for blob is, if you go to data lake storage, you might be noticing there is a change in the container icon. If you can see, this container icon in the data lake storage is kind of cylindrical. Okay. But if you go to the blob storage, you can see the icon is like a folder kind of structure. Okay. Are you able to notice that? Like containers icon? There you have
Okay.
file folder structure in the blob, but in the data lake, you have some kind of cylindrical icon. Okay. So this is the first sign through which I'm just looking at. You can identify this is a data lake storage. And anyhow, in the properties, it is written as data lake storage. Okay. And here in the properties, it is written as blob storage. So the second thing, whenever you are creating containers, let's say I'm just creating container here. My I'm creating container here. My ADLS container. ADLS means data lake storage container. Now creating container here, and here also I'll create one container. My blob container. Okay. So both will look alike, but the few differences are there. If you notice in the container of data lake storage, we have an option to create a add directory, which means we can create a directory, we can create a hierarchical structure in a data lake storage, but you will not get these options into the blob storage. You can see there is no any option to create a directory. Okay. Now you might have question, Aman, we can also create we can also create a folder in this while uploading the blob. Let's say I'm just uploading any files in the blob by browsing it. Let's say I'm just uploading this something like this file. Okay. So here, if I go to advanced section and just keep some folder name like input folder. So I'm just giving the name and click upload. So this file will be uploaded to the folder that is input folder. Okay. So what is the difference between data lake storage? Even in the data lake storage, you can also do the same. You can go to upload folder and upload any file like talent questions here. And in the advanced section, I'd go here and write an input folder. So here also I can upload the it is also uploaded in the input folder. Okay. So now the question is like and it is been asked in the interviews like since we can create folders in both containers and blobs, then what is the difference here? Okay. The difference is whatever the folder that you have created in the blob, those are virtual folders, those are not a real folder. Okay. And what are the folders you have created at data lake storage? That those are called real folders. And how can I prove that? So whenever you are clicking on this folder, whenever you want to do any operation, whether let's say you just wanted to assign access to any other team member of your team or any other people of your storage account. Okay, so you cannot provide access at the folder level. Let's say I just wanted to click on this folder. I just wanted to delete. I just wanted to modify this. Okay, so I'll not do at the folder level. If I click on this three dots, it is not working. Okay, but in the data lake storage, I can do any modification on the folder level. If I click this three dots, see, I'm getting an option that I can rename this folder. I can see the properties. I can generate the shared access signature to assign the access for a on a temporary basis to another team member. I can delete it. Okay, so here you can perform the operations on folder level in data lake, but in the blob we cannot have the like a modification access at the folder level. Okay, so that's why it is called virtual folders. If you need to do any modification, then you have to drill down into the folders and you have to add the individual file. Okay, now you will get off. So there are two major differences in the data lake storage. First difference is you will not in the data lake you will get the add directory option that is not present in the blob, and the folders that you are creating in the data lake it is called real folder, and the that are present in the blob that is called virtual folder. Any queries or concerns on this?
Hey, how can I create the folder? Sorry, I missed that. I only
No
see
worries.
the option to upload. I created the ADL also. Okay,
Mhm, mhm,
data lake, and I created a new container, and in the container,
mhm.
when I try to upload, I see browse the files, etc. That the same option like how I was seeing in the blob storage. But
See,
now,
okay, let's see. Let's see. I'm creating another folder now. Okay, so just click upload. Okay,
Mhm.
go to advanced section.
Okay,
Here you will get an option upload to a folder. If you can drop down, scroll down a little bit.
upload to
So
folder.
here there's a text field upload to folder. Okay, so you have to provide some name here. Let's say I'm just giving output folder. Okay. So whatever the file that will be browsing here, that will be come up into some kind of folders. Okay. So let's say just uploading another file, education template. So that will come up into my upload folders. See, now
Oh,
we got our folder, right? So you can perform this action.
okay, okay. So select a file and you can put directly that into that particular folder that you have provided. Okay.
Yes, yes, yes.
Okay, I just created that. So here I can see the folder, and in the folder I can see my document also, or the file that I have done. And if in the blob storage, when I go ahead and do the same, 1 second, please. Upload, okay. Sorry, my kids are going crazy today. They're not sleeping on time and giving trouble. Okay, so I just uploaded, successfully uploaded. So I can actually see this. Okay. And you said in the ADL, we have an option to share the folder level, right?
Yeah.
So how do I
Here we
do
have
that? Three dots
real
and
folder. So for that, you are asking for data lake storage.
the data lake storage.
Yeah. So for data lake storage, you have two options to create folder. Okay. Either way, you can directly create a folder by just click on this add directory.
Okay.
Just click on this. So name you need to provide. Let's say I'm just giving some output. So without uploading any file, I can create a folder for you. See. Okay.
Okay, directly
Now
we
you
can do, or
yes,
we can
but
have to do it in the upload.
yeah,
Okay.
the blob data is not available. So I'm
Okay.
writing down the difference here. You can check it the notes or you can take the screenshot.
Yeah. Sure. Aman, just give me a couple of minutes, huh? I'll be right back, please.
Sure, sure, sure. So there are three different kinds of blob. Okay. The blob have also some types of blob. So whatever the files you have uploaded, that is going to basically blob. Okay. So blob, this is another the first kind of blob. Like whatever the files you are uploading that will be stored in the blob. So blob is basically used to store any kinds of file. The another kind of file is that is called page blob. Okay, place blob is being used for whenever you are creating virtual machine, but that is not required at the data engineering level. Okay, but just telling you for your information, for your knowledge. Basically, phase block are being used to create a disk storage of a virtual machine. So whenever you're creating virtual machine and you are configuring a disk storage, like as we used to have C drive, right, for our laptop. Let's say if you go to your PC, okay, uh, so here you have some C drive wherever you storing all the program files and all kinds of users and Windows kind of files. Okay. So similarly, you need to create some disk file for your virtual machine as well. So those disk file will be those data will be stored in the page blocks. So this is a second kind of blob. And the third kind of blob is append blob. Sorry for my writing, it's not very good. Okay, just ask me anything whenever you're not able to understand. So other kind of blob is append blob. So append blob is basically used whenever you want to log any errors or message. So for logging purpose, basically append blob is used whenever where any single instance of file will be created and it will keep appended the logs whenever your application is run. Okay. So these are things I just wanted to show you about the blob story. Yeah. In case of any query, just let me know.
Okay. Okay. Yeah. Thank you. We can continue. Yeah.
So if you want to select the if you want to see the where it is block blob and page blob and append blob are there, so you go to the and while creating the containers, you can see this. Please click create container here. Here I uploaded the files, any random files. Let's suppose this one. And you go to section. So here you can see the blob type, right? The first option, blob type. If you just click on this, so you can see the three options are given, whether blob, page blob, or append blob. Okay, so there are three kinds of blobs are there. But you don't need to select page and append blob because whatever the files you're uploading, those always it will go to the blob only. Okay, blob is basically used for the uploading of files. Are you performing any hands-on activity on this? Like
Yes,
on
I'm
your
actually
laptop?
creating, the containers and, the files and these three types. I'm just trying to play around.
Mhm.
Okay. Yeah, I think, yeah, I'm good here with the blob storage.
Okay, here few things are left out. Let's suppose you need to provide the access of your blob storage to another team member, to me. Okay, due to some business requirement, like it is usually happening whenever you are working any in a team and enterprise level of application. Okay, so due to some reasons, you need to provide the access of your storage account to another team member or another people who belongs to any third party organization. Okay, so in that scenario, you are not allowed, you cannot give a full access of your storage account to that person, because if you provide a full access, then might be there is a high chance that the data will be compromised. Okay,
Mhm.
so that is not recommended. Okay, already. So that was it is always recommended. There is one option that is called SAS. In short, it is called SAS, and SAS stands for Shared Access Signature. Okay, so I can add one more word here. SAS stands for SAS stands for Shared Access Signature. Okay, shared access signature is basically gives you flexibility that you can provide the access of your storage account on for a temporary basis or for a specified time interval. Okay, so that in case your data will be compromised, so it will only be compromised for few time, for few period of time. Okay, not for the on a permanent basis. Okay, so so that you can handle those issues. So how you can create this SaaS? So in order to create the SaaS, let's say you need to provide some access. I have to provide some access of my storage account to you. So I will go to the security and networking section here. And here you can see the option shared access signature, right? Just click on that. And once you come up into this, so here you can see there a list of services, a list of permissions are given, like to who, what kind of permission you want to provide to that person, whether you want that person can read, write, delete, list. Okay, add, create, update, process. So I don't want to, if you want to provide full access, okay, for some time interval, okay, so you can do that. But I just only that person to read my files, don't want to modify anything, so I just uh, keep this boxes unchecked. Okay, I just mark this box unchecked. So whatever the access I just wanted to provide him, I just wanted to check those only. Okay. And what kind of files you want to provide access. So I just wanted to, if I just wanted to allow for blobs only, so I uncheck this file, queues, and tables. Okay. And the third thing that I need to configure here, I need to configure the time. Okay, I need to specify like for what time period I just wanted to provide access. So right now it's 8:23, and the end time is 4:23. Okay, so this is for 8 hour window. I'll provide the access. Okay, post 4:23, that person will not have the access to my storage account. Okay, so in this way you can make your you can secure your data. Okay, even if you can reduce the timing for 12, 30, you can say 00 PM. Okay, so I can only provide for 4 hour access. If within 4 hour they will perform their action. If that will not, so their access will be lost out. So in this way, you can just only provide the 4 hour access. If in case that will, anyhow your storage account will be compromised, so it will only compromise within this 4 hour window. Okay. Any queries on this?
And also the routing tier here,
Mm-hmm.
it says
Yeah.
by basic by default, but what are the other options we have? The networking
Yes, yes,
and
yes.
the.
So let's suppose you only allowed to some specific IP addresses. Okay, you
Mhm.
don't want to allow. So you like basically Microsoft Azure, it gives you flexibility. Not only just you can restrict the access to a particular time period, but you can also restrict the access to specific IP addresses. So let's say you know about the IP addresses of that particular person. Okay, so he might be like, let's say you are providing access to me. Okay, for a specified period of time, but I can now reshare that those access to any other team member, to my other team member. Okay, so that is not a good thing, right? Like you have trusted me and you have provided access. So why? How could I like share that request to another team member? Okay, so in that case, you can also restrict the particular access with that IP address. So here you can specify my IP address. You can ask for my IP address. I just can you share your IP address, please? So you can mention those IP address over here. Okay. So only I can access that your storage account, and for this period of time, no other person can access those storage account. Even I would try to say that that would not be visible to them. Okay. The second one, and the next one is allowed protocols. So since you are trying to secure your data, okay, so it is always recommended to go for HTTPS kind of protocol, not HTTP, because HTTP is not a secure protocol. It is not being access to the uh, what is name over there? What this that is security layer. That is called. I am forgetting the name. Yeah, SSL certificate. Yes. So HTTP protocol do not come up with SSL certificate. Where HTTPS is the secure one. That is why its name is postfixed with the S. Okay, which means it is coming up with the SSL certificate. So that's why it is always recommended to select the options for HTTPS protocol only. Preferred routing tier is, so whether you want to allow public internet routing, whether you want to allow Microsoft network routing, but these things are not recommended. That's why by default it is always selected for basic one. Okay. Signing key, you can forget about this. Okay. Now once we are done with this, let's suppose why it is not coming up. Uh, Let me check. We should have this.
So this option we have shared access signature in both the data lake as well as the
Yes.
block storage.
Blob storage. Yeah, because the shared access signature is available for storage account, regardless of what services you are sharing. Okay, it is available for storage account. That's why you have the option whether you sharing for blob or file. So if you only want to share blob, so you need to uncheck. That's what I'm saying, right?
Okay.
If you
Okay.
want to allow that person can see your blob and file tables as well. So you can share the files as well.
Okay.
Right now, I'm trying to figuring out why this button is not being enabled. Yeah, it should be coming up.
Let me try.
You can meanwhile you can just do the hands on.
Yeah.
Yes, yeah. Now it is coming up. So I just wanted to allow the person to see my blog. Just try to focus on the screen, please, for a second, please.
Okay. Yeah.
Okay, so I just wanted to allow that person to see my blob since I have checked the blob only. Okay, and which resource type I just wanted to see him. He or she can see my containers. I have given the permission for read, write, delete, list, add, and create. Okay, I have uh, disabled the update and process. Okay, so even if you can just wanted to no, don't want to allow that person to write, you can also uncheck the write. Okay, now, I just wanted to enable the deletion of version. So once the this particular thing will be done, you can also delete the version. Okay, so you can specify the time. This is will be 8-hour window. Allowed IP address, I didn't specify that, but that is optional. You can specify if you wish. If you wish, I'll only allow the HTTPS protocol. And why it is HTTPS protocol? Basically, whenever you're generating the SaaS, it will coming up as a HTTP URL. Okay, and then you are that URL you can share to that person. Using those URL, he or she can access your storage account wherever it is required in their application. Okay, so once let me just click on the generate SaaS. So it will generate some connection string and the SAS. Okay. So two things that will be generated, a SAS token and a connection string. Okay. So let's suppose you need to use your storage account and if that person needs to use this storage account in their application. So they can use this connection string. Or if they want to use this SAS URL, you can just copy this and they can use wherever it is required. Okay. So URL have both a SAS token and the connection string. Okay. So they can use this particular URL in their application. So this is called SAS token. So it have all the details. As if you can see on this, so it have all details. Like it has been created on 6th September 2024. That is a start date, ending time. That is 10:58. It is a UTC. It is given, and it is start time is 6/9/2024, and that is started at 2:58 UTC. Okay, that is for 8-hour window. It will be valid out. Okay. So this is called SaaS. Okay. This is a very good feature to provide access of your storage account to any third party application. Apart from this, let's suppose in the within Azure, you have created some application like Logic Apps, Data Factory, or Databricks, where you want to store your wherever you want to use this storage, wherever you want wherever you want to use your blog files. Okay, so how we are going to connect your storage account to Data Factory? Because Data Factory don't know what kind of storage account you have created, what kind of files you have uploaded. Okay, so in order to use your storage account in your Data Factory, you can use this access keys. So whenever we will be learning about Data Factory, whenever we will be discussing in upcoming sessions about Data Factory, Databricks, we will be using this access keys. Okay, you need to click this show. So there are two keys are given: primary key, that is key one, and secondary key, that is key two. Okay, so you can use any one of them. Okay, it is not mandatory that you can use only one. So you can use any one key, and you have to specify in the Data Factory that this storage account you want to use it. Okay, so this is through access key you can communicate through connect your different Azure components with your storage account. Basically,
Okay.
this is to authenticate your storage account for that particular Azure service.
Okay. So in the shared access signatures, when you generate the SAS token, that
Mm-hmm,
token is available in your access key, where you
mm-hmm,
have two set of keys, key one and key two, and you can
mm-hmm,
share either one to your
mm-hmm.
teammates. So once they have this key access, I mean added into, how are they going to add this? They are going to add this key in their shared access signature, or
No,
Like for
no, no.
example, now I
Shared
create.
access, don't confuse with the shared access signature. Okay, shared access signature is a different thing. Whenever you want to provide any third party organization or third party application, okay, and access keys are basically used whenever you need to provide the access of your application, authenticate and of your storage account within Azure. Okay,
With,
so that within Azure, if you want to connect any application, and let's say you have created a data factory in your Azure account, okay, and you want to connect your Azure data factory with your storage account, so in that case, you'll be using the access keys.
Mhm. So we need to, like for example, in your screen you have this key, right? Key 1 and key 2. If you share the key with me, then I need to
Mhm.
go to my access key and then add it here in the access key, or where do I
No,
go
no,
to?
don't. Okay, just forget about the access keys. Whenever we be discussing about other application like Logic App, Data Factory, I'll show you what is the use case scenario of the access keys over there. Okay,
Yeah,
so lots
I'm
of
just
services are.
trying to see, like, how are we going to set it up so that they can, they have to, like for example, when you're sharing it with the teammate, right? Like they have to provide or add this key or something so that they can able to access the blob storage for this example, right? Are you able to follow me? Like what I'm trying to say, like for
I would say forget about
trying
the
to.
access key. You understand? You got this idea of shared access signature, right?
Yes, shared access one, I got it. And what is the purpose of it? Also, yes. And we want to provide the permission, the allow them to see what services they want or up to what time or all these
Cool.
things. And we're trying to generate the key, right? Uh,
Beautiful. Cool.
so from here, what is the next step? How are we going to share with them and how are they going to provide that to get access to the particular folder, file information and all that?
They actually see whenever you are generating the SaaS, okay, so this
Yes.
will be, as you can see here, this will create a proper HTTP URL for your storage account. Okay, so this will act as an API key, or you can say API. Okay, so these APIs, you get the person who is just using this, okay, they need to consume this particular URL using their in their application. Okay, so is their problem like how you are going to do it? If they are using REST API, so there are certain protocols, the certain
Uh,
rules and certain steps over there. Okay, in order to consume that. I'm not going to deep dive into that particular process because that is an entire session on that. Okay, so basically they have some certain rules. Using
oh,
these URLs, they can consume your data and they can just fetch your data from your storage. So whenever you are getting data from different data sources, okay. For example, if I'm taking a example of Amazon websites. Okay, so here for the Amazon website, basically Amazon is central repository website on which different vendors are listed on their products. So here the vendors would be from like northeast India. Here it could be West India. Here it could be South India. So from different zones. Okay, not just one particular part of India only, but also different zones of the entire world. Okay, so each of the things like product will be listed onto the central repository. So in the data world as well, basically we are going to receive data from different sources. Okay, it doesn't matter like it is not necessarily like you'll only be receiving some structured data, some SQL DB only. Okay, it could be CSV as well, it could be JSON as well, or it could be Parquet file as well. Okay, the data sources could be different depending on like what kind of data you're sourcing, whether you're sourcing data from any let's suppose POS point of sale or some kind of just putting out the data from the website. So in that case, you might be getting JSON. You're just pulling the data from some web application, so you can get the data in a simple form. Okay, so those data, basically, there popular operations are being performed. That is ETL. Okay. ETL stands for extract, transform, unload. So first of all, we will extracting those data, then we'll be transforming it into a suitable format, and then we will load those data into our data warehouse. So this is our data warehouse, which in short we used to call it DW. Okay. So those data will be loaded out into our data warehouse in a form of structured data. Okay, I just wanted to notice over here, whenever we're talking about the data warehouse, so all the data which are available in the our data warehouse, those all are structured data, not unstructured data. Okay, so your data sources could be structured, semi-structured, and unstructured. Okay, but in the data warehouse, what are the data you're available? Those will be all data will be structured format. Okay, so the first difference is only like your data sources, different data sources could be your unstructured, semi-structured, structured, and structured. But data which are available in data warehouse is also it is always a structured data. Okay. Post that this data is available now to these data will be consumed by different kinds of users like data analyst, data scientist, and BI users or BI developers. Okay, so these data will be consumed by the different processes. So this is the proper, you can say, end-to-end flow which are being performed by data engineers. So the data engineers are responsible to extract the data from different sources, transform them, and load it to data warehouse, and then made the data available for data analysts and data scientists and for BI users to take the business decision. Okay. So this is the entire what are the process and mechanisms are involved in order to make the data available in data warehouse. Those things are performed by data engineers. Any queries or concerns till now?
No, man.
Okay. Now let's see what is the difference between this. Yes, one more thing. I'm just leaving it here. Basically, whatever the data analytics being done into the data warehouse level, those are called OLTP. I think we have discussed in the last session as well. OLTP, not this OLTP, is OLAP. That is online analytical processing. And what are the data analysis or what are the data extraction is being done at data source end, that will be OLTP. That is online transactional processing. Okay. Now we will see the difference between data warehouse, or you can say the between the data sources, or you can say that in the SQL database and in the data warehouse. So we cannot consider like every SQL database will always be a data warehouse only. Okay, though in our data warehouse all the data are stored in a structured format. It doesn't mean like every time the data warehouse that you are using, that will be a Azure SQL database or some SQL database. Okay, that is not a necessary thing. So basically, there are some popular tools are available in the market which are you can use Azure Data Warehouse like Redshift. Okay, these are widely used by the AWS developers. Then the third-party tool also available like Snowflake, which is most now more popular. Snowflake, and in Azure we have Azure Synapse. Okay. So basically, Synapse is being used as a data warehouse. Most of the mentioned in the real life scenario, where we in the Azure Synapse, basically we have inbuilt, you can say, its own SQL database available. Okay, so we will be using this SQL database as a data warehouse. Now, talking about differences between data warehouse and SQL database. So here we can talk about this. So let me just write it down. SQL database over here. Or you can say data sources. Okay. So first difference we have already talked about. Whatever the processing will be done at the data source end, that will be OLTP. That is transactional. And whatever the data processing done in data warehouse end, that will be OLL. The second difference is in the SQL ended, like whatever the data query you'll be doing in the data source and a SQL database, and that will be in the real time. Okay, because no one is going to wait to execute the query, just to wait for the execution of query for longer time, like 1 hour or 2 hours. Okay, or you can say more than 50 minutes. Anyone not to wait. Okay, that's why here the query are like highly optimized to get the data in the real time. But in a data warehouse, basically, this is not required in a real time. You can like here people are like quite Like they can wait, they can expect some delay to get the data. Okay, so not in real time. So you can get the data in some more than 15 or 20 minutes. Okay, if you wanted to take the notes, so you can take it. Okay.
Yeah, I am. Yeah.
Okay. The third difference is basically whatever the data you are querying over here in the SQL. Okay. So basically the volume of data. Okay. Whatever the data you are querying, those will be not much more. Like there will be very smaller volume of data. It could be in 1 GB, in a GB, or uh, might be in the TB as well. Okay. So data will always be available. Data size will always be available. Size or volume, whatever you can say, volume will always be available in GB. Okay, so that will be is GB or TB. GB means gigabyte and TB means terabyte. Okay, but whatever the data is available in data warehouse, in that volume of that data size will be high. Okay, here the volume of data, most probably it you could get the data in petabyte or terabytes. Okay. Terabyte or terabyte. So these are three basic difference that you should know. Okay. Basically, in the SQL database or data sources, we used to get real-time data processing. For example, I'm just taking an example of like let's say you visiting some retail store to purchase some groceries for your home. Okay, now uh, whenever you just wanted to go for billing at a billing counter for just take a bill of your what are the products you have purchased so far, what are the products you have added into your cart. So if the retail stores or the cashier was just trying to make a bill for you, if it's POS, or POS means point of sale machine, which they were using to generate the bill, if that will not be able to fetch the data in real time, if data is not getting fetched in real time, so you might be getting irritated, like why is POS not working, because every product have their own price. Okay, then that particular cashier need to uh, put some details in your bill, like what are the products you have purchased, what are the data products offers are there, how many discounts are given. Okay, and what is the label of the product, so everything. It's so if the data, those data is also be might be some stored in some SQL database or some kind of NoSQL DB. Okay, if the data is not being fetched in real time, so it will, the POS will not be working, and you will be getting frustrated, like why I need to just go to home quickly, just have some other personal work. So you might be getting irritated and you will leave the retailer store in a no time. Okay, but in the data warehouse, and that is not the case anyway, because that is not being used by the end user. These are being used by the data scientist and data analyst and BI user. So they can just wait for some time to carry the data, and anyhow they are querying the large amount of data, the petabyte, terabyte, not just a smaller chunks of it. Okay, so this is the example you can take it. If you have any query, just let me know, please.
Okay. No, no. Please proceed. Yeah.
Okay. Apart from this concept, basically there is one more thing just wanted to tell you. There's a might be you might be heard about one term. It is data mart. Okay, so we have so far we have discussed about data warehouse and SQL database. But what about data mart? What is data mart? Okay, so data mart is nothing, but you can say it's a subset of data warehouse. So what does I mean by subset of data warehouse? Okay, so let me just put a proper definition here. Data mart. While working on a real life scenario, you will be heard about this name, data mart. Okay. So again, I'm taking an example of retail store. Okay. So basically, whenever you are fetching the data, okay. So let's suppose these are the different vendors from different zones, from different regions of a country or world. Okay, they will just trying to sell online, just trying to sell some at some city malls, or you can say big shopping complexes. Okay, so in that case, let's suppose I just wanted to sell my groceries through big basket, through some other like a big tech startup. I'm not sure like what startups are being used in the US, but in India, Grofers, Big Basket, and Blinkit are nowadays very popular. Okay, so if anyone is trying to sell their products, grocery products on online or through these channels, so what they can do is, first of all, they will list out their products. Okay, and whenever they are required, that orders will be put on for their products. So those orders will be fetched through data warehouse only. Oh, sorry, on the warehouse. Okay, on the physical warehouse. Here in the physical warehouse, after just keeping this all this product into warehouse, it will be now send out to data mart. Okay, that is a mart. You can say the shopping complexes wherever it is required, it will be sent out. Okay. Similarly, the data world as well. Okay. So whenever you are getting some data from different data sources, first of all, it will be keeping on into data warehouse, and then after this, it will be sent out to data mart. So data mart is nothing but you can say it's a subset of a data warehouse. So what, like there might be some question, though we already have a data warehouse, and these can be easily consumed by the particular users like data analyst, data scientists, and BI users. So why we are having, what is the need of this having data mart? Okay, now I just wanted you to understand here. Let's suppose I just wanted to uh, let's suppose like here we are having different sources. Okay, so just taking about the example of retail stores only. Okay, so might be there is some that it depends on the zone to zone. Let's suppose this is my zone 1, zone 2. Let me just rename this everything. Zone 2, zone 3, and zone 4. Okay, now in the if I'm talking about just India only. Okay, so the like like in different zones of the India, like people are have their own choices, their own lives, and their own preferences. Okay, might be in the North India, the people are not like very likely to buy rice. Okay, but in the South India, they might be are having likely to buy rice over here. And the quality of rice is quite different from zone 1. Okay, in the South India, might be having a different quality of rice in compared to North India. Okay, so basically the retail owners who are just running their store, they need to provide those products only corresponding to their customer. They cannot just put all products, common products, in all their retail stores. Okay, so as per the customer needs, they will put down the product in their stores. Okay, so here let's suppose you want to know from the zone 1 whatever the different products or what are the dairy products are being sold out. Okay, and in the zone 2 you want to know like what are the different you can say uh, how many breeds are being bought out from this particular region of India, or this particular person, what is the demography, or what is the behavior of people who are purchasing this particular product. Okay, so basically in all kinds of data are available in your data warehouse. Okay, here it is a mix up of data is available, but whenever you just want to categorize, just segregate the different kinds of data in order to answer the questions of BI users, data scientists, and data analysts, we are segregating we are categorizing, or you can say we are segregating the data, different data into a smaller chunks. That is called data mart. Okay, so one data mart could only have specific data or data related to some specific category. Might be it would have some data related to customers only. Okay, another data mart would have the data related to staff which are working in the retail store, or employees which are working in the retail store. Okay, like which is the person taking more leaves, which is the highest performing person, which is coming on time or in time, which is being absent for 2 to 3 days. So everything data will coming up into this one. The third one will have data related to products which are being sold out into retail stores. Okay, so these will make a specific. It will just categorize, but all these data will be available in data warehouse. Okay, but whenever you just wanted to categorize into different data sources or different categories, so you can just keep them in a data mart. So those are called data mart here. Any queries on data mart?
Not following. Yeah.
Basically, these are the basic theory. I just wanted you to just know so that you can able to distinguish between data mart, data warehouse, and SQL database. So usually data warehouse, either in the if you're using Azure Stack, so you will be using Azure Synapse that we will be learning in upcoming sessions. Okay, how we can use Azure Synapse as a data warehouse. Might be some other organizations are using some third-party applications as well, like Snowflakes. Okay, so the functionality will always be same, so don't worry about it. Okay, sometimes if the if any organization do not have much more data value, okay, so let's suppose some organizations do not have much more data value, they might be getting the data in some GB, 10 GB or 20 GB only. So in that case, they would not configure, they would not create any Azure Synapse service. They're not using some Snowflake. So in order to save the cost, they will use the SQL data base only. That is Azure SQL database. Your SQL database as a data warehouse. Okay, so Azure SQL database is also have a capability to store data in kinds of, let's say, 10 GB, 20 GB, or 30 GB. Okay, so if your data value or data size is not much more enough, so you can use the Azure SQL DB as well as a data warehouse. So don't be confused with it, like why, since Azure SQL DB is different with a data warehouse, so why we are using as a data warehouse one. Okay, so data warehouse is could be anything, any data destination or any data storage where you can store the data in a structured format. Okay. Any queries in the differences between data warehouse, data mart, and SQL database?
No, no questions.
If you want to know the difference, I can show you the characteristics of data mart as well. Okay, so basically, I can write it down over here. Let me just write it down so it could be helpful for your notes. Just write characteristics. So first characteristic of data mart is, as I said, it will be highly specific subject area. Okay, which means either it will have a customer data, either it will have product data, either it will have a store related data or zone related data. So it will have a highly specific subject area. It is not a mix-up operator. That's why it is short. It was called a highly specific subject area. Okay. Second characteristic is basically you can since the data size has been reduced while just putting some specific subjects, so your query performance will be high. Okay, so you can get the data in the real time. So you can also get a high query performance here. Just tell me wherever you are not able to understand my writing. And you can say what I can say. Okay. Yeah. So another thing, like you can see, in other words, like it is a summarized view of data warehouse. Okay. Data mart are the summarized view of data warehouse. Yeah, this is the three major characteristics you can note it down. So in case if it is asked in the interview, you can specify these three different, then it would be enough.
So basically, this is also like our Azure Synapse only, right? The views that we have in the Azure Synapse.
Azure Synapse, basically that is a different thing. Azure Synapse is basically it's a wide thing. Okay. So in upcoming sessions, we'll be learning basically ADF are being used for data ingestion. Okay, where you'll be ingesting data from different sources to your data warehouse or data lake storage. ADB, that is Databricks, Azure Databricks are being used for transformation.
Okay.
Here you will be doing transformation using some PySpark code. Okay, here we'll be doing some PySpark code for data transformation. And Azure Synapse is a not third party, it's a third kind of service which have the capability of both Data Factory and Databricks. Okay, so some organization might be preferring to implement their data pipelines or data architecture by following this path. Okay, by following, they will be having might configure data factory for data ingestion. Then they will store in these data into data lake. After storing the data lake, they will do some data transformation through data bricks, and once the data is available through the database, they might store in some SQL DB, okay, for data warehouse purpose. Now, from the SQL DB, they might be creating some Power BI reports or some data visualization. They can do it, okay, either through Power BI or certain Tableau. Okay, but as I said, Azure Synapse have the capability of both data factory and Databricks. So if you want, okay, if you got a chance to create a pipeline, create a data pipeline from scratch, so what you can do is, instead of just configuring Databricks and ADF, you can have Azure Synapse, a single service that is going to work as a both data ingestion, which can be used not just a data warehouse but also a these three, all three parts can be done by Azure Synapse in the single-handedly. Okay, so Azure Synapse can be act as a data ingestion tool as well, can act as a data transformation tool as well, and also can act as a data warehouse. Okay, so all these three activities can be performed to the Azure Synapse. Not only this, Azure Synapse have also capability to integrate to the third-party tools like Power BI. Okay, so it have integration capability to integrate with the Power BI as well, where you can use this integration to generate some dashboards and reports.
Okay.
Okay.
Mhm.
Now, how the Azure Synapse can act as a data, see how the Azure Synapse can act as a data ingestion. So basically, similar to ADF, Azure Synapse have some canvas, okay, where you can drag and drop some activity to perform some data ingestion. It also have a canvas to write some PySpark code for data transformation. So here also you can use the PySpark code, okay. And how it is act as a data warehouse, basically in the Azure Synapse, whenever you be learning about it, there is inbuilt, whenever you are creating Azure Synapse, so along with Azure Synapse, a particular SQL DB, inbuilt SQL DB will be installed, or will sorry, not DB, it's a DB. Okay. SQL DB will be getting installed or getting configured or getting deployed along with Azure Synapse. Those SQL DB which is associated with Azure Synapse will act as a data warehouse. So that's why all this capability can be consumed by the Azure Synapse. That's why you might be seen in the job description. Okay, organization either using Data Factory and Databricks, or they might be using Azure Synapse plus Python or PySpark. Okay, Azure a required skill in their JD. They might be mentioned. Sometimes you also get like must have skills like uh, Synapse, and good to know skills like ADF and ADB. Okay, so they basically mentioned these services. So if you have some basic knowledge of ADB and ADF, that is also enough. Or you can say must have skills of ADF and ADB, and good to have skills of Synapse. Okay, so they are just complement to each other. Either way, some organization, not only this, some organization also use all the three services. Okay, so it depends on organization to organization, like how they are preferring to work on it. In some organization, you might be found. Let me just show you what part. Even in my organization as well, they are using like okay. So in my organization as well, like they are using ADF for data ingestion and Databricks for data transformation and Synapse just for data warehouse. Okay, so it depends on business to business how they are just wanted to implement it. So because they are just incurring some cost, so if you are willing to pay it for all the services, then that's completely fine. You can do that. So that's why it is recommended to have these skills in your skill set to get to know about the ADF, ADB, and SRLD because these are the major players in the data engineering. So if you're not using, even if you're not using the runtime stack, sorry, not runtime, if you're not using Azure stack, so complementary each of the role, okay, you should have some tools in your skill set. Like for example, if I'm talking about this is ADF is used for data ingestion, it's a data transformation, and this is for data warehouse. So if you are not willing to work on Azure stack, so what you can do is you have to look for some data ingestion tool. So I guess Airflow can be used for data ingestion. So there's a third-party tool called Airflow. For data transformation, nowadays Databricks is will only used. Okay, so Databricks is a third-party tool. Basically, it is associated with the Microsoft Azure and also with Google Cloud Platform and also with AWS as well. Okay, so Databricks has a partner with all kinds of cloud service providers. So you definitely are going to work on Databricks if you're working on data engineering. Okay, so Databricks you can say it's a popular or it's a must to have a skills. It doesn't matter whether you're working on Azure Stack or not. And for data warehouse, you should have Snowflake. Okay, so these things you need to have in your skill set. Okay. I'm just showing you some alternative as well. Any queries or concerns on this?
No, I'm just not familiar what the airflow is and the
Mhm.
snow.
I'm just giving you an alternative. Like, let's suppose you're not following Azure Data Engineering. Okay, if you are not following data engineering to the Azure stack, so you might be heard about, let's suppose, if you're just appearing for data engineering. So if the organization is not using Microsoft Azure Cloud, okay, so they might be using some third-party tool like Airflow for data ingestion and for transformation Databricks and for data warehouse Snowflake. Okay, so these are different tools or alternatives of each step. Okay, just wanted to know you for your knowledge. Okay, nothing specific.
Yeah,
I hope
okay.
the question you answered.
Yeah,
Okay,
I
yes,
really
please.
appreciate if we can have, these session by session, like any, uh, you know, um, she, like assignments, or I know I'm again talking about the same thing, but it would be nice if I have practice a set of questions or something, with the multiple choice with what we've been covering so far. So that would be easy for me to, revise and,
Okay,
prepare for the certification. You know what I'm trying to say? Like practice and
got
all that.
it. Mhm. Okay, no worries. We'll follow the same path what you are suggesting. That's will also be good. Okay, so I'll be putting out some questions. I just like, might be I'll be mentioning, but I'll not be highlighting. Okay, so going forward, I'll be highlighting as well. Like this will be asked in the certification exam or also in the interview questions as well. Okay, so
Yeah,
you can make
yeah.
a note of it.
Okay. Okay, because
Okay,
again,
so this, yes, yes,
yeah.
please go ahead, please.
No, I'm just again trying to, if not, like I have to go online Google and try to, find the set of questions that I can, practice question
Mhm.
that nation, So I'm trying to see if you can provide me some info that would be also helpful, like
Uh,
why.
For certification, I can provide you practice paper. You can just go through it. Okay, so those are not just practice paper, but that are the previous papers of certification. Okay, so I can just provide that to you. So you can just solve those papers, and if you have any query, you can ask me, or because that will be very helpful while whenever you are appearing for certification exam. Okay, there are three major players, and also some supporting tools are also available. So in the if we talk about just for ADF, okay, so if we dedicate completely on ADF, like I just wanted to master ADF, okay, so at least 1 month will be required to learn for ADF only. Okay, if we just completely focusing on ADF as well. So each of the tools will take at least 1 month. But since we are just trying to compose this particular all the tools in the this training within 30 to 40 hours, so definitely I'm not going to like cover up in depth each and everything. Okay, but yeah, definitely up to intermediate level I can explain you. Okay, because since we are need to complete it anyhow in the 30 to 40 hours or 50 hours, max to max 50 hours. Okay, so it will be still 2 month or 2.5 month training. Okay, that we need to cover up. So you cannot expect that you will be just learning in 30 days and you get the certification that you are just able to follow the uh, interview and just get the data engineering job. This is not like a single thing. Okay, yeah. If you're learning just for ADF, that is Data Factory, then definitely we can cover up in detail, in depth, like up to advanced level, uh, onto like you can say in 1 month. Okay.
Okay. Okay. If you can please, later, when you get chance, if you can email me the set of, practice,
Sure,
uh,
sure.
be really appreciated. Like the days that we don't have class also, right? Then I can
Mhm.
go and practice.
Sure, sure. I can share you. But the thing is, like, why I'm not sharing so far because I have, I think, mentioned in the demo class as well. Basically, I can share you the practice paper because I've not shared yet because until unless we'll covering all these components, we will not be able to get anything over there. Okay, because the questions are quite high level. So until unless you will not be able to complete the training, you will not be able to find relatable. Okay, everything will be bouncing over the head. So you might be blaming me because like I'm not getting anything in the certification. So that's why I'm not shared to you. So I recommend you to please complete the training. Then you can just go for the making exam. Okay,
Okay.
a practice paper. What a shame. Because in between, if I share the certificate, you might be getting confused like what are these area, what is integration runtime, what are copy activity, what is link services, because those things are not being covered here. Okay, we'll be covering in the upcoming sessions. So in order to find relatable, I would recommend you to first try to follow the activity which are being like discussed in the sessions. Okay. So right now we're discussing the theory part only. But yeah, going forward, whatever the activity we'll be discussing, please follow the activity on the same day. And I'll try my best to allow some time in the session itself to so that you can just show me your screen and just try to replicate the same process. If in case you got stuck, so I can help you on this. Okay. These things I can do for you. So as I earlier said, like basically data factory are being used for data ingestion. Okay. So it's a very good tool. You can say no code based tool where no coding language is required to have a hands-on data factory. Data factory is basically used for data ingestion, or you can say moving the data from one data source to another data source. Okay. So you might be having some data source, some on-premise that is on a private network on-premise, I believe you remember, like we have discussed in the very first session, what is on-premise? On-premise is a private network which is owned by the organization itself. Okay, they have their own servers. They might be using the data. Earlier, they might be operating the data on their private network only. They have their own set of servers. But now, since everyone is just migrating to the cloud, they just wanted to grow their business. They just wanted to migrate and move the data to the cloud. So from private network, how they will be migrate the data, so they will be migrate the data using the data factory itself. Okay, and the data source could might be getting some from REST APIs. Okay, REST API is a kind of service through which you can get the data. Okay, you might be having data in a format, some CSV format somewhere else, some Parquet format. Okay, so all these data could be migrated through one data sources to another data source. Might be you'll be storing some in a data lake or in blob storage. Okay, so those things can be happened through the data factory. So data factory, you can say, is a kind of Azure service which is used for data ingestion from one data source to another. Okay, now there are different things. Okay, now I just wanted to show you some demo today itself, like how you can create a data factory. Okay, so for that you need to visit your portal, that is a data Azure portal. Just search for data factory here. So you'll be getting options like data factories. Okay, just click on this and create data factory. You need to fill the details like resource group, name, region. So let me just add one resource group here. Demo Azure Data Factory. Name I need to provide here. So ADF demo learn. You can give any name over here. There is no restriction on this. And region I need to select nearest to me. It is Sentinel. Okay, so the data factory name is already taken, so I can give some unique name over here. It is yes, it is not accepted. And this currently we are having only version 2 of data factory. Okay, so nothing else need to be changed. Everything just keep this by default. I just click on create. So today I recommend you to try to create SQL database. Just try to follow the previous session recording. Okay, just try to create SQL database, data lake storage, blob storages. I hope you have created blob storage, right? Because it's been a long time since we have discussed about the blob storage and data lake storage.
Yes, I have. And now we are creating the data factory here. You're creating this, but we haven't tried creating the data warehouse also, right?
Data warehouse is just a concept, Kalyani. Okay, it's not any kind of service. Okay, if you search for data warehouse here, so there is no any service like from the data warehouse. Okay, so basically data warehouse is a concept, okay, which you can implement using the SQL database or Azure Synapse. Okay, so we will be doing this data warehousing. We will be implementing the data warehousing with the Azure Synapse in upcoming sessions. Okay.
Okay.
So that's why we are covering the theory part. So data warehouse just a concept. Okay, like data ingestion, data transformation is just a concept in the data engineering world. So data warehouse is also a concept. Okay, so since we have created data factory, this is a dashboard of data warehouse. Sorry, data factory. I just got a hangover of data warehouse. Okay, so here we can see the resource group, subscription name, subscription ID, but there's nothing come up. Okay, so in order to work on the data factory, you need to launch the studio or workspace for your data factory. Okay, so in order to launch the studio, you can see the big button of launch studio. Just click on it, and so studio will be opened up in a new tab over here. Okay. So in the data factory, basically you have different kinds of tools are available. As you can see in the left side, first of all, we are having a home button. Okay, so the home section you can explore these styles. Like if you want to learn it, like how you can ingest the data using the copy tree, so you can explore it. As you know, this is for beginners friendly. Okay, just cancel this. How you can orchestrate. So these are tutorials. You can say it's a code for tools. Okay, so it will ask you to do some instructions. It will give some instructions to perform some activity. So you can perform it just to get to aware about the data factory. Okay. So coming back to our topics, basically there are 3 to 4 major tools are available in Data Factory. First one is home. So if you want to just go to your dashboard, to the home dashboard, you can just consider dashboard by just clicking on home. The second tab is author, which is called author mode as well. See the author mode, you can perform any if whatever actually you will performing, whatever the data transformation will be doing, that will be done in this author mode. Okay. So here in the author mode, you can just click on the trigger to create a new data pipeline. You can create a data set, you can create a data flows, and you can also write it out from Power Query. This is your canvas on which you will be drag and drop activity which will be required to do data transformation or data ingestion. Okay. So we will be covering each of the things in detail in upcoming session. Okay. Just giving you an overview right now. Okay. So don't worry about it. If anything is just going over the head. Okay. The third tab is for monitor tab. So here in this particular area, you will be able to see like how your data pipeline is performing, whether it is getting succeeded or getting failed. If it is getting failed, then what is the issue behind that? Okay, what are the triggers are being executed? What is integration runtime you have created? So as of now, we have by default one integration runtime, that is Azure integration runtime. So how many integration runtimes are there? Those will be covering in detail in conversations. It is from tomorrow itself. And what are link services? How many link services are available? Those things you can see over here. Okay. So this is the manage sections where you can see the link services, integration runtime, RM templates, kit configuration, and many more things. If you want to explore some videos and tutorials, you can also go to this learning center section where you can get a tutorial. Just click on this, so it will open up some intro videos, intro documentation for it. Okay, so you can also explore this method of documentation to learn about more in our data factory. Okay, so I would recommend you to just go through the session, try to create data factory, go try to explore each and every tab, whatever you need, and try to understand. Okay, if if you're not able to get it anything, just don't worry about it. Okay, just anyhow by tomorrow we'll be covering each of the topic in details. Okay.
Okay. Okay, I will go ahead and try creating the data
Yeah.
factory.
Also, if you missed out any of the previous session, I would recommend you to please try to do at your own, like creating SQL DB, creating data lake storage, creating job storage, because now those, as I said, those are the supporting tools. Okay. And now going forward, we will be taking the help of those supporting tools while learning Data Factory, Databricks, and Synapse. Okay. So
Mhm.
you can see those are the like basic thing. Okay. Now we're just heading from basic to intermediate, and then we'll be heading to intermediate to advanced. Okay. So this will be getting a quite tougher to understand. Okay, so it's quite difficult to understand. So I just need your attention in the upcoming sessions a lot. Okay, so that's why when you just perform the all the previous activity that we have discussed so far.
So I'm curious, like how much code do we need here moving forward? Like like in a data factory, creating the pipelines or running any of these linked services or any such thing. How much coding do we need to add, like notebook, queries and all
For
that?
for Data Factory, you don't need to know about any code. Okay, so this is a completely no code based tool. You can say no code based application. Yeah, if you have some basic SQL knowledge, that would be great. Okay, that will be good to have. But that's basic only. Okay, not just a very advanced level. If you have advanced level, that's fine. Basically, every data engineers are expected to have advanced level of SQL knowledge. Okay, so if you have SQL, if you know about the SQL, then yeah, you are able to follow this. So there is no codes will be required. All you have to do is just drag and drop the activity, and you can perform the activity what you want to do on a data. Okay, for data bricks purpose. Okay, so for the data factory, there will be no any coding knowledge required. But for data bricks, you need to know some basic Python programming knowledge. Okay, and some good knowledge of SQL. Okay, that's it. That's the only thing you need to have.
Okay, okay, okay. Python, I'm not sure. I don't know Python, and
I can share you one resource, a very good resource. Whenever you got some time, just go through this. Okay. So it will be very easier to just written in plain English. Okay. So you can just go to through this. just one or two trail, not just each of the topic. Okay, some basic topic like what are data types, what are variables, casting strings. So these things you can again, like you don't need to learn each and everything. Okay. But yeah, definitely if you're going for interview, so you should have the knowledge of Python because they will be asking some questions on Python as well. Okay. So for training purpose, you should only need to know some basic things like what are lists, what are data types, what are variables, what are numbers, custom string, how you can, what are different kinds of data types. These two courses are like will be using on a very frequent basis in the database. Also, learning for Data Factory, you will not be needing any coding knowledge. Okay, so meanwhile, you can consume this time or you can utilize this time to learn about Python. Once you will start this database, there will be require some basic knowledge of Python.
About data flows, like how can we perform any kind of data transformation activity in the data factory. So here we can perform like a transformation activity, like if you want to join two data sources and you want to get some aggregated result from that two particular data sources. Let's suppose, for example, you have two data sources like employee data and some project data. Okay, and in the employee data you can say you have some csv files where you have employee details like employee id. Just take an example. Okay, employee name and project id. So these are three columns in your employee data set, project id. And where in the project data set you will be having some project id. These are the columns will be present over there, project id, project name, and something like the project yeah, that's it. Project ID, project name. Okay. So now these are the two data sources are present. There are two CSV files are present in your Blob storage or any kind of Azure storage account. Okay, and you have been asked to, like, you need to generate some output. You need to generate some output. Not you don't need to move these files somewhere else. Okay, no one is asking to move those files, but you have been asked to generate some output file where that output CSV file would contain employee ID, employee name, and the project name. Okay, so from employee ID and employee name can be achieved from the employee data set, but in order to get the project name in our output file, these should present in all these column, these three columns should present in a single output file. Okay, so how can we get this project name? So basically in the SQL, right, we are already aware about, like if you are having two tables in the SQL. Okay, and you need to achieve these kind of scenario, then you can perform joins in the SQL, right? You might be aware of, like inner join, left join, right join, full join.
Mm-hmm.
Okay,
Yeah.
similar kind of scenario we can also achieve in the data factory as well. Okay, so in order to achieve like this scenario, like where you have to generate this these three columns in our output file. Okay, our output CSV. Let me just give here output. So in order to achieve that, you have to join these two data set, emp joins project, not a project, it's a project. Okay, so how can we do that? Okay, using the data factory. So there is a one way that is called data flows. Data flows basically it's a kind of way through which you can perform data transformation like joins, aggregate, joins, aggregate. You can apply filters. Okay, you can split the two columns in a single column to two different columns. Even you can merge two different column to a single column. Okay, so these things the kind of transformation you can perform using the data flow into your data factory itself. Okay, so let's see how we can achieve this scenario. Let's consider this scenario where we have two data set employee and project, and three columns are given the employee and two columns in the project, but we want to achieve that these three output. Okay, where we don't need project id, we just need employee ID and employee name and project name. Okay, so how we can do that? So let's see that. I hope the scenario is clear to you, right?
Yes, this is clear. I also, after the join, want to understand clearly about the aggregate also.
Yeah,
But I,
definitely. We will covering each of the aspect, okay, one by one. Yeah, you're saying something, please go ahead, Kalyani.
no, so I'm having cough. I'll just keep myself on mute.
Okay, okay, cool.
So to recap, we are actually doing a transformation in the data factory, joining the two data sources, the employee and the project using the joins, right?
Yes, yes, correct.
Yes, achieve. Okay. So in the storage account, you're going to create two containers for the employee
Yes,
and project with the CSV file or something in each.
yes, yeah, yes,
Mm,
yes, you're right.
Of the employee ID, employee name for the employee one, and project ID and project name and other things for the project.
Correct, correct, you're right. Yeah. So just going to create a sample database, okay, and then I'll be using the same data source. So let me just create one Excel file so that I can just prepare the data set and I can upload the same into our blob storage. So this would be employee ID, employee name, and project ID. Okay. Employee ID 1, 2, 4, name Kalyani, 1, Gautam, uh, Arvind, project ID. You can just give 3, 1, 2. Just give some random project ID, okay? Or you can just put one as well. Now this is my employee. I'll just save this. Employee. Similarly, I can put a project ID and project name. Let me just delete this thing. This is not required. Project name I could give any random name. Okay, just XYZ ABC DEF and here JKS. Let me save this. Project data set. Okay, cool. So our data set is prepared now, and now we'll be going to a storage account and we'll be creating one container. So this is my container. Here I'll be creating one folder in a container to upload my files. Okay, so I'll be uploading both of the data set that I have prepared just right now into input folder. I'll be writing here upload to folder with a input folder. Okay. Now see, in this input folder we have two data set, employee data set and the project data set. Okay, now I just wanted to get an aggregated result by joining these two data set into a output folder here only. Okay, as of now there is no any output folder project, but once our ADF pipeline will succeeded, there will be an output folder with some files. Okay, so let's see that. Okay, how we can achieve that. So this is the our data set prepared, storage account is prepared. Now we need to do like joining. Okay, so
Okay.
in order to do the joining with
One
the
question.
data, yes, please. Yeah, yeah.
Sorry,
Go ahead.
just interrupting 1 minute. Can you just open your Excel file that you just created? Because I thought in the employee, you also created the project ID. You also added the project ID. Uh,
Yeah.
is that right?
Yes.
But we want to actually do the joint, right, with the project ID. We don't want to.
See, whenever you need to do the join, you need to have one common column, right, between two data sets. If you remember, in a SQL as well, whenever you're performing some joins, so you have to like you have some reference column, right? Or you can have
Right.
you need to have some, so that's why I have put a common column, that is project ID in the employee table. And also basically here the employee data set is referring the project ID. Okay, which is a primary key, a primary column of project data set. Okay, so basically Kalyani has been assigned a project ID 4. So if someone wants to know what project is being assigned to Kalyani, so he or she needs to open the project data set to check the project name with the ID 4. Okay, that's the problem. Like you need to look into the two data set. Now since this column is common, okay, I can join, then only I can join, I'll be able to join these two data set, right? If this column is not present, so at what like behalf you will be joining this two data set. Okay, so it's completely like SQL. Okay, so let's suppose these are the two tables. Okay, and someone asks you to return data where I just wanted to show this result, employee ID, employee name and project name. Okay, so in order to do that, you will be writing query like select uh, imp ID, employee name and project name from employee as e join or inner join, whatever you want to perform, join project p on e dot project ID. If this common column will not be there, so how you are going to perform the join? Okay, that is not be possible, right? So there should be some column, common column in between the two data set. E dot project ID equals to p dot project ID. Are you getting my point?
Yes, what I was confused is the value. In that value, I get that we need to create a primary key. That
No,
would
no,
be
no. Primary key is not required. Okay, so basically this is the ID we are referring in the employee data set. So whatever the ID you have, okay, that should be present in the employee. Okay, as you can see here in the employee, I have all on the IDs over here. The two one is not I'm using, but yeah, that is fine. Okay, so basically I'm just giving some example. Might be
needs to
two
be
people. Yes. Mm-hmm.
because two members can't have the same project ID, right? This
Yes.
ID needs to be unique, right? Like,
No, that is not the like in a single project, two persons can also work, right? Like it's not mandatory like one each of the person have been assigned a single project. Okay, so under one project, two people can also work. So that's what scenario I'm just trying to implement here. Like
okay.
it's not like that. Like one project in only be assigned to one person only. Okay, so like you and me can also work in the same project. Okay, so say, that's why the same code can also be assigned.
Okay.
Yeah, so in short
Okay.
you used to call it, this is the employee details. Okay, where you have employee ID, employee name and with their project that assigned to. And this, if someone wants to know like project about the project, which project have been assigned to Gautam and Arvind, so they have to just go to the project details and they can just check for the that yeah they have been assigned the project name, this XYZ project. Okay.
Okay.
Okay, cool. Like going forward, you will not be having just three columns. You will be also having the addresses. Okay, you will be also be having business unit. Okay, in which business unit? Okay, so again, three more than two or three people can working in the same business unit. Okay, might be Kalyani and Aman is working the dev team, and Gautam will be working on some QA, and Arvind will also be working as a QA. Okay, so this is possible, right? Basically, in the QA, two people can work on in the Kalyani, and Aman can work in the dev, or Aman can work on the some testing moment or something like this, like as a Scrum Master or something like this. Okay, so it could be different, but that is the possible scenario. So I'm just trying to cover each of the possible scenario over here.
Okay.
Is it clear now?
Yeah. Yeah.
Hello.
Yes. Thank you. Let's.
Okay,
Yeah.
cool. So let's go back to our core data factory. So in order to create a data flow, so data flow, what is data flow? So data flow is the like you can say a kind of a feature of data factory which allows you to perform data transformation on your activities or on your data. Okay, using some graphical user interface. Okay, so here you don't need to like write some any code on something else. Okay, so if let's suppose I just wanted to uh, perform joins on two data set. So simply I can just drag and drop some of the features. Okay, so I'll show you. Let's just click on three dots and click on new data flow. Okay, so here you have to provide the first thing, that source. Okay, so if you referring this SQL query where we have written select imp id imp names, this is the our like column name that we want to get it. So the first source is employee table here. Okay, so we will be sourcing the employee data set. So let me just click add source, and here I need to provide the source name, employee details, or whatever you want to provide. Give the name, it's up to you. Now I need to select the data set. Okay, so as of now we didn't any created any data set, so let's create a data set for the employee. So I'll just, since it is our uh, CSV file is present in blob storage, so I'll be selecting the blob storage here. Click continue, and the file which data present in my blob storage is of CSV format, so that's why I'm selecting the CSV here. Imp data set. Let's create a link service for data factory. Blob link service. Select my storage account. Let's test the connection. The link service. Yeah, it's successful. Just click create. So link service have been created, and we need to select a file path. Okay, just click on this browse. This is present in my container and present input folder, and just select the CSV file. Okay, so basically it will pick your employee data set here. Okay, and yeah, make sure to check this checkbox first row as header, otherwise it will also consider as data, because here our the first row is header. Okay, this is not a data. So yeah,
Mhm.
just make sure to check this box to notify the data factory. Your first row in the CSV file is a user header. Click OK. So our source is present next, which means this up to this point you are okay. Now you have to provide the another data source, that is project. Okay. So in order to do that, just click this again, add source, and give a relevant name. Sorry, project details. So far, any queries or concerns, Kalyani?
No,
Hello.
I'm following.
Yeah. Okay. So need to create a data set for project in the data factory. Just click blob storage. Again, follow the same process. CSV. If we present in some other data format, JSON or Excel, just select that file format accordingly. But it is present in the CSV, so I will be selecting the CSV only. Give a name, project data set link service will be the same because it is present in the blob storage only. So I'll be using the same link service and selecting my file from here. So select the entire path here. Okay, cool. Now our this employee details come up in our data flow. Project details is also come up. Now we have to perform this part. Okay, where both of the project ID is same. Okay. So in order to do that, just click on this plus icon. Okay. And the first option you can see here in the data flows to join. Okay, there are multiple operations you can perform on this on any data source, like join. If you want to perform some conditional split, like you want to split two different one single column into two different one. If you want to check whether this column is existing or not, if you want to perform some union between two data set, if you want to look up in some details for your data set, you can also do that. You want to create some a new column based on some other existing column, you can also do that. You want to select it, you want to aggregate, surrogate key, pivot, unpivot, window, you want to apply window function, you want to perform rank, external cost, cast, if you want to cast it. So everything you can do that over here. Okay, filter, short, alert row. So yeah, these things like transformation, you can perform a data transformation. Okay. So this is the benefit of Data Factory. Basically, if you need to do the same thing in a Databricks, so you have to write some PySpark code over there. Okay.
Mhm.
So just click on join. So now it will ask you where.
What to
Sorry.
join? Like,
Yeah. Yes. Yes. Just give me a second. I delete this. So if I click join, so you can just give a name, joins or inner join, whatever you want to perform. Here you have to provide the data source name. Okay, so as you can see, once you select the joins, you can even select what kind of join you want to perform here. Okay, whether you want to perform full outer join, inner join, left outer join, right outer join, or cross join. Okay, so right now we want to perform inner join, so I'll be just going with the default and the left stream. Okay, so left stream, which means uh, to the join to the left side of the joins. Okay, what are the data source will be present? So that is already present, that is employee project ID, employee data set is present. Now we need to select the right side or right stream of the join, that is a project ID. Okay, so here we will be selecting a right stream, that is project details, and left stream is already selected. So join conditions, if you want to perform join conditions, like on which join condition you want to join your two details. So I just wanted to join on the behalf of project ID. Okay, because that is the common column between two data set, employee and project. Okay, so I'll be just dragging down. Let me just drag to the upper so that it will be visible to you. Just click on this drop down. So it will just show you all the columns which are present in the employee. Okay, because this is your left stream. So here I just wanted to select project ID, and also here I want to select the project ID. So now your SQL query is being achieved over here. Okay, now we are good to go with. Okay, let me just check partition inspection. Okay, yeah. So if you go to inspection over here, so you can see this is the basically columns will be returned after joining. Okay, where you will be having an employee ID, employee name, project ID, and project ID name. So you might be noticing whenever we are joining two details, so project ID is coming twice. Okay, the first project ID from the employee details, and the second project ID is the from project details. But we don't need this output. Okay, we don't need this project ID in our output. Okay, so if is there any method that we can remove it? We just only need employee ID, employee name, and project name. Okay, so how can we do that? So there is one scenario. Basically, you can just go to, okay, just click with this. There is one or more option should come up that is not coming up. Okay, anyhow, let me just use this. So this is our scenario is prepared now. Now how we will be executing this particular data flow. Okay, so we cannot directly execute this data flow over here. Okay, so you have to call this flow into pipeline. Okay, so just go to pipeline. If you want to execute this data flow, you have to go to the new pipeline, and here you need to use one activity that is called data flow activity. Just search for it and drag and drop into your canvas. Okay, so once you drag and drop it, you have to go to the settings. Just select the same data flow that you have given. That is, this is the one that we have created earlier. Okay, you have to select this data flow, whatever data flow activity you want to like execute it. Okay, and then you have to select the parameters. I guess no parameters is required here. Just a second.
Aman, I got confused actually. So in the
Yes,
pipeline,
yes.
for creating a data flow and
Mhm.
the option settings, what are we adding here in the settings?
Actually, your voice is quite too low. Well, I'm not able to hear you properly.
Can you hear me now?
Yes, yes, quite better.
Just wondering, like in the pipeline, when we select the data flow,
Mhm.
what details do we need to enter in the settings? Like, what are we trying to fill
Settings
in?
that you have to specify. See, in the real life scenario, you will be having multiple data flows over here. Okay,
Okay.
multiple data flows will be listed, like just a one thing. Yeah. So whenever you are just whenever you want to execute this particular data flow, okay, so you have to specify in the data flow activity which data flow you want to execute it. Okay, that's what I'm selecting here.
Okay.
Yeah.
The one that we just created for our previous
Yes.
flow, that is the name that
For
we
the,
need to put. Uh,
yes. Yes. Yes.
and
Mm-hmm.
and what is the other options? Can you please go back to settings, please?
Yes, please. Yeah.
Okay. What is this Azure Resolve Integration Runtime? That is by default the run on Azure IDEA.
Yes. Yeah. So basically, yeah, this is the integration runtime. So it is asking like whether you want to run this data flow activity onto some other integration runtime as well. Basically, this is a data transformation activity. Okay. So from the performance perspective, like if you want to, like sometimes you might be your data flow will be quite large. Okay. So this is since we are learning from a demo purpose, that's why it is quite small. That just a simple transformation we are doing, just join two data tables. Okay, but in the real life scenario, you'll be having multiple data flows over here. Okay, so sometimes it would take some time, like 5 to 10 minutes to process those data and to perform some data transformation on those data. Okay, so it was like it is recommended if your data flow is quite large. Okay, in that case you can just create your own IR. Okay, you can use some self-hosted IR or some other IR. Okay, so you can just create it and you can select that option. But if your like data flow is not quite large, so you can just like run on the by default IR which is already present in data factory. It is auto resolve integration runtime, or it is also known as Azure Integration Runtime.
Okay. Okay. Got it. Thank you.
So let's publish these changes. No sync transformation found in the data flow. Oh, okay, okay, okay. Uh, One thing we forgot here. So after performing this join, okay, so basically we have provided two details and I'm joining it. But where we are going to like sync the data, sync the output, or you can say dump the output. Okay, so we need to add one more flow here to sync it. Okay, so just click on this plus icon and just scroll down a little bit. So just click on sync. Okay, so here we have to provide the data set wherever we want to dump the output. Okay, you generate the output file, in other words, if you need to say it. Okay, so let me just give a output. So basically, it will join the two details and will generate the output at this particular data set or at this particular location. Okay. So incoming stream, in of course, whatever the output will be generated from this join, that will be dumped into this location. So we need to select a data set for this as well. Just click new block storage. because I'm just going to create in the same blob storage. So I'll be selecting blob storage, and also I just wanted to generate in the CSV format only. Just click continue. Output dot cs no, output data set blob link service. Here my container, and since there is no any output folder is present, so what I can do is I can give a directory name manually output, and it will come up with a name output dot csv. Okay, seems like something has been changed. Earlier it was generated automatically, but anyhow we need to create one folder over here. In order to create any folder, you have to upload some files in a blob storage. That's why I'm just uploading some random files, so kindly ignore it. Yeah. Just to create this folder, okay? So we can use this folder in dataset. Yeah. So now we have selected our dataset. Okay. Now we need to now we will be able to publish these changes. So let's publish this. Okay. Now we are getting error. Some sync dataset output does not have any schema. Please import schema from dataset. Turn on allow script data. Okay. Just turn on this allow schema drift.
What is this option? Allow schema drift?
Okay, so like basically in our folder there is no any schema is present because there is no any file is present, okay, as such. So you can just allow the schema drift, which means like whatever the schema will be generated from these input file details, that the same schema will be uh, dumped to the output as well. So that's what like we are checking it, allow schema drift. So if you want to just want to check the schema, just go to mapping here, and you can just you can see this is like by default it is selected auto mapping, okay. So if you want to just uncheck, if you uncheck this, so it will show you the schema what will generate, okay. So here the input columns we have, like after the joining, after the join that both employee and project, we will be getting output as a employee id, employee name, project id from employee details, and again one project id from project details and project name, okay. That will be mapped to the out columns of employee id, employee name, project id, project id, and project name. So from here only, if you want to delete project ID, like if you want to delete any column, not just asking about project ID, any column which you don't need, so you can delete it. Okay. So as I said earlier, basically in the output we only need employee ID, employee name, and project name. We don't need project ID, so you can just delete it. Okay, because that is not required. So only 3 columns will be there in your output files. Okay. And also, yeah, you can check this. By default it was checked out, but yeah, if it's not unchecked, so just make sure to check it. Like it will skip the duplicate in columns, and it will also skip the duplicate output columns if in case that will be available in your file. Okay, let's publish these changes. Yeah, let's run this. Go to pointer. Let's see, it's still in progress. Taking time. Still not taking time. Let's wait for this. Let me just cancel this. It should not take much more time. And let me just debug this manually before triggering it.
Okay.
So we can also debug this by just switching this data flow debug.
Okay.
So basically, whenever you are switching to data flow debug, so it will create a cluster behind the scene, okay, for you, and it will run your data flow activity on that cluster. Okay, so it would need some resource engine to run on. Okay, so basically it incurs some cost whenever you are switching data flow debug. If you're not aware of the cluster, so cluster is basically is a group of engine, or you can say a system or machine or virtual machine or laptop or PC, whatever you could understand. So like it will just provide some resources, some like a running engine to run your pipeline. Okay, so that will be assigned by automatically by Microsoft Azure once you switch on to the data flow debug.
Okay, thank yeah.
It will take a couple of minutes because it's take time to debug.
Can we check the logs in the
It's being queued right now. Now it's in progress. You can just check the
in activity? Yeah.
debug entity here. So if it is taking time, which means your integration runtime is basically uh, busy in some other task, like basically at the same time the Azure IR being used by multiple team members or multiple organizations. Okay, so that's why like sometimes it is not being recommended to use the Azure IR because it's quite slow. Okay, whenever you need to run the data flow activities like this. So most of the organization used to prefer for self-hosted integration runtime. There you can create your own integration runtime to run on. The flow activity for the debug will run will start as soon as the data flow debug session is. Okay, the session is not ready for the data flow debug. As you can see, it's still in progress. Okay, so once it will be ready, it will be start running. Okay, data flow debug is ready now. Now let's see this. Why it is not being happening? It should not take much more time. So meanwhile, it is being progressing. Let's explore the other activities of data flow. Okay, then we will check in a while, like whether it is progressing or not. Might be it should take much more time. Okay, just go to data flow here, and
And we don't have much data also, right? It's very simple one. It should not take such a long
yes,
time.
yeah,
Yeah.
something is meshing, but I believe everything is I have mentioned over here, so it should not be taking much more time. Might be the performance of IR is not so good because it should show the data in the real time only. Just the three columns is there, three or four columns.
But the idea here is in Data Factory, we don't have to actually write the code in, um, you know, Python or, any such. We can just use these activities and just, directly select a join and what table we want to join and all that, right? Easily.
Yes, yes, yeah,
Mm. SQL code.
yeah. So basically, Data Factory is not only like basically the use for the data ingestion, data transformation as well. Okay, the first level of transformation. So basically, in the real life scenario, whenever you are working on some data engineering project, okay, so there you will be having three lake house architecture in your data lake. Okay, so there you will be the first layer will be the bronze layer, or you can say the silver layer. Bronze layer is the layer where you will be as it is sourcing the data from on-premise REST API or someone like what could be the data source. You'll be keeping the bringing the data into your cloud as it is. Okay, now you'll be doing the transformation like this, like joining the two columns or splitting the two columns or single column or merging them or applying some filters, and then you'll be storing in another container of your data storage account. That will be your second layer. Okay, those transformation will be done by the data factory yourself. If you want to do some another like next level of transformation, then yeah, definitely you have to take the help of Databricks in that scenario. Okay, but yeah, most of the tasks will be done by the data factory itself. So as you can see, this is the data preview. Okay, so we will be getting this out as an output: employee ID, employee name, and project name. Like where employee name is Gautam, Arvind, Aman, and Kalyani, and their project name. So this is the output that we can just get it from output file. Okay, so this is the data preview that he is showing that here your employee details was Kalyani, Aman, Gautam, and Arvind, where we have three columns: employee ID, employee name, and project ID. And in the project details, we have, let me just refresh this. So it will show you the all the data preview. Okay, that is the beauty of data flow debug, that you can just go step by step. First of all, I'll check the employee details, then I'll check the product details. So basically, it is preferred whenever your pipeline is getting failed. So you can just check a step by step what is the data is coming into the data factory. Okay, so it is successfully fetching our data sources. Like as you can see, as it is, I have given in the Excel sheet or CSV file that the same data is coming up into data factory, and now it will be performing the joins here. So after performing the joins, the data is like this. We have five columns: employee ID, employee name, project ID from employee details, project ID from project details, and project name. And now we are getting the output here as a three. Instead of just getting five columns, we are getting three columns because we have deleted two columns from the mapping itself. So that's why we are getting three columns only: employee ID, employee name, and project name. Okay. So this is the output will be generated. Now let's run the pipeline. Okay, it's got succeeded now. Cool. So what I can do is I can just turn off the data flow debug and trigger this pipeline. So basically, this is was not the issue of pipeline. This was the issue of the Azure integration runtime. Okay, it's take a lot of time to process the files.
So even when we did earlier just the debugging and it was successful, right? We should be able to see a new file in the output folder, right? In the storage
No,
account.
no, 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 no. So
Only
whenever you're debugging, it will not generate any file. Okay, it will just generally just show you the output, data preview in your output section. Okay, but yeah, if
okay.
you see, you can just cross check. Yeah, you are right. Okay, so it have generated some files over here. This is the output file. Okay, so if you can check the input file whenever we are doing some debugging, just go to edit. So it will showing the three columns are there: employee ID, employee name, and project name. Okay, so it's a fully generated of file. But there's one problem here. Basically, it is generated the output file with some random name, and some added files are also there. Okay, I just wanted this file with some particular name, some clear defined name. Okay, this is just generated some ID or like part 000 something like this. Some name is good. Like if you have multiple files over there, how you are going to distinguish like this is the result of the employee and project details. Okay, joining up employee and project details. So in order to do that, what you can do is let me just cancel this pipeline. We need to make one change over here. Just go to data flow in the output. I just set a single partitioning and name default. Yeah, just just go to settings here. Okay, and here you have to give the file name option as output a single file. Earlier it was selected default, so instead of just default, just select to output a single file. So it will only generate the single file, and you have to provide the name here, output to single file name. Okay, so whatever the name you'll be providing, let's suppose output data. So the file will be generated into your folder with the same name, output data only. Okay. Any queries on this?
Um, no, I'm trying to follow. Yeah, yeah. Thank you.
Okay. Meanwhile, it is running. Like if you have any queries, Kalyani, just let me know, please. We will. I'll able to like I'll just try to resolve them.
I would like to give it a try for this
Okay.
one.
Yeah, got succeeded now. Now let's see.
Yeah.
Sorry, you are saying something. You're saying something, Kalyani.
Actually, this is a transformation, right? The other
Yeah.
thing is like ingestion also, like how if any live example of ingesting some files into the storage account. So that would be the example like what we have covered previously, right? Like any files
Yes,
in
copying the data. Yeah, that copying the data is set to be the data ingestion.
data ingestion. Okay, that is one thing I wanted to make sure. Is there anything else, or just the copy activity what we've been, doing for last few weeks? That covers
Mm-hmm.
that. Okay,
Yeah.
so ingestion into any storage account. If we want to do it in the raw storage account and all that, it's the same process, right?
Yes. Yeah. Yeah.
And
Okay.
the main thing I want
Yeah.
to
Good.
is like
Mhm.
what is this aggregate? What exactly are we trying to do in the aggregation?
Definitely, we'll be learning each other like aggregate filter in the upcoming session. Okay, I'm not going to cover each and everything like in a single session only. So definitely, we will require one or two sessions more to cover up that part as well. Yeah.
Okay, okay. So now the pipeline has been successful,
Yes.
and
Yes. Yeah. You can see
also,
the output data is generated now. So earlier, when we have debug, so there are two files that come up. Okay. The first one is for log. Some random things are being generated. Okay, and it have provided some random name to your file. But if you just select your in this pipeline, basically if you can go to this pipeline data flow and just select your output here, go to settings and just select this file name option to output single file. Earlier it was default. if you set this output to single file, okay, and you have to provide the output data, the name of your file, so then it will only generate a clear one single file only, okay, with the same name that we have provided, that is output data. You can see the same output is present here as well, okay. So basically, in order to clean your blob, in order to clean your container, just make sure to select the output to single file only, okay, whenever you're performing some data flow activity.
Okay, got it.
Yeah, that is all for today. Kalyani, just go through the recording, okay, try to do this activity on your own, and
Mm.
yeah, let me know if you have got some stuck somewhere else or got some queries. Yeah.
Okay, great, great. Hey, Aman, also, just want to remind you, if you can please share me that preparation for the certification, the questions you remember you said that you have a.
Yeah, actually, I remember that. So basically, the thing happened to me as well. Like, there is some issue at my laptop, okay, and also like there was one folder I have where I have put it all my like previous year papers of DP 203, and like not just for data engineering but also for DevOps engineering as well. But somehow it got deleted. Okay, so I'm not able to recover it right now. I'm just trying to fetch it from some other sources. So once I'll get it, I'll share that to you. Okay.
Yeah, that would be really helpful.
Yeah.
Yeah, cool.
Yeah. Sure.
Thanks, and I will,
First point is an overview on Azure Database. Basically, what is Azure Data? It's nothing but a cloud-based big data and ML platform. And the important thing is it provides a collaborative workspace. So by collaborative workspace, what I mean is multiple people can work in Databricks at the same time. By collaborative workspace, what I mean is, say if we have, if I'm using one notebook, and then if another person is using the same notebook, and then if let's say if I make some change here, that change will be reflected in the other notebook at the same time. See, this thing has popped up saying that another person has logged in and using the same notebook at the same time. So here you can see it got updated automatically. That's about collaborative workspace. Multiple people can use at the same time. So if there is one more user, one more circle will come up with that user ID.
Okay.
Yeah, so that is about collaborative workspace. Then another thing is it works on Spark. So Spark architecture, as you know, the important thing about Databricks is it follows a distributed architecture. As in, if we give a code, it divides the whole code into multiple sections, and each section will be executed parallelly, and we will be getting the output faster. Since it deals with big data, and to process this huge amount of data, we can take advantage of Spark architecture. So basically, the backbone of Databricks is Spark architecture, the massive parallel processing. Yeah. Then another thing is it can be used to train and build, as in you can use it to train and build ML models. It's just theory concept. We won't be looking into MLs here. Then other thing is since this Databricks the workspace is present in Azure, we can integrate with other Azure services as well, including Azure Blob storage, Azure Data Lake storage, SQL data warehouse, event hubs, and even Azure Synapse Analytics. All of that. We will be in later sessions. We will be looking into each of these. And plus, it can have seamless integration with business intelligence tools. Yeah. Then
Okay. Yeah.
Coming to key features of Azure Database, we have already seen collaborative workspace. As in multiple people, like let's say we have data engineers, we have data scientists, and business analysts. All of these people can work together on the same notebook at the same time. Collaborative and Apache Spark in it. We saw that the backbone of Databricks is Apache Spark. And in Apache Spark, the important thing is massive parallel processing, dividing the for query into small sections, executing each of those parallelly. And we will be looking into detail on what happens, how it is getting divided, where it is going. So all of that in the second module. Then we have ML capabilities. So basically, Databricks provide machine learning libraries using which we can build and train our then a data science workflow. In in the Databricks, we could build end-to-end pipeline. As in from end-to-end pipeline, basically what I mean is we could do data preparation, data cleansing, and all of that. Multiple transformation, and finally clean all the data, put it into create a pipeline that takes in all of the data, cleans the data, and puts it into a sink that points to BI, or that provides the data for a model. So the complete end-to-end pipeline can be built in Databricks. Next is automation and DevOps. So Databricks provides CI/CD, continuous integration, continuous deployment capabilities. So, and we have a module exclusively for CI/CD, how it does all of that.
Okay.
And and it provides automated job, as in we could schedule our pipeline. So as I said, we can create an end-to-end pipeline, and we can schedule it to run at particular time.
Okay.
Yeah. Next is the use case. So these are all just before getting started, just theoretical concept. So use cases are data engineering, ML. It provides ML libraries and BI analytics, like BI tools like Tableau, Power BI. All of that can be basically connected to Databricks. Then IoT analytics. So one thing that's booming right now is the streaming data. Yeah. So by streaming data, what I mean is real-time data. So from IoT devices, we could send this real-time data to Databricks, and basically we could from this real-time data we could view the data. We could do transformations on this real-time data and get insights from this data. Next, then it's about genomics. Genomics is nothing but as in it supports whether we could identify genetic variations and build models for disease. Basically, it deals with healthcare data. That's all. Okay. Now, how to create a workspace? So, to create a workspace, okay, just hit on create. Then we will be coming here. So these are, so basically we'll have our subscription and resource group. So as you know, multiple resources are tagged under one resource group. So if we want, we could create a new resource group, and the workspace name, this has to be unique workspace name. And the pricing tier, we could give premium, standard, as per and then we don't have to bother much about network encryption or tags, and just hit on review and create, and we'll create the workspace for us. So that is how we create Databricks workspace. So once Databricks, then configuring the workspace settings. Say once we have created the Databricks workspace, we will get option to we can configure settings like access control, and then connectivity to ADLS. As in by access control, what I mean is we could give add AD groups, and then to the AD group we could add users for access.
So those AD groups are added via Azure, and you are able to basically consume those groups. That's what you're saying, right? Or you have to create those inside here.
Correct. No. We don't have to create those AD groups here. So basically, we have to we have to provide those AD groups inside the workspace, so that the people inside that AD group can access the workspace.
So can you repeat that? So AD groups are going to be created outside, right? That's not, you
Yes.
won't create that inside.
No, we won't be creating that inside. We just have to provide those AD groups, saying that these people need access.
Okay. Is it possible to show that, or is it just because it's a setup, it's not possible?
No, it's not set
Yeah, I
up.
can imagine.
Yeah, these are prod environments. I don't want to mess.
Yeah, sure. No worries. That's fine. So if you can provide some links, like that will be kind of, I just want to look up those things and, just want to be aware of it.
Sure. Yeah,
Okay,
I can provide you links. So after the session, I'll be sending a mail with the Databricks notebook. So along with that, I'll include the link as well.
Okay, sounds good.
Yeah. Then another thing is we can configure our Azure Key Vault as well. As in, the concept of Key Vault, right? So that also we can configure. So so that is about configuring the workspace settings. Then creating cluster in data. So now that we are here, so this is the Databricks UI. So here we could switch between machine learning or data science and engineering here. Then here workflow, since this is community edition, we don't have this here, but when I'm talking about jobs and all, I'll show you in using my account of how we could schedule jobs, all of that. Yeah. Okay. And then so here we're gonna create a database cluster. So basically come in compute. Inside compute we can create a cluster, and cluster name -01, and then we will have an option. So since we could select our Spark version, Databricks runtime, all of that, and then we can hit. So here, if you see, we have worker nodes and we have driver nodes. So this entire thing, we call it as a cluster. Along with the worker node and driver node, we call this as cluster. So the cluster is nothing but a group of virtual machines. You can hit and create. Basically, that will create the cluster. And yeah, next to configure the cluster, we will have so since this is community edition, we are not getting option, but we will have option to set the nodes. As in now, basically nodes are nothing but how so we run our code on these nodes. So basically, nodes are just compute space for us. So we could set the number of nodes that we need. Basically, say let's say by node configuration, what I mean is we could set the minimum number of nodes and the maximum number of nodes. So node is nothing but you can think of it as virtual machines on which the code runs. So and if we enable auto scaling based on the load, it will switch between the minimum number and maximum number. So that is about auto scaling. And then we could Spark configuration, like as we saw here, we can select the Spark version, all of that. Yeah. Then the next thing is about notebook. So basically the everything that's done in Databricks will be in this notebook. So okay, so let's say, and the important thing about notebooks is it is very interactive. So let's say if we could write some code and then we could execute the code and we will get the result here. So this is one data frame, and we just read the data frame and then we display the data frame and we will get the result here itself. Oh, it is very interactive. We could create visualizations, all of that from the notebook.
Okay.
Yeah. So basically, yeah. Now we will see how to create a notebook. So click on workspace. Like I showed you earlier, we could create a folder. So I've already created folder. So let's say we are just creating folder to keep our files organized. So here we can create a notebook, and we could use this notebook as module 1, and we can set the default language. So basically, by default language, what I mean is we could select between Python, SQL, Scala, and R. So whatever code that we write here will be run in Python. But say, even if we have set the default language as Python, and if we want to run some SQL command, then we could give the magic command %SQL. So if we use %SQL, we can run SQL. Or if you want to run Scala, we could give %Scala, and it will run Scala code. Even though the default language is Python, we can run SQL commands here. Let's say,
Okay.
yeah, let's just
Okay.
select one. So when I run select one, you can see, like I said earlier, it is very interactive, whatever we are doing, and we could display that here itself. Yeah, so okay, now creating and opening a notebook. So, and to open an existing notebook, say if to just go to workspace, navigate to our folder, and then we could open up some other notebooks as well. Next is about the interface. So basically, you should be knowing now how to change the default language here. And even if we have Python to run another language, we could use %SQL. That's another thing. And then we can have. So here we could have import notebook, export notebook, all of that here.
Okay.
Yeah, and how to clone a notebook also we could use here, but I'll show you how to clone using this other way. Rename, move our notebook to a different folder, then upload data to DBFS. We will be seeing that now. Then create table and export. This is how we export a notebook. So we can create on export, and then we could hit on these files. So this will just be how the output will look like once we export. Then we have version history. So version history is nothing but we can link our database notebook to Git. So
Okay.
once we have linked our database notebook to Git, so if we make some changes, that change will automatically be integrated to Git. You know version controlling, right? Here, so the edit we won't be using edit much, as in whatever is present here, we can do that inside the cell itself.
Yeah.
Then here line numbers, all of that. And then help, yeah, that's about this. And then here we saw if we have multiple users logging in, we can see them here.
Okay.
Yeah, if multiple users are using the same notebook at the same time, we can see their user ID here, and say since this is saying green, I'm having a green sign here. So if you have one more user, let me see if I can. What I'm saying is it will come up as a different color. or it's because it's the same ID, it's coming in the same way.
Oh, okay.
Yeah, if it's a different ID, it will come up as a different color. So we can see who is making change, who is making what change. Then wait. Then here we could run the cells. To run all the cells in the notebook, we could use this. And to run individual cell, just select on the cell, hit on, click on this and this to run the particular cell, or click on Shift plus Enter. That will run this command. So you have already worked. You should be knowing this. So here we can select the cluster, which cluster to use. All of that here.
Okay.
And this is to basically publish our notebook. That all of that we'll be seeing in the CACD session.
Okay.
Then yeah, revision history and to add comments to the notebook. Yeah. Now coming to cell. So in the cell we have the default language. Say if we want to change the default language. So basically there are three types of cells in the notebook. So one is the code cell, markdown cell, and row cell. Say I'll show you what is markdown cell. So here if we change the language to markdown, it will give %empty, and say if we type anything like title 1, it will show that as a header. It will come like a header.
Okay.
So those are markdown cell. Then code cell is nothing but the cells in which we write our code, like using Python, SQL, Scala, R. So and then we have a row cell. A row cell is nothing but if we will have cells where we just comment out all of the code, or comment out and give comments. So those are all row cells. These are not interpreted by the notebook.
Okay.
Yeah. So that's about the three types of cells. Then inside these cells, say here we have the option to run all of the cells above or all of the cells below, or run this particular cell. Then this is about we could add cell above, add cell below, and so if we want to give title to this particular cell, we can use this. And here we could say title 2, and then that will just give the title. Yeah. And say if we have execute this result and if we want to hide the result, this will be very we will be using this very often, because if we have a lot of results that's popping up, it will be difficult to see the entire code. So to avoid that, we could use hide result, and then we can use show result to show the result here. So we basically we saw three types of cell and working with code and text in notebook. Then how to create a new cell, so we could click on the plus here to create a new cell, or we could go here and add a cell below. That will add cell below. Next is basically writing code. If you want to write in some other language, you could use this, or if you just want to go with Python, you could go print, and that will just print the output here. What I did is shift enter, and then that executed this cell. Then writing text, we saw how to write the text, and then displaying code within text. So inside say inside the markdown language, if you want to write code, you use the backtick and then write code inside this. That will just show as a highlighted thing here. Then to switch between cell, it is very easy. We could just go and select here. And now recently Databricks has provided, as in recently in the documentation I saw, we could run multiple cells at the same time. So that is one very recent change that they have made. So I'm yet to look into how we could do that, but it is possible. In the next session, I'll be showing you how we can do that. Then switching between cells we saw, and now we will see how to import and export notebook. So basically, we will create here export a notebook, export as a TPC file. Yeah. Now we'll click on import notebook. Now we have imported the notebook, and we will be having two more. So this is the one that I just imported.
Okay.
Next is about connecting to data sources. That is really not in the scope of this session. So as in we have an exclusive module on how to connect to other Azure data sources. I can show you how to basically to get a sample data set. So here what we're going to do is we have a Databricks file system. So you could think a Databricks file system as like a storage space that's inside Databricks, to which we are going to upload data to this. Now if we go inside data, we should be seeing this. Go to data, inside data, click on hit on create table. We will copy this particular file path, and then we're going to go to the workspace. Basically, how to read a file is what I'm going to show here.
Okay.
So to read a file, we could use the read API, spark.read. Now since it's CSV file, I'm going to give spark.read.csv. And then since it's Databricks file system, dpfs, and just give the path. If you can see here, the first line is not the header. So to make the first line as header, I could give header So this, so what happened here is we read this Databricks file. We put the Databricks, we read the CSV file, put the CSV file into a data frame, and we displayed that data frame. So this is PySpark code. This is just so that you will get a taste of what we're gonna do in future.
Okay.
Yeah. So that is about how to read a file basically. I'll show you how to move a notebook around. As in, if you want to move, we could use here and then move a notebook. Basically, go to folder, select notebook, and then if you want to move it here, we could move it and then select where to move it to. Yeah, and then we could that will move the database to. It moved the database from here, this folder to this folder. We have module 1 here. Then if you want to clone, so whenever you're working in the database notebook, it is advisable to make a clone of that notebook, then work on it, and then merge the changes. To clone, we could select a particular notebook, right click, and then clone the notebook. Yeah, so that is how you clone the notebook basically. Then yeah, we
Did
saw
it clone
how
at all?
to create. No, so that basically you right click, hit on clone, and then give the path where you want to clone, and then you'll be able to clone it here. But I'm not getting. So how we move the notebook now? We will be getting a create clone option here, but I'm not getting it. Maybe because of the community edition, I'm not getting. Not sure.
Oh, okay. Some limits are there on the usage. Okay.
Yeah, but we should be able to clone. But
okay, that's fine.
But that is, yeah, that's the process. You understood, right?
Yeah.
Right click clone. Yeah. Then okay. So that is it. I'll do one thing. I'll export this one. You can take this certification, database lakehouse fundamental certification. This is how it will look like. It is very easy. So after the Delta Lake architecture, that session, you will be able to take this up. Yeah. So basically, after you finish this code, you will have something called essential capstone. So today's session is gonna be about Spark. So basically, Spark architecture, as I told you yesterday, it deals with massive. So basically, Spark architecture is a distributed system. The main idea is to process the data in parallel. So massive parallel processing happens.
Okay.
That is the whole idea, but we will be going in detail at each level. So the components of Spark architecture, it consists of, initially there will be a cluster manager. There will be a distributed storage system, like how we saw yesterday, DBFS, Databricks files, and a set of computational engines. These computational engines are the clusters that we saw yesterday. Okay, now you will see the role of each. So cluster manager, the role of cluster manager is to, basically we have the computational storage and the computational engine. So basically, role of cluster manager is to allocate the resource. Say in the computational in the cluster yesterday we saw we have multiple nodes, and to manage all of these nodes, as in how much that the role of cluster manager is to manage this computational engine.
Okay.
Yeah. And then we have distributed file system. So distributed file system, it provides a fault tolerant and scalable storage layer for processing by Spark. So fault tolerance is very important for Databricks. Okay. I don't want to deviate from the topic, but once we cover these three topics, I'll talk about fault tolerance.
Okay.
Then the other thing is, so that's about distributed storage system. It's nothing but it provides fault tolerant scalable storage layer for processing the data. And this the Spark can integrate with a variety of distributed storage system. It could be Hadoop file system, Amazon S3, Azure Blob storage, anything. Then the Spark core. I'm going to talk about computation engine. So it has a set of library for machine learning, graph processing, etc. And then and using the computation engine, we could schedule jobs to run our notebook. And the computation engine also provides fault tolerance. And another important thing about Spark architecture is the main data structure of Spark architecture is resilient distributed data structures. So resilient distributed data set, RDD. Okay, it's nothing but it's it's a collection of data, and it can be processed in parallel.
Okay.
Across multiple nodes. So if we have a huge, say, if we have a data set that's huge, it could be divided into multiple set and sent across multiple nodes. So each node can provide the output and then send it back. So and this is also immutable and fault tolerant.
So this is the internal storage where all the calculations are done, is it?
This is the basic data set. As in, how do I put it? Yeah, you can say it as internally what is happening, but say now we are dealing with a data frame, right? This data frame is derived from RTD. So that is resilient, it is immutable and fault tolerant. So basically the overall idea of Spark architecture is to enable scalable, fault tolerant data processing using combination of distributed storage, distributed computation, in-memory caching. Yeah, and Databricks provides in-memory caching. That is why the processing speed is faster. Okay. Now coming to fault tolerance, and important points: fault tolerance and provides in-memory caching. So say what is in-memory caching? If you ask me, say one thing. What RTD does is different. The data will be spread across these storage spaces, processed in parallel, and gives us the output. In-memory caching, on the other hand, say if we are using a data frame in multiple places. Okay, so in that case, we could cache that in memory and then do computations on the data frame, rather than whenever we are calling the data frame to get distributed and then process it again and then give us the output. We will cache it in memory and then use it.
Okay.
Yeah. So that's about in-memory caching. Then coming to fault tolerance. So for fault tolerance, it provides by fault tolerance by using the RDD distribution. So what means is, so this RDD, they will be partitioned across in our whole structure, we will have cluster manager. Okay, that manages all the computation engine, all the nodes and executors, all of that. And then we will have worker nodes. Okay, again, once again I can. So we have cluster manager, then we have driver node, then we have worker node. Okay. Now what happens is, inside the worker node we have executors,
Okay.
and inside these executors there are cores. Okay, and each worker node will have some amount of storage associated with it. Okay, and the RDD goes inside this storage. So what happens is, when we fire a query, it goes into cluster manager. Cluster manager then manages, okay, what all how many worker nodes should be associated with it, all of that, and then it gives the query to the driver node. Driver node, what it does is, it distributes that the whole code across multiple worker nodes. So whenever so inside worker node there will always be some executors that are vacant, as in some executors that don't have work. So the driver node divides the work across multiple worker nodes as per the instruction from cluster manager, and then this worker node, it processes that inside the worker node also. There will be multiple executors, and inside the executor these cores takes up this task, and then it processes the data and gives the output back to driver node. The driver node consolidates this output and gives us the final result. So that is the whole story. Now coming back to fault tolerance. So now the RDD, what happens is, this RDD will be spread across multiple worker nodes. Then what happens is, so when I say that this RDD is distributed across multiple worker nodes, there will be multiple partitions of data, and each partition will be replicated in multiple nodes. Why, if you ask me, say one node were to fail, to prevent that, there will be replication. So partitions are replicated. So what happens is, whenever if any node fail, so since this the partition is spread across multiple nodes, whenever a node fail, it can still recover, because it is replicated in other nodes as well, the partition of data. Yeah. Then Databricks does something called lineage. So like I said earlier, RDDs are immutable. Say if we do multiple transformations to one RDD, and finally we create another, we do transformation and refer that to, as in put it in another RDD. If we do all of that, it maintains a lineage. So even if there is a failure at any point in time, database can refer this lineage and recreate the RDD from that point. Then there's the key components of Spark architecture. So we have already discussed what is cluster manager. It's for managing and allocating resources across the Spark cluster. Then we have worker nodes. So worker nodes are what executes the Spark computation. So yeah, then we have executors. Executors run on the worker nodes, and these are responsible for executing tasks assigned to them. Yeah, and each executor, it is responsible for managing a set of tasks and keeping data in memory for faster access.
Okay.
Then we have the driver program. Driver program is the main program that controls the flow of the application. So it runs in a separate node that's different from the worker nodes. Then we talked about RDD, the fundamental data structure. It is immutable and it can process parallelly across the cluster. Yeah, that is about. And then Spark. Then we have two more things like Spark SQL and Spark Streaming. Okay, so Spark SQL. Spark SQL is a module in Spark to process structured and semi-structured data with a programming interface using SQL-like syntax. Say, yeah. So what happens is, let's say if you want to use SQL code for a data frame, how we saw yesterday, yeah. So streaming, what happens is from the streaming data, we could get that data into a data frame and do normal transformations that we do to the data frame. We can do to the streaming data frame also. The only thing is there will be small changes in syntax when we read the stream. When we are reading file, we use the read API, but here we should use read stream. When we write, we use write API. Here we should use write stream. And whenever we want to stop, yeah, that is one thing that's not there in the data frame. We could stop the stream, we could start the stream, we could set it to wait for it, as in we could set that to terminate after some time, or we could check if it is streaming or not. So all of that is coming in later session. You don't have to worry. Next is the overview of Spark job. Spark job is nothing but we could whenever, let's say, where we wrote a set of code and then we give that code, and then when we execute that code, it's nothing but a set of tasks that are submitted and submitted to be executed on the cluster. So that is the whole thing with Spark job. So we have job, we have task, and then we have stages. So this is the level of jobs. So say when we give this any code to for the Databricks to execute, the whole code will be called as job, and that job will further be divided into tasks and stages.
Okay.
Yeah, and each of these stage will be taken up by here we have cores, right? Each core will take up one stage and then execute and then give us the output. Yeah, then talking about Spark jobs. Yeah, so we have the first part is development, the development as in writing the code. The second is job submission. So for job submission, we need to those are just theoretical concepts. As in order to run a code like how you saw, we should have a cluster. If we don't have a cluster, we'll have to create a cluster on the fly and then execute the code.
Okay.
Yeah, and then that is job submission, and then job scheduling. Say if we want to run any notebook, we could create a job for that, and then we could have that execute at any time, any point in time. schedule. As in, I will show you how to schedule a notebook. That is coming in the later session. And then job execution. So at this point, you should already be knowing how the execution works, how massive parallel processing works, how it takes up data and distributes it across multiple worker nodes and does the processing in parallel. Job. And then we have monitor. This also is coming in the later session. I'll show you how to monitor the execution. So when we talk about we have something called performance features. So here I'll be showing you how to monitor if a Databricks cell is running for longer, how to troubleshoot and know what's happening in the background. So in RDD, there are transformations and actions, like I told you earlier, similar to in data frame, how we have transformations and action. We have the same thing in RDDs as well. So what happens is, let's say how I told you, it will take all the steps, and then finally before calling the display function, it will take all of that, creates an optimized plan, and then executes the display function. So this display function, these are called as actions, and all of these are called as transformation. All the steps above are called as transformation, and then the display function, the write, all of that will be called as actions. So that also is coming in later session. How to differentiate between transformations, actions. So the important thing to remember is it's a distributed system. We have a cluster manager, driver, worker. So cluster manager is for managing all of this. Driver divides the entire computational code into and gives into worker node. Worker node takes up this task, does and divides it into stages, gives it into each core. The core processes it, gives it back to the executor. The executor gives it back to worker node. Worker node gives it back to driver node, and driver node gives us the output. So this module is about reading and writing from Databricks. So before starting that, first thing is to understand different file formats. So to start with, we have CSV file. You must be knowing this already, but just to keep CSV is nothing but comma separated values. Here it will be stored in a raw format, as in each there will be each line represents a row, and the columns are separated by commas. So that is comma separated value, row based storage. And then we have JSON, JavaScript object notation. JSON is an example of semi-structured data format here. Yeah, and it is optimized for reading large data sets and provides access to specific columns. So in JSON, the file will be, I'm pausing sharing. I do have a JSON file. Let me get that. If you are aware of JSON, then
yeah, you don't have to show. That's fine. I know what JSON files are.
Yeah, okay. Then we have Parquet files. So Parquet file, the important thing is here it will be columnar storage. So this is a term that you will hear a lot in this space, raw based storage and columnar storage. We'll see what are columnar storage now itself after understanding the file formats.
So when you get the Parquet files, like that's so usually Databricks will just pick up the files from a data lake or a file storage. So essentially we are assuming that the Parquet files are already available, and Databricks is not used to create those Parquet files. Or can you actually do that also?
Yes, we can create, and we will see how to create in this session. We can create Parquet file, we can create JSON file from Databricks.
Okay.
Yeah. Then we have ORC. ORC is another format, optimized row columnar. It's similar to Parquet file. It has columnar storage and everything.
Okay.
Yeah, and then the other things we have Avro format. So it's a binary format and it's mostly used for data serialization. You know the data serialization, right? How we send do serialization, send the data, and then after receiving the data, we do deserialization and get the contents of the data.
I don't know that. I may need to explain that to me. I've not worked with Avro files before.
Okay, so it's nothing but serialization, like say how if you want to send one file from let's say one device to another device, we do serialization and then we send that file. So upon receiving the file, we do deserialization and then we get the contents of the file.
Okay.
Yeah, it's mostly used for sending data across. It's our file. Then we have XML file, extensive markup language. This is used for storing structured data. Yeah. Then we have the text file, TXT files. It's used for storing log data and all other text related data.
Yeah, that's fine.
Yes.
So
Then
usually, in your experience, what kind of files you usually see most often?
most often it will be Parquet file only.
Parquet files, really? Okay.
And maybe somewhere CSV file. JSON file will be very less from my experience. But even if it's JSON file, we could read it. That should not be an issue. I'll show you how to read JSON file also here. Okay, now we will see what are columnar storage. So columnar storage and row-based storage. Row-based storage, you know, right? CSV file, everything will be stored in one row. And then for one particular, say one particular primary key, each all the data will be in one row. But here, when we come to columnar storage, it will be stored in all the column data will be stored in separate columns. So the rows won't be tied together. So when we need a subset of columns and when we are querying and we only need a subset of columns, we only need to get those columns. So that will be faster.
Can you repeat that last statement again? I'm trying to digest that. It will.
Okay. So in row-based storage format, everything will be the storage will be based on row level. So whenever we are trying to query something, we have to go through each row, identify that, and then get the output. But coming to columnar storage, everything will be stored in column. Each column will be stored as separate. And whenever we need to query something, what it does is, and we need a certain set of columns. It only searches those columns and gets the data. So it will be faster rather than going through all of this, all of the rows and then identifying everything. It will be storing a certain set of data, a certain set of the data in one column. It will be storing separately, and then we will be getting that data. Usually, what happens is whenever we mount our ADLS to Databricks, we will get the path using that. So it will start with DBFS itself. Then we will have, let's say, I'm giving a real world example. Whenever we are working in projects, it will always be mounted in ADLS.
Yeah.
So after DBFS, it will be /MNT. This is the mount point.
Yeah.
So you know what is mounting, right? We make a directory in ADLS available to Databricks. So whenever we need to access any file from that mount point, we have to go through DBFS and access it. It's a database file system, mount point, and then from the mount point, you will give the path. So let's say if mount point is inside a container, a folder inside a container. So from that folder, the path after the folder you have to give here, so as to access the file. Got it?
Not completely, Adarsh. If you can explain that a little bit.
Okay, so let's say we mount fs.mount, and then we give the path, and we give our ADLS path to mount, and then we give that mount point as MNDA. Okay, this is the mount point that we have given for this particular path in ADLS. Okay, now here,
How do you? Can you explain that? Like when you say you're giving a mount point, like how do you make those determinations?
that's based on business requirement. So let's say if you have an ADLS path and we need to access the files from that path. That path we will be giving as mount point. Or if you want to access different containers inside a storage account itself, then you will be giving just the storage account here. So from the storage account, we will be traversing to different containers using this part of the code.
And for setup, you can just directly put the ADLS path and the mount point, and you'll be able to pull the files from there, or like don't you need to do any kind of like setup in terms of security and things like that?
Yes. We need to do that. We need to give the access key,
Yeah.
app, all of that. Yeah, that we will be seeing in later session. So we mounting and all is coming in later session. I just showed you how
Okay.
the idea of mounting. How to mount we will see in later session. That is not related to read and write session that we are having today.
Okay. Sure.
Yeah. So the basic idea is we'll have an ADLS path. From that ADLS path, we will be referring as a mount point, and from that mount point, we will give the file, the rest of the path here. That is it. Now,
What when you said
hmm,
that DB utils, what does that exactly do? That function you had there?
yeah, Databricks utility function dbutils.fs. Fs is file system.
Okay.
So if we do dbutils.fs.ls, which is to list the files, and if we give a path, that will okay. Let's see here. So I need to create a new resource. This might take some time. Okay, so what happens is we are trying to check what all files are present inside this particular folder. That is dbutils.fs. Similarly, we have dbutils.mb, we have dbutils.cp to move the files, to copy the files, then to mount dbutils.fs.mount. Yeah, don't worry, all of that is coming in later session.
Okay.
When we play around Databricks here. So this session is exclusive for read. Yeah. So now here, let this complete. Then we will be able to. I'll be able to read the file from the CSV, and then display it here. Specifying schema.
Okay.
So let's say if we are reading a CSV file, and then so whenever we read a CSV file, everything will be interpreted as strings. So let's say if we have a number, or basically the idea is if after reading the file, we want to read in a particular format and then get the file. What I mean is whenever we are creating a table, we will be creating the table using certain data types. Everything won't be varchar. We will have date time, we will have integer and decimal, all of that. Similarly, we could use the same thing here. So, okay. Now, if in order to specify the schema, we need to, there are a few things that you should know before getting started. To specify schema in Databricks, there are certain types in so there is a particular module PySpark.SQL.types, and from this particular there's a particular library PySpark, and from there we are importing certain modules. So from PySpark we need to import struct field and struct type. Then let's say if you're using a string, you need to import string type, and if there are integer, and if there are date time, we could import that as well. Then the second
So
thing
what
is
is
say,
this schema used for exactly? When you say we have to do schema, can you tell me the reason behind it?
yeah. So like I said, so when we are reading a CSV file, everything will be read as string. Right?
Oh, okay.
Yeah. But if our requirement is that the third column is a number, and if you want that number as an integer, whenever we are reading itself, we could specify the schema and read the file to the data frame. So all of the data types in this data frame will have our required schema. Okay. So now, so what is struct field? So struct field is basically to tell database that we are specifying a schema.
Okay.
And struct type is basically to imply that this as in we are providing the details of a particular column. Let's say we are providing the details of an attribute, and there will be three parameters here. The first one will be name of the file, name of the column, and the second one will be type of the column, and the third this argument will be this thing, if the column is nullable or not nullable. Yeah. So here let's see. Okay, now this is done. So here if you see, for this particular, after this path there are multiple files. So all of the files are here, and the thing is this particular thing is very useful, as in since all of these are in list, you can access each of these using say you could put this in a for loop, and you should say for I in this particular thing dot path. If you give that, you can access all of each of these paths separately. Each of these paths will be given to I, and then you could play around with it.
Okay.
Yeah, and then
So
if you
you
want
can
to print,
basically traverse through the entire file
yeah,
directory, right?
yeah, correct. Okay, list has no attribute. Okay, sorry, my bad. So for I, you can give I dot path here. Yeah, so this is very useful that whenever
So
you're
you can just
coding.
okay, so you can basically get a list of whichever file you're looking for and things like that. Okay.
Correct, correct. Yeah. Let me hide the result. Yeah, this I use this very often in my whenever I code. I use this one.
Okay.
So let's say I'm gonna create a small data frame to show you this one. It's the schema. Okay. So we're gonna see first we're gonna import our particular required data frame, required struct types and all the data types. This is how we import different modules from different libraries. This will be the library, and we're gonna import our required modules. We could the one way to import is we could do star, that will import everything, but that is not
Okay.
recommended. Only the just import whatever you need. struct type, struct field, and then we have string type. Then we have integer. And let's say, so if you want to create a sample data frame anytime, this is how you create a sample data frame. Now, to create a sample data frame, spark.create data frame, and then give the particular data here. Okay. Now we'll give df. Then I'll display df and I'll show you how to get the schema also. Types. Okay. Now we have not specified anything. So now df dot print schema. Okay, so this df dot print schema will give us all the list of the schemas. So now here it is string, long, and string. Now we will specify our schema. Schema equal to. First, we will tell that it is schema that we are specifying. Then we will tell it specify a particular column. And then the name of the column will be name, and it's a string type. And then is it nullable? Let's just give it as true. And then for the second column,
Also, you'll basically define the schema for every column,
yeah,
and you have to do this for every time you read a data frame.
no, whenever we so if we are reading the data frame and if it is inferring the wrong schema, so what happens here is it goes inside the file and then it infers the schema and gives the same schema. So if you want a different schema than what is inferred here, then you need to follow this process.
Okay.
Yeah. Age, and then age will give us integer. Okay. So slight change. So struct type is to show that we are defining the giving this schema, and struct field is for each field, each column. My mistake. I said the other way around.
Okay.
And then all of this we need to put inside a list, and then give this to struct type. So earlier it was a long here, so it changed to integer here. So whenever we are reading a file, and if you want to give the schema, we could give dot schema, and we could define a long schema for our file, and then and how we did it here, we could give this to a variable. Let's say it need not be always schema; it is x, and then we could give that x here. Then it will rather than inferring schema, it will keep the schema and then load the file to the particular schema.
Can you repeat this X thing again? I got a little lost.
Okay. So this schema, whatever we
Oh,
define the schema here,
okay. Yeah.
yeah, we put that to variable, and that variable we could give here. And rather than inferring schema, it will refer the schema from this particular variable and then do it.
Okay.
Yeah. So let me hide the response. So now we saw how to define schema. Then, so I've already shown it to you, but I'll show you again. So if you are reading the file from the CSV file, reading the data from the CSV file. So here, if you see, the first column will not be header. In order to make the first column as header, we have dot option, and then we will give header and set that to true. That will basically take the first line as header.
Okay.
Yeah. Then there is something known as schema evolution. So by schema evolution, what it means is, say if we have written this data frame and we did not give schema. So whenever this thing happens, it reads the file to this particular data frame, and then we will run the rest of the code. Basically, what schema evolution means is, if there is a change in schema, if there is the ability of Databricks to handle the change to the structure of the data over time. As in, if there are additional columns added, or if there are additional columns removed, or if there's any data type change of any columns, Databricks can handle that. So basically, the ability is to read one type of schema and give the write it out in a different schema. Read one schema and write a different schema. Write a different schema. Yeah. So basically, what I mean is, over time, if there are columns added or removed, we can still read the data and process the data.
But if the schema changes, how will you manage the schema though? If
So
the
Spark
file,
automatically detects the schema of the input file and then writes only the required data to our output file.
okay,
So let's say if we have df and we took the data from this particular path, and then whenever we are writing the file, let's say, so okay, I'll show you how to write it. So if we do df.select and then give the required column names, here I'm going to give column names, and then if we do to write, we use the write API, spark dot data frame dot write dot format, and then give the particular format dot save. So here, if you see, what happened is, we read the file. So even if there are changes here, we read those changes, and then we get the required column and write it to a different file format, or write it to the same file format even. So the basic idea is, the Spark has the ability to read from a particular schema and then, or particular format, and then write to a different schema and different format. So that is how they handle schema evolution. So even if there are changes that happens to this particular file in the in future, they will be able to handle it.
okay.
Yeah. Yeah. So in tomorrow's session, I will give you more example. Let me also quickly check up if I could get more example. This is one example of how we could handle schema evolution. I'll check for more example in tomorrow's session. Handling header and footer. So how to handle header and footer. Basically, we saw also header. We already saw how to handle header. Option dot option header we give it as true. That will handle the header. Now let's say if there are footer and we want to skip the last 3 rows. So here I'm getting 10,000 rows. Okay. So when reading, let's say if there is a footer, if there are footer in the CSV file and I want to skip those files, we could give footer here. And then since it's 10,000, let's see, I'm going to skip 5,000 rows. The output should just be, okay, what here? Okay. Basically, using this option, we should be able to do it, but somehow I'm not able to do it. Okay, let's try it. Option.
So, question,
Yeah.
others. So all these APIs that you're calling, right? Options, Spark.read, then a dot load. Where do I get an entire library of all those? Like, so I know how to apply.
Yeah, so you could search for PySpark code, and then you'll get the whole list. And that is one thing
What?
with
Sorry, you kind of cut out.
PySpark code. This is the PySpark code that we are using
Yeah.
here. Yeah. So PySpark for Databricks, you could search and you'll get the entire library. That is one thing. Or all of the things I'll be giving here. Everything that I know and I use on a daily basis, I'll be giving here. So you should be good with this.
Okay.
And even in later session, we'll be discussing on Pandas library also.
Okay.
That's another language that we could interact with this thing with a notebook. So that also will be seen. Yeah, so this is how you do with footer, option footer, and give the number, and that will skip the final few files. But somehow here I'm not able to do it. But this is how you do it. I'll check on this and then. And tomorrow, I don't want to waste your time. I'll debug and then I'll see you tomorrow.
Okay.
So let's say, similarly, if you want to skip the first few files, you could quickly skip rows. Yeah, so that worked. So here we had 28. I skipped the first 3 rows and we got 25. This is option to skip the first few rows. Okay. Now the next is to handle delimiter. To handle delimiter, what we could do is we have another option. So let's say if we have what a tabs if you have a tab separated file, so we could use spark.read dot, and in the option we could give delimiter, and then you could give the particular delimiter. Let's say if we have a tab separated file, give /t for the tab separated file. That is one way. Or instead of delimiter, there's one more parameter that you could specify, which is set dot option set, and then set we could give here particular, even if it's line, we could give here. Yeah.
Okay.
Yeah. So that is about it, and then so the next thing is so you in database mostly we will be dealing with Parquet files. So let's see the advantages of Spark using Parquet files. So the most important is it's columnar storage, and to store it requires less space. less space, and then accessing is also faster. Yeah. Then then we have compression in. We could specify the compression for the Parquet files. We have snappy compression, and some snappy is one of the compression type that we use very often. So that you can specify, and that will further reduce the size of the data.
Okay.
Yeah. Then we have encoding, and in encoding, that will increase the query performance, and also it will reduce the size of the file. And it supports predicate pushdown, like what we saw yesterday. Predicate pushdown and column pruning. You remember, right? Predicate pushdown is nothing but if you have a where clause in select.
Yeah. Okay.
Yeah, that will be applied to the source, and we will only read the required columns. That is possible in Parquet 5. And column pruning. Column pruning also will only read the required columns. Yeah. So that is about it. So to get started, we're gonna see first the definition of data frame, and then we will go from there to different functions. So data frame, we have already seen what a data frame is, but from a theoretical perspective, data frame is nothing but it's a distributed collection of data that's organized into main columns, and it is the fundamental data structure in Apache Spark and Databricks. And yeah, that is basically data frame. It's nothing but it's just a collection of data that is organized into columns. Now, coming to benefits of using a data frame, so benefits between data frame and an RDD. RDD, we already saw resilient distributed data set that can be distributed across multiple nodes and processed in parallel. So first point is higher level of abstraction. So when we are comparing that data frame against RDD, here data frame provides higher level of abstraction. So what that means is, say in RDD, as in RDD provides a lower level API, and we have to manage the data layout, serialization, all of that. But when we come to data frame masks all of that from us, and we can efficiently query and process the data. And the second point is schema enforcement.
Can I ask a question here?
Yeah.
When you say RDD versus data frame, right? So, I mean, we discussed some of those data frames in the previous class. So, like, how do you declare an RDD? Like, is there some way to use that, or I haven't seen that, so I was kind of curious.
Yeah. So there is we could declare RDD, but no, this is all about functions. But let me just quickly check. There should be some in one notebook. I think I have already declared an RDD. Yeah. So this is how you
Oh,
create.
okay.
You use so to create a data frame, we use Spark session, and to create an RDD, we use Spark context.
Okay. All right.
Yeah. So all of that is coming in the upcoming session. So you don't have to worry about that right now. Spark context, Spark session, that is coming. Spark session and Spark context, that is coming.
Okay.
Because if I go into that right now, we will deviate from our.
That's long. Okay. All right. Okay. Let's continue
Yeah.
this. Okay.
Yes. So coming to schema enforcement, we saw yesterday we could, while reading a data frame, we could give our particular schema and then read from that data frame. So by schema enforcement, what it means is if there is something wrong in the source, if there's some data type changes or anything in the source, and if you have defined a schema, whenever we are reading the data itself, it will throw an error, and we will be able to catch this error at a much catch the error earlier. That is the whole point of schema enforcement. Then we have performance optimization. So performance optimization, as you already know, we already discussed predicate push down and column pruning. So data frame supports all of that.
Okay.
Yeah. Then it has integration with other tools like machine learning, and all of that can be as in we could give data frame as input to machine learning models. All of that integration with them.
Okay.
These are just theoretical things, but soon we will get into Databricks and see different things. So now coming to differences between RDD and data frame. So the first thing is data representation. So RDD is nothing but collection of objects, whereas as in there won't be any. Let me check. I could show you that. See here, this is how an RDD will look like.
Oh, okay.
Yeah, it'll take some time. So that's how an RDD will look like. But on the other side, a data frame, we saw it is much more organized into rows and schema and all of that.
Okay.
Then schema enforcement. So first one is data representation. Then we have schema enforcement. As you know, data frame enforces schema. It has a set of it will have a schema defined to it, but RDD on the other hand doesn't have schema enforcement. So if we have any mistake or if we have any mismatch in the source, we will be catching it at a very later point in our node. Then there's something called as lazy evaluation. I'll give you I'll tell you what lazy evaluation is. So we already discussed. So if there are 10 lines of code, all of these 10 lines of code will not be executed whenever we write the code, and when we execute the code. In reality, it won't be executed. Only structure of the code will be taken into memory. But whenever we do some actions, like whenever we display or whenever we write to a file, that is when all of these 10 lines of code, it takes the whole thing into memory, it optimizes it, and then runs the code. So that is lazy evaluation. But don't worry, a detailed session is there on lazy evaluation.
Okay.
But yeah. So the thing is, RDDs are lazily evaluated, but whereas in data frame, what it does, it uses catalyst optimizer. So like I said, it will take all of that code into memory and optimizes it and then runs the code. So in between, there's a catalyst optimizer that comes when we are using data frame. So that is about lazy evaluation. An entire session is there on lazy evaluation, so you don't have to worry now. Then yeah, performance, we already know that data frame has more performance because of optimization technique like predicate pushing, predicate push down, column pruning. Yeah, because we have these things, it will only take the required data and then process it, and we'll get the output sooner. Yeah. So then next is interoperability. As in let's say whenever we are using data frame, we could basically use SQL like queries. By SQL like queries, we saw yesterday, we could read a file and then we could, to get the required columns, we could use dot select column name, and that will give us the required column. So we could use such type of code when we are dealing with data frame. but when it comes to RDD, it does not have any SQL interface, or so
Yeah.
we have to use RDD specific method. Okay, now we're gonna see about, so that you must already know. But let me see if I have yesterday's. Yesterday we did create 3 sample. This one. Just for sample records, so that I could show you different methods using this one. Okay, so now let's say out of these 3 columns, I just need just the first 2 columns. Yeah. So if you select, what it does is it will select as only the required columns that we are specifying inside the select.
Hmm.
Yeah. So that is about select. The second thing is, okay, so say if you want to drop a column, so from the data frame, if you want to drop a column, no, yeah, it didn't work. Why it didn't work is because this is the transformation that has to reassign back to our data frame. So here if you
Sorry,
see, sorry.
what happened? Like I missed.
So here if I want to drop a column, this df dot drop and give the particular column name, and that will drop the column. So that happened here. So that is df dot drop.
But you're assigning that back to df, right? So if you
Yes,
do df dot drop column name
it
and you just do display, it will not drop.
it will not drop. So what happens is when I did df dot drop, it as you know, these data frames are immutable. So nothing happened to this. It created a new data frame. It did this particular transformation and created a new data frame. Now what I have to do is the new data frame I have to reassign back to the old data frame,
Okay.
then display it. Instead, if I have given df1, okay, right now that will be gone. Now I have to create the data frame. Then instead, if I given df1, okay. Now here, if you see
Okay.
what happens is, yeah,
I understand. Yeah, because it's okay. I get
immutable.
that. Not a problem. Yeah, because it's mutable. Yeah. And if you just do
Hmm.
display of df dot drop df dot drop column name, will it work?
Display of df dot drop. Yeah, that will work, but that will not make any change to our data frame. So here, what display does is, it is like print in Python.
Yeah.
It just shows
Okay.
us the data frame. Yeah. So if I do inside df dot, inside display, if I do df dot drop, what happens is it will do the transformation. It will create a new data frame and it will show us that data frame. But
Okay.
but that data frame is not assigned to anything right now.
Okay. Sure.
We
Okay.
have to assign that to another variable, and then show. If you want to use that at a later point, you want to assign to a different variable and then use it. Yeah. So the next transformation that comes is filter transformation. So filter is to filter out the records. So since we have 3 records here, let's say df dot filter, and then in the filter, df dot let's say what, age greater than Oops, sorry. Yeah, if you greater than or equal to, you should be getting 2 records. This is how you filter out the records. df.filter.
Okay. And we're putting age over there. Those are not. Is that case sensitive? That is right.
Uh, I
This one
think
from
it should be case sensitive. Let's see. Yeah, it is case
okay.
sensitive. Yes, because we are directly referring to the column using df dot, right? It should be
Hmm.
sensitive. Yeah. And the next thing we're gonna see is group by.
So I have to ask a silly question. Is this is all Python functions, right? Not PySpark, right? These are not. What is this? Is that
And
some
these are
Python?
PySpark, PySpark.
PySpark. Okay.
Yeah.
Okay. Okay. My bad. Thank you.
So now we're gonna see group by. So the group by, let's say, what is the group by on? Okay, group by and say, okay. It's like just how we write a SQL code. If we have to use group
Hmm.
by and then column name, and then I'm gonna get the average age. Yeah, this is how you group by. So the you'll give the column on which you have to aggregate on inside group by, and then whatever you need. As in, if you want a sum, you could give sum here. If you want a average, you could give average here. But don't worry, group by is coming in the upcoming session, so there are advanced things that you could do in group by. What I mean is, you could group by on a particular column, and then you could use something called .agg. And then if you're using .agg, inside .agg, you could give multiple things. Let's say.
Oh, so you're grouping by multiple functions, multiple aggregates, right? That's what you're doing. Okay.
Okay. Average is not defined. Okay. Okay. So here what happened is we need to initially import. But don't worry, those are advanced functions. Those are coming. This AGG and all is coming in the later session. But there are basic things that I need to show you before we move on to those things. Yeah. So that's about grouping, and then the next thing is to sort. To sort, we could use df dot. Same error. It's case sensitive. Yeah,
That the DSC is descending. Okay. Okay. Okay.
descending. Yes. If it's ascending, changes to ASC.
Wherever
Now,
you go, you have to call the data frame dot column, right? Like df dot name. You just can't
yeah,
write name, right? It won't. It
you
won't
know, you
understand that.
can't. You
Okay.
can't write name. df dot range. It has to understand. Yeah, correct. But I don't get ACB. Why it's ACB? It should be ABC.
Is it doing the init caps? Because
Yes. usually import from PySpark or SQL. Oh, look into that. It might have something to do with caps. So this is another way you call each column. From PySpark.sql.function, you can import the column, and then inside here you could give the call, and then you could give the column name. Yeah.
Okay. But you
So
could
there are
directly just give
space or
the column name
so
also.
yes. So if there are space or anything in the name, it's better to use this one rather than the other one won't work.
Oh, okay. Yeah, spaces can be a problem, right? Yeah.
Yeah. So we saw sorting, we saw filtering, and the next thing is there is pivot. So pivot is also advanced function. So let me see. Oh, this should come as column name. Yeah. So here what happened is we grouped on this one, and whatever name it was there, it pivoted the name to column names, and then it gave us the average age in the intersection. That's about pivot. So it's similar to how we do what, let's say, similar to transpose, but only we'll get an aggregate at the intersection of each.
Okay, so essentially, can you just go up one more second? I'm trying to understand that. So you're saying that you need to
One second. Let me. I'll give the other one as well, so it'll be easier to understand. Yeah.
Sorry, what was the other one? I didn't see that.
The normal data frame. So from this data, what happened here is we grouped on this one. So this row 2 and row 3 became one group. Row 1 is another group. So based on this group, now I said I need to pivot my column name. So this column name we did a transpose to here, and these names appeared as our column names. Whatever was in this column appeared as column name, and when in the intersection of this one and this intersection of our particular whatever we used in the group by and in our column name, I want the aggregate of the average. So it could be average, it could be some aggregate function we have to give here. So this will come in the intersection.
Okay.
So if you see here for female and for Alice came here female, and the intersection it is 25. Similarly for Charlie and Charlie male, intersection is 56. That's what happens in pivot.
Okay.
Yeah. Then the next thing is distinct. So to do distinct, okay. So let's say I'm gonna select df.select. We will be getting just 3 records here. Yeah, 2 male and 1 female. So if to remove that, if I do df.distinct, it will give us 2 records. Distinct.
Missed to see that. Yeah.
that is about distinct. Next is join. So to join, we need one more data frame. Let me create one more data frame. We'll give the same schema. Change the name. Okay. Alan Cohort. Help me out here with names, please.
Write some ABC. Nobody cares. Adarsh.
No, yeah, but we'll later in. Okay,
Okay,
yeah.
right. Give Max.
So, hmm.
Give Jennifer or something like that. Yeah. Who cares, man? Just write ABC. It's okay.
Yeah, I understand, but so we will give one as TF1 and then data as data1. That's okay. Hmm. Okay, so that makes sense, and yeah, we will join them on the base of age. So to join two data frame, the basic syntax is df dot join, and inside the join, so, we are joining with df1, and we are using df dot age. We're joining with df1.age. We could either, it's the same thing here. To call a column, we could either use this, or we could use import from PySpark.sql.function import call, and df.call we could use. No, we just use call and then get the output.
Okay, just data frame 1 dot column name equal to data frame 2 dot column name, right? That's all it is, pretty much.
Yes, correct. And then if you do what type of join we are doing, we can keep that here.
Oh, okay.
Also, we should keep equal to equal to. Data frame has no attribute age, just caps. Yeah, so that's how we join.
What was the error? Sorry, I didn't understand.
So error was the same error, case sensitive.
Oh, okay.
Yeah. I'll show you the other way as well if you are getting me. One second, this is another way to call.
This is to prevent the.
No, what I'm trying to do here is this is to if there are space in the column name. Okay. That did not work. I was trying out if that work or not, but there's an
Curved
easier
brackets,
way.
is it? Okay. So df.
df I'll be putting inside.
Oh, okay.
df dot here. Hey, it's showing invalid syntax.
Functions dot import, right?
Oh, okay.
Space import. Sorry. Yeah. Is it? Because df dot
Yeah.
df df dot column, right? Or df
One second.
dot column open braces age, right?
Yeah, we could use that as well, but so
Oh, you signed something else. Okay, okay. I'll let you do that. Sorry, my bad.
no, it's okay. You could 1 second. Mostly you won't get space inside, but if there's a chance that you get, then it will be an issue. Yeah. Okay. So that worked. So this is how you should do, and when you're getting when you're doing join, and if there's space in between.
Okay.
Yeah. Now the next thing is gonna be about we have seen join. Next is gonna be let's see to add a new column. So that actually that is coming in the later session, but still I'll give you a glimpse here. Let's say you want to add a new column. The column is okay. We do the same. Yeah. So if you want to give a fixed value for all column, you use lit. Lit is to show that this is a literal value, and it should be there in for each of the record. And to add a new column, use with column. And let's say if you want to rename this column, you use show that as well. Column renamed. Yeah, that's how you rename a column. You use the function with column renamed.
Okay.
And you could it need not always be lit 11, so you could give what age into 10 maybe. So we can't just give age, we have to give df dot age. Yeah, you could do anything. How you do in SQL, you could do similar things here.
Okay.
Now yeah, so that is about common methods in data frame. DB utils, like it's a utility method in Azure Databricks, and it allows us to interact with various database services. Like it allows us to interact with file system. How we saw yesterday, dbutils.fs, we could use that and access the file system, and then it will give us to access to databases. Then clusters, we could manage the cluster using Databricks utilities. So these are all the things that DB-utils offers us. We could manage each of these using DB-utils. So I'll show you some common methods. One thing is dbutils.fs. This will give us access to file system. And say if you want to copy a file, dbutils.fs.cp, and then we give the path. I need the path now. Take our path from here. Now, if you want to copy this file to another location, tables fs. Now that will move to this particular location. Now I want to list down all the files that is present there. So, but what I want is I want you to see if whenever I'm making some error, how I want you to know how I'm fixing that and how I'm
Okay.
trying to decipher the error. So that I want you to know.
Yeah.
So,
I have many questions about this DB utils and how this file system and all these things. I mean, I don't know whether I can ask today. I'll let you finish today 10:30 my time. But I have questions
yeah.
to like how the entire process works with the file system and in your projects, do you get data in the files or do you get it as tables and you're using it as tables? And I wanted to understand how that is, how you're doing that.
Okay, so in my project, what I'm currently doing is it's mostly in external table. So those files will only be getting files. So those files
Okay.
will load to a location. And how we saw yesterday, we create table and we refer to that particular location. And when we query from the table, we'll get the data from the file. So that is
Okay.
how we usually do. And yeah,
So essentially you'll just create an external table and keep it and you'll be querying from the table pretty much.
correct,
And
correct,
and, and
correct.
the
Yeah,
and the external table points to the files, right? Basically that's what it is.
correct. That's what it is.
Okay. Okay.
Yeah. So this is how you run. If you have another notebook and you want to run another notebook in this notebook, you use this code dbutils.notebook.run and you run the notebook. And then we could also, yeah, that is how you run the notebook. Another notebook in this notebook. Yeah. Next, then is
Oh,
yeah, that is something that you could do. Next is dbutils.secrets. So these secrets are coming in the upcoming session. So I'll tell you all about what secrets are and how to configure secrets, all of that. So you just this is another feature that dbutils offers. That's the only thing about dbutils.secrets. Okay, so I'll tell you what happens. So in the code, we are not supposed to give any of our access keys or anything. So for that, we will create initially we'll create a key vault, and we will store all of that in Azure Key Vault. And when coming to here, what happens is here we will do secret scope credential, and then we will create a secret and store the key in here as a secret, and we'll get a secret ID. That secret ID we will be referring here and getting the secret out of it. So initially the secret is nothing but our key from Key Vault.
okay.
Yeah.
So that basically you'll get that ID and you'll just be using the ID, is it? That's all pretty much.
Yes. 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 So basic thing is we will have a secret. We will store that in the key vault. We'll get that key. That key we will store here as a secret, and the secret ID we will be using. So we have no connection to the access key at all. Through the secret, we'll go and get it. So all of that is coming later session. I just want to give you a glimpse here. Yeah. Then yeah. So
This is
then
how you store your accesses for the. I mean, your any other. Okay, you know what? I'll let you finish because I have many questions, but I'm getting too deep into it right now, so not a problem. Let's continue.
okay. So just note down the questions, or you can even mail them to me. I'll go through it. If I'm not getting anything now, I'll refer something and then I'll get your answers by tomorrow.
Okay, I mean, but that's just I'm just having like beginner questions, right? These are not difficult questions, so I'm sure.
That's completely fine. That's completely
Okay.
fine.
Okay.
So we saw how we could set a number of worker nodes. We know worker nodes now, right? We will have a cluster manager, we'll have a driver, and driver will divide our code to multiple nodes, and we will have worker nodes.
Hmm.
So we could set how many worker nodes we need, all of that here. Say if we have, we need to scale up to 10, or if we have 15, we could do that here.
Doesn't it
So
auto
that
scale?
is how we,
No, it doesn't auto scale.
it does auto scale. In case if we have it enabled, so in cluster we have to enable auto scale, right? So if we haven't enabled that, we could do that here based on our particular requirement.
Okay.
Yeah. Then then there's something called as dbUs.widget. So widget, what are widgets? So initially, if you are giving some, if we write the notebook and there are some parameters. So to give the parameters, we could create widgets. So here I'm gonna create a widget, and inside the widget I'm gonna give name as widget name, and then I'm gonna give a list of values as default value. Sorry, as the drop down, we should get these values: value 1, value 2. What is that? What is that I'm getting?
Sorry, I didn't understand what the widget actually does.
So if in case if you have parameter, and
Okay.
say if you have a parameter, and then if you we can't go inside the code and change every time, right? So to do that, what widget does is, whenever we create a widget, so we will get an option here that says we could access the widget from there. But I'm not sure why I'm getting this. It's widgets. This is selection sequence must include default value. Yeah. So this is a widget.
Oh, that's what. Okay. 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 I see what
Yeah.
you're saying.
But if so if you wanna access the widget, so dbUs.widgets.get, you could use that and access your particular widget and give the widget name. I'll give you the default value. Say if I have selected 2 here, then you get the default value. So the use is, say if you have some SQL code or anything where you want a particular year, and you could set that year here, and whenever you're selecting that, that will get automatically updated here, and you could just click on run all the code, so you don't have to touch the code anymore.
Can you come again? Can you repeat that? So.
So if you
I didn't
have
get it.
any say if you have a SQL code, or if you have a PySpark code, where so we were using filter, right? So inside filter, say I could show you an example. So here we were using filter. So in filter we were using greater than 50 or something. So in the code we don't have to touch the code anymore. In the
Okay,
code
you
we
just put
could
50 there.
yes, instead of 50 we will put this particular value, and then in the drop down we will get all the values here, and then just click on it, and then we will get the value.
Oh, okay.
Yeah, so there are multiple ways to create a widget. One is a drop down, and there is also something else called the text box. So text box is nothing but you could instead of drop down there will be text box. I can show you an example. Actually, they follow camel case. Yeah, so there is textbooks. I'll show you tomorrow. Then the next thing is we already saw how to in dbutils.fs how to list down the file. Then we could read a particular file. So dbutils.fs we could use head to read the first maybe 10 lines or so of a file. So let me see. Usually we do this with text file, try with CSV file as well. Okay, so it works with text file. So if you want to read the first 10 lines of a text file, you use dbutils.fs.head, give the path here, and then give the number of lines you want to read. So that is how you read. But usually we don't use this. It's just for theory purpose. We will read the file to a data frame and play with it.
Okay.
Now if you want to put some file from our local to Databricks, we could use dbutils.fs.put command. So this put command and all is very useful because when you go to Snowflake also, it is very similar to Databricks. So there also you'll have put command. There also you'll have external table, all of that.
Yeah. Yep.
Yeah. So so in put command, you give the your local path here and your DBFS path here. So that is about put command.
That's basically just to dump the data into a file system somewhere, right? That's all it is. After you do the calculations or whatever.
No, this put command is basically to put file from our local path. So this local path is my local from my system. If I want to put something to Databricks file system, I could use the
Oh,
put
that.
command.
Okay. Putting.
Yeah,
Okay.
yeah, that is what. So in just to give you an idea, in Snowflake also there's the same thing. We could use put. So in Snowflake, what happens is there will be stage. So using put command, we move our file to a stage. Then from the stage, we will copy to table. So this put
Yeah.
command it's universal from local system to the file system in cloud. So that is about put command. Then to remove a particular file. So let's say that is dbutils.fs.rm and give the whole path of the file. Yeah. So now it will just remove this file. So you're getting true because that file has been removed. You'll get false because it is already removed. Second time you run it, it's not there. You're getting false. Now to create a directory, you use dbutils.fs.mkdir. That will make a directory. So let's say you want that will just yeah. Tell me.
When you put the path, right, dbfs / file store, those things remain same as they are across all the
No.
like when
This just this part remains the same. dbfs dot
okay.
this part. So this is to imply that this is part of the Databricks file system. The rest
Okay.
of the path changes. So I'm just taking this because I already have a path. So I just took this. It could be any path. So from here to here, it's up to you. You can decide what path you need. We can create
Yeah.
primary keys. So we could do that. How we create a primary key on a normal table, create table, and finally we'll add constraint, name of the constraint, and
Yeah.
primary key. And if it's a composite primary key, you'll give the columns names there. We could do the same thing here, and that is one way of doing it. The second way is from your data frame. If you have a composite key, you could combine multiple columns and create a new column. And then from that column, you could drop duplicates from that column. And then from that data frame, you could you could convert that data frame to a table and then add constraints over it. That is another way. That's like two ways of adding constraints is what I said.
So when you the first way, right, when you're adding constraints to a table, what sort of table is that? Is that an external table or like?
No, internal table. One is creating constraints in table. So that also two ways you can do while creating the table or by altering the table.
Okay.
Then the second way is from a data frame, concatenate all composite primary keys, and then use drop duplicate function, and then give then new column name that contains all the concatenated information. Then convert this to table. For that, you could use dot save as table, and then give the table name. So yeah, then you could add the constraint, as in then you could alter the table and alter table name, then add your constraint name, then primary key.
So question here, right? So when
Yeah.
you say on the first one, right, you're creating a table.
Hmm.
So when you read data from the source files, okay,
Hmm.
or the Parquet files or whatever, you're going to read that
Yeah.
into a
Hmm.
data frame. Then you'll create the
Hmm.
table, and
Hmm.
then then what will do? How will you push the data into the table?
Yeah. So for pushing the data into table, there are two ways of doing it. So let's say you create a table external, as in you create a table in a separate cell, like how we create table in SQL Server. You use create
Yeah.
table name and then give all of the constraint everything, and then you define the primary key there itself. Okay.
Yeah.
In that case, if you want to insert the data from your data frame into your table, you should first create. There also in that also there are multiple ways of doing it. One is you could create a temporary view from the data frame using
Okay.
this thing. Create or replace temp view. We already saw, right? So it is nothing but create or replace temp view, and then use this temp view in normal SQL code. Replace temp view and then new view name, and then use person SQL, and you could give insert into your table, and then select if you need the required column, you could give that, or select star from view. Yeah,
Or is
that
it
is
like, is it
yeah.
possible to you mentioned that you use external tables, so you'll create an external table from the source files,
Mm.
and then can you just do insert into table, select star from external table?
Yeah, yes, we could do that. But first, you will have to from the external. Yes, you can do that. You are basically asking from external table if you could move that data to internal table. Right?
Yeah, but we'll
Yeah,
have
we
to be
can do
careful,
that.
right? Because there'll be duplicates and all those things. If you have constraints, then they'll error out.
Yeah,
So
that yeah, but that filtering you will have to do before you copy it into your internal table, because internal table does has constraint and external table there won't be any constraint,
yeah,
because those are files, right? It's up to us what
yeah, it's a
we
file.
can't
Yeah,
apply.
it's raw data. Yeah.
Yeah.
So when you
Yeah, so you
just
can
what?
do that.
So when you say
Yes.
create a temp view, right? I'm forget this. Like, so temp view, that you can create a temp view from a you can create a temp
Session.
view from the data frame itself, right?
Yeah, the code will be df dot create or replace temp view.
df dot create or replace temp view of colon whatever brackets name.
Yeah, your new view name. To begin with, we have Azure Data Frame column. So first thing to understand is what is data frame. Data frame is nothing but a collection of data that is organized into columns. And then we have column expressions. These column expressions are used in data frame operations like filtering, sorting, grouping, aggregating, all of that. So we will get started. We'll show you examples of each, and then we will go like that. To create a new resource, create a test and run. Okay, it might take some time for it to get started. I'll start explaining things. Maybe I have the result here. Oh, okay, I have the result. Okay, so what happens is this. This is one of the function. So the first thing is call. So we already saw how we could call how we if you want to use a particular column in our data frame code, we could use the call column expression. So let's say if you use call name, we are just how in SQL Server we just write the column name. We could it's the same meaning
Yeah.
here. Yeah.
Okay.
So yeah, this code is like in SQL Server we have case when, right?
Case when. Yep. Okay.
Yeah. So that is what's happening here. So if you have when this is the if condition, and then if this if condition is true, then this is the output that we want to give, and else we should be giving this. So here if you see, I have given when name is Alice, then give the name, else I should give a name. So if you see here, we have Alice, Bob, and Charlie. So we can see the output as only Alice. So this is case when. Now, so yeah, so like I was saying, the first column expression is COL to call a particular column, and then we have EXPR. So what EXPR does is if we have if you want to do any type of transformation to a column, like let's say here if I want to add some number to the existing column, I could use EXPR. So it's nothing but it's saying that this is an expression. I'll calculate this expression and give me the output. That's EXPR. And then we have alias. So alias is nothing but I'm just giving a new name. How we have AS function in SQL. So that's alias. And then dot sort. Dot sort is similar to order by in SQL. So we do the sorting, and then I'm calling this particular column and saying that I need it on the descending order.
So
okay?
question here, Adarsh, like
Yes.
so you have all these functions on data frames, right? So there are each of these things. There are so many of these, all these. You're calling all these methods and all these things, right? My question was like, if I wanted to write this in SQL, how will I write it? Like I'm just trying
Yeah.
to, So if you can just show me that, I know it's pretty straightforward. So if you can just show me that, I'll be grateful.
Sure. So what you're basically asking, if you want to do this transformation in SQL, right?
Yeah, in this data frame
Okay.
transformation in SQL, yeah, which is
Yeah.
faster though, also.
Which is faster you're asking?
Yeah, so to put the code out
Emma?
in SQL and then show which is faster.
No, this is faster. So PySpark code is faster. Say if you want to use SQL, what happens is you need to first convert this data frame, like how we saw here. You need to first convert it into a temporary view.
Okay.
So that will take time. That is one thing. And then you have to do the transformation on top of this view.
Okay, so there's one more step.
One additional step. Yeah. So that is more expensive. But this is very once you get the hang of it, this is very similar. This is
Okay.
how we do select. By select,
Yeah.
we need the required columns.
Yeah.
So what I'm trying to do in this session is basically relate PySpark code as much as possible to SQL code, so that you will
Sure.
get the hang of it. Yeah.
Okay.
So here we are doing select, and here we are doing sort. Sort is nothing but order by in SQL. Yeah. And alias is as. Expression is expression is nothing but an expression. It says compute this expression and give me the output.
Okay.
Yeah. So okay. Then column expression can be used with other data frame APIs like we have filter, select, group by, aggregate function, all of that. Then overview of column class and methods. Okay. So column class is used to represent a column in a data frame, and then so it's nothing but the column class provides us a way to manipulate the particular column. So we already saw all of these this alias is one of the method of column class. Then inside the sort we could use DESC, ASC. That is one thing. And then here we're gonna see this thing is null. So what this does is it gives us the binary output. So if this column is null, then this will return true.
Okay.
And if that particular column is not null, this will return true. And if it is null, this will return false. So both these will be inverse. And then how we have like statement in the where condition in SQL, we will use like statement. Similarly, we could use it here as well.
Okay.
Yeah. So, that is another thing. So this is how the output will look like. Right now we do have data. So is null will show us false only, and coming to is not null, it will the output will be true. And name like Alice, we have only one Alice. The rest two are Bob and Charlie. So we have only one true.
Okay.
Okay. Yeah. So the next thing is in. So what here what happens is by is in we could give a list of values, and this also gives a binary output, and ask it to check like if the value is present inside this list, then give me true, else it should be false. So okay, let me add Bob as well, so let's see the change. Okay, so that is about the first thing. Then if it contains air, then return true. Then we could so there is something like between, similar to in SQL how we have between. It's the same logic here as well. So if we could tell column between this particular these two ages,
Okay.
and then it will give us the output. So let's execute this. To run the cluster is not yet started only.
It's taking a long time for no reason, is it?
Yeah. We have Alice Bob. Okay. It should, in this case, sensitive. You see, we have two true here. Earlier we had one true because there was only Alice. Now we have Bob as well. So the first one is returning true, and these are just Boolean output. So it will be like this.
What was the
Okay.
function to rename the columns? Just curious. That was
Sure. Alias. So
oh, that alias. Okay.
yeah.
Okay.
And one other thing is, say if you wanna download all the rows, you could download all the rows as a CSV file and then do analysis over it. So that you will be using doing a lot often.
Oh, okay. That's very helpful.
Yeah.
A lot of the older SQL, the consoles didn't have that. It used to be very
Hmm.
difficult to validate results from a query. It used to take a lot of
Yeah.
time.
Okay. So the next thing is, this is how we will be casting. So casting to a different data type. So let's see. So to get the schema of a file for a particular data frame, we could use print schema,
Okay.
tf.print schema, and that will tell the age is right now integer. Okay. Now what I'm gonna do is I'm gonna cast it to a different data type, and then we will see df equal to df. I thought we could do star as well. Okay. Hmm. Gonna call name and then what age is ambiguous. Age b age. Okay, why am I getting this one? To age or what? Oh, okay.
There are two ages there. That's why I think, right? Yeah.
Yeah. Okay, I'll do it again. Yeah. Yeah. So now if you see here, okay, the first one itself is showing as double. Then I'll some changes to it. Yeah. So first is double, and then I cast it to another data type. So that's what you see here. And then I reassign it back to the same data frame. So that is
Oh, you're
the
just gonna put it back into the same. Okay. Okay.
yeah. That's why I did print schema for both, and these are the two schema. First one has had double, change the data type in line 2, and now we have integer.
Okay.
Now this thing, this is how we get the take the substring. It starts from first index and goes till 3. That's about substring. Then yeah, then the next thing that we're gonna see.
Quick question. So, I have
Yeah.
a question about the schemas, right? I was looking up. There was some way to automatically get a schema without having to declare it, right? What what is that? I didn't quite understand that clearly. So there's some way to just automatically get the schema without declaring it.
Yeah. So the actually to get for the schema, there are 3 ways to get the schema.
Okay.
So the first way is it infers the schema on its own,
Yeah, that's what I was talking.
and
Yeah.
yeah, then the second way is this thing where we could define our custom schema, And the third way is using Scala code, we could get the schema.
Okay.
Yeah, that is using Scala, we could do that. But yeah, right now I don't have that on the top of my head because I don't use this much often. But I'll look it up and give that to you in next session.
Which one is the usual best practice to define the schema, right? Because that way you can control it.
Yes, defining the schema. We ourselves will be defining the schema and then making the changes. So mostly I use this only, the defining schema.
So when it infers the schema, what does it do? It will just review the columns and see if this is a number or if this is a double or this is that text. It will convert that, right, based on that, right?
No, if it's a CSV file, everything will be string data type.
Oh, so even when it's inferring the schema, it will do just it'll put everything as string.
Yeah, so whatever data type is there in the source, it will take that. But let's say that's for CSV file. Let's say in Parquet, the data type will be tied along with the data in the source, as in Parquet files. So when it infers schema from Parquet, it will take. It won't do anything. It will take whatever is in source. It will take that.
Okay.
That's the whole idea. If you want to have control, we could define the schema, and we could get the schema from the source as well, and then make changes on top of it using Scala. But yeah, this code I'll show it to you tomorrow.
Sure.
I have it written somewhere in my notes, but yeah, I don't remember that. Okay, so then coming to substring. So substring is similar to SQL. Starting index is this one, and then ending index is this one.
Yeah.
Then yeah. Okay, so this is important. So this is how you add a new column. Now we have a scene. Okay, so df dot with column. Here you're adding a new column. This will be new column name, and what should be the contents of the new column? That's this one. So here what I'm doing is, so let's say if you wanna add a new column, and then all of the column value should be constant string. Let's say you want to add a new column and the contents of the column should be high. All the columns should have high as string. So in that case, you should use literal value, lit, and then give your particular string here. This is to add constant string. That's lit. So here what I'm doing is I'm using concatenate function, and then I'm concatenating my name, and I'm giving between a name and this particular column. Lit new. I'm between name and the literal value. I'm concatenating, and then giving this as a new column. That is happening here.
Okay, so you're basically
The,
concatenating a column name with a literal string. That's what you're doing
yeah,
with the literal value.
correct,
Okay.
correct. Yeah. So that is happening there, and then here we're gonna see. Okay. So here we are filtering our particular data frame, and I'm giving the filter condition. This is something that you will be using very often. So these two, adding new column. Let's say if you want to replace the existing column with a new column, you could just give that here. Let's say I'm gonna replace name with a new name. So that's what happened here. To replace the existing column also, you could use this function. Just give the same column name here, that will replace. Or if you want to add a new column, you can do that here.
You just change name back to name, or
No. So here, right now what happened? Okay, right now what happened is I added a new column. Okay, and
okay, yeah.
Let's say now what I want to do is I want to change this. I want to replace this column with the new values. So I gave the same column name as this one, and then if I execute, it renamed, as in it replaced the old column with a new column. That is with
Oh,
column
okay.
function. Yeah. So the next thing is filter. So filter is like the where condition in our SQL. So it is very how do I put it? So
Yeah, this is straightforward.
let's it's very straightforward. So and this also you'll be using very often. And if you want to combine two values together, yeah. If you want to add, this is like and in our SQL. The only thing is you should two condition. You could give and here, and the only thing is you should encapsulate both of this in brackets before you use the and. So this note, this is one condition, the other one is one condition. Then let me see, give me 1 second. Okay. So similar to filter, we could use where. So the only difference is we need to give include all of this inside single inverted commas. So here I'm using where, and here it's different. So and I could use
Oh, like that. Okay.
so this will be very similar to SQL. The things you have to use two equal sign here. Yeah. So if you have to include all of this in single inverted comma, and if you're using string inside, you have to give double inverted comma inside.
Oh, okay, because
That's
it's a string within
condition.
a string literal. Okay.
Correct. So that's with where condition. Yeah. So the next thing is similar to how we saw earlier, we could use is in and then give a list of values, and if the values are inside this the list, then only return the value. So the thing is, these the functions with a list, you have to be careful because those things you will be using more often, because we could integrate PySpark with Python. So using Python, because there might be something that in your project where you get the values inside a list. Then if you want to do manipulations from, you could incorporate that list inside your PySpark code. So that is what happened here. So let's say I have 25 age here. So here now you can see we have two output. So what it does is it checks if the age is within the values that's present here. If it is, it will give us the output. Starts with AL. This is like using like and then first giving the first two values and the percentage sign. If it starts with AL, it will give us the output. Yeah. So this is group by. So here what we are going to do is we're going to group it by sex. Then this is different from SQL. So in SQL, let's say no, this is also similar to SQL. In SQL also we could group by. So what so in the back end what happens is in using the data frame, if we group it by a particular column, it will convert this to an object, to a group object. So I will show you that. See, this is an object, group data object, and this is the position that it takes. That is not important. So the important thing is it converts it to an object, and then from that object we are using .agg and getting and then giving multiple aggregate functions inside on this particular object. So basically I'm telling it I want to aggregate, and these are the functions that I'm going to give to aggregate. Yeah, that is happening here. Then yeah, so this is how you get today's date, as in similar to get date in SQL. Here we have current timestamp. So
Okay.
that will give us today's date. Yeah. Then yeah. So here what I'm doing, basically what I'm doing is I'm adding. So to this date, I'm gonna add 7 days. So I did this yesterday. So with one more day today. So from this particular day, I'm adding 7 days. That is happening here, and then from so here we created the date column. From there, from that date, I'm extracting the year. If you want month, you could replace the year with month. You will get the month, day, all of that you will get here. So that is about dealing with date. Huh. So this is okay. So next we have this is nothing but sort. We already saw what is sort, and similar to sort, we have order by also. So here, so somehow this is not working in this particular cell. Yeah, but that's the two code for sorting. One is if you could use order by, or you could use sort, and then call the particular column, and then use ASC, and then if you want to sort it using some other column, and then you want to sort that column in the descending order, you could do that as well.
Mm.
Yes, that is happening here. Okay, so now coming to window function. So you must already be knowing window functions in SQL. We have row.
Yeah.
There are multiple types of window functions. Yeah. So here we're gonna see running total, rolling average. So these three we're gonna see. So to start with, basically here we are defining the window. So here I'm partitioning by sex and then ordering it by age. This is just a rank function. And then
You
so
don't need
here,
like you can. Do you need to use rank with window function? You can use rank directly, right?
yeah. So here what I'm you could use a rank directly, but here what I'm doing is I want to partition it based on sex and show you how the rank functions. Let's say if you want to get what so from a group you want the oldest member, so I could use rank, and then and then finally I could from here I could filter it out where rank equal to 1, and I'll get the oldest member in each group. So that is what happened here. Yeah. So here what I'm doing is you already should already be knowing this with column. With column is to add a new column. So I'm adding a new column named rank, and I'm calling the rank function, and I'm using the over clause, and then I'm defining and I want it over this particular window. So in this window, so for the first one there's only 1, so the rank is 1, and in the second one I have 1 and 2, because this is the oldest. This has 56 and then this is 50. So that is about a rank function. Now similarly, there are three types of functions. One is three types of window function. One is the ranking, one is aggregate, and then we have analytic functions like lag, lead, all of that. So the second one we're gonna see is the aggregate function. So this is running average. So here there is something called unbounded preceding. So by running total, what happens is, say if in here, so here also I'm partitioning based on sex. So here, in the first one, it will be just this one. In the second one, in the first record, it will be 50. And the second record, it should be 50 plus 56. And if there's a third record, it should be 50, 56, and that record. So how to calculate that running total is, here in the window, I'm defining the window as a dynamic window. And I'm saying all the particular records in my window till my current record. That is about unbounded. That is unbounded preceding. All the records above till the current. So that I'm doing here, and then I'm taking the sum over this particular window. That's running total.
So you can do moving averages with this also, right? Because every time a data element gets added, you can create the moving average, rolling average, or whatever
Yeah.
you want it.
Yes, rolling average. That's the second thing that I was gonna say. Yeah. So there also, if you give unbounded proceeding and then and this zero, what the zero signifies is your current row. So you could use that, create a dynamic window, and it will function on its own. So here, what I did is here I took rows. So the 2 rows above and my current row. So that is the average that I'm taking here, but I don't have 2 rows above. So here, the first 2 will be same, and then coming to, so don't look at this rank. This is from the earlier one.
Okay.
So here, yeah, and then let's say in
So when
the
you
third
say
one,
rows between -2 and 0, what does that mean exactly? Like I didn't quite understand that.
the 2 rows above my current row.
Okay, it'll give you the rolling average for 2 rows above the current row, is it?
Correct. Yeah. Okay. Window is not defined. I have to execute this. So before executing the window function, you need to import window. Before using rank, you need to import rank from PySpark.sql.window. Okay, so this is a library, and then from this library we are importing this particular module.
Okay.
Yeah, so that is happening here, and then okay, so in order by like how we used to use col dot pds. Yeah, so that is happening here. That is rolling average. Then the yeah,
So
you
just one
have
second, right? So when you say, can you scroll up? I just want to look at that window. That so you're partitioning by, okay, by sex, order by column, okay, and then you're saying rows between -2 and 0. So
it need not be always -2. I just took an example. It could be -1 as well. So just
so
the row
minus,
above. Yeah,
okay. So it'll just to give you the average between the rows above and the one and the current row.
correct.
Okay, and you
And
can
that
do,
order is, and this defines the order. And yes, you can do.
okay.
Yeah, sorry, you were saying you can do what?
So like for instance, on the first cell, age 25, so it's giving 25 because it's the first one. So
Mm.
second column, second you have age 56, so it should give
No,
25 and 56, right?
I have partitioned
Average.
by sex type. Here I have partitioned by
Uh,
sex. This
okay,
could be one partition. That is why it's giving this thing. And these
okay,
two are
got
one
it.
partition. Yeah. Okay. Next thing is join. So this is one of the best practice that you could use, and this will be more efficient also. That is broadcast joining. So let's say you have one data frame, a small data frame, and you have a large data frame. So it is advisable to do broadcast joining when one of the data frame is small. So what broadcast join does is it takes your particular data frame and it sends that data frame across all of the nodes. So you know the architecture right now, right? There will be a driver node, worker node, and inside the worker node, there will be multiple cores and all of that. So to each node, we will be sending a copy of this data frame. That is broadcast sharing, so that we could reduce shuffle.
Okay.
Yeah. So shuffle, if you remember from last session, is nothing but whenever one node needs data. Uh, needs data and it doesn't have the required data, so in that case the data has to move from other node to this node, so then that data movement we call it as shuffle. So to reduce that data movement we could use broadcast join, but it sends the whole data frame to all of the node. So if both data frames are huge, we should not use broadcast join because it will have negative
Okay.
implication. Yeah. Then here now we're gonna see about user-defined functions. So, I'll tell you as per these are user-defined functions, but it is not very advisable to use user-defined functions. I'll tell you the reason why. So the first part of one second. Let me see if I have missed anything in my notes. Yeah, we have seen logical expression. So we have seen grouping and aggregating data. We have seen the case when also we have seen window function processing. Yes. Yeah. So okay, coming to UDF. So UDF are basically to apply custom transformation to a data frame. So first thing is first we need to define the particular UDF. So here what I'm doing is I'm using the upper function and converting. So whatever I'm defining here, I have to convert that to an upper function. So here I'm defining my UDF, and then in second line, here from this library I'm importing a UDF module, and here I'm registering my UDF. Yeah. So first we have to define the UDF, then we have to register the UDF, then we could use the UDF in our normal code. So here now what this does is it takes each of the record and then it applies whatever function we have defined here, and then it gives us the output. So if you see here, it will convert our name. It goes here, it applies upper function and converts the name into uppercase. But why I said we should not be using this is we should be because we'll be dealing with large number of data, so large data, and then to do the transformation in a row by row manner is not at all efficient. So this should be our last resort.
So when you say row by row, I don't understand. What doesn't all transformations happen row by row?
No. So these transformations happen in bulk. So this let's say what let's take any transformation. So even if you're using filter transformation also, it takes the complete data, and then from the whole data, it just picks whatever data is required. But here, what happens is it goes into each row, iterates each row, and then gets us the output. Where is that?
Okay, so it's
That's
basically
about
applying
user
UDF to every row, one by one. It's going.
every
Is
row.
it?
Yeah. And the
So
whole
when you're
idea
using,
of
sorry,
no,
go ahead.
please go ahead.
So I was saying that. So in other cases like filter, you were just it was just able to apply to that particular whatever the value is looking at. But here, every row it will be going one by one. Okay.
Correct. Yeah. So it iterates through each row, so that is not at all efficient. Yeah. So the next thing we're gonna look at is how to handle null value. Here, what happens is, say if we have any null value in any column, then it will basically drop that particular record. And say initially it will be going in record level, but if you want, we could define another access also. And if we give access equal to 0, okay. So so drop when I have to check. Yeah, I'll check this out, and then when I'm sending the note, I'll send it to you. So basically what happens is there is a parameter inside, and when we give that particular parameter, it will check between the if say if any of the rows in one of the row, if we have a null value here, instead of 56, if we have a null value, it will drop record 2. That is drop NA. But if we are specifying another access, and then if we have as in if we are specifying the columns, and if 56 is having null value, then it will drop age column. So that is drop NA. And then how to switch between access, that I'll tell you. Then the next thing is fill NA. So fill NA is nothing but if there are null values on any of the columns, then this will basically fill that particular column.
It'll fill it with NA. That's it.
Yes. If you want to fill it with some other value, any other string, you could do that as well. That's it. The drop NA, when I send you this notebook, I'll update it and send it to you. Yeah. So this collect is important, but collect also you should not be using, because that I'll tell you why. So let's say here what I'm doing is from this particular name, data frame name, I'm converting it to an array and getting the first element. Yeah. So this is the second element, and then this will be the third element. Okay. Right now there are just two. Okay. So that is happening here. So this is basically, so let's say you have done a ton of transformation and finally you want to show just the string value as output, then you should be using collect. So it will basically convert it to a two-dimensional array, and then it will give you the value. So these are rows and these are columns. We only have one column, so that is why it is giving you this, because I have selected name alone. So if there are multiple columns, you could access the required value here. Yeah. Then the next
Others,
thing is
we are above. Yeah, we are above our time contract. Others, it's past
yeah.
10:30.
So just, yes, I understand. Just give me just two more cells. Will be at done.
Okay, 2 more cells. Okay.
Yeah. So here, what happens is, okay. So here, how to change the date format. That's what you are seeing here. So let's say we have a particular date, and then if you want to convert it to year, it is very self-explanatory. Year, month, date. That's how we change it here. This also the same thing. So there are other functions. So here we use date underscore format, or we could use to underscore date. That's one other way. And this is date underscore sub is to subtract the date. Earlier we saw date underscore add to add more dates. And then date diff is to find the similar to SQL function to find the difference between dates. Yeah. So in this date sub date add, you could add more parameters and show if you want to add month, you could specify that and then add month. Yeah. So that is about it. We have completed both the modules. So let's see if I have missed any. Column class, working with column expression. We have seen in detail all of the expressions. Yeah.
Is there a proper like a cheat sheet of all the, like I can use your notebook, right? That itself will be the
Yes.
all the.
Yes. Yeah. Cheat sheet, I haven't found any till now. I'll check that if I have any as in if it's available in the internet. But yeah.
Yeah. Okay.
I had to search multiple sites and get all of this.
Okay, so that's how you have to do it. Yeah, that's a challenge, right? Like I think with PySpark also, like it's not like everything's not available. Like for SQL, right? If you open one thing, there's like a proper dictionary. You can find everything in one place. So when
Correct.
you're doing any coding, right, you can just directly start. You can look at that and you can use that guide and you can easily code. But with PySpark, it's a challenge, right? It's so many different ways of approaching a problem.
Correct. Yeah. Then we have to choose the most efficient one.
Yeah,
That's why.
and because
That
we'll
is
be
the
we'll be working with millions of rows, right? So
correct.
small changes will have significant impact.
Yeah. And one more point I have to tell you is why I told you we should not be using collect. I'll tell you why. So what collect does is it takes all of the data and then it brings it into driver node. You know the architecture, right? Driver node and worker node.
Yeah.
Worker node should be the one that should be processing, but it takes all of the data and puts it back to driver node. And then because of this, there will be memory issue and performance with degradation. So that's what happens when you use collect. The collect and the UDF we should use only as a last resort. delta lake and delta table, all of that. So I've divided it into two parts. So you're going to see the first part today. It's a bit complex. So let me move to not getting anything. Okay. So before that, yesterday you asked how to mount a data lake in Databricks, right? So this is the code that you use to mount data lake
Shouldn't we
in.
have a? I'm looking at the schedule. Other shouldn't we have the? Hold on. Where are we right now? Building and querying data lake before we go into the Delta Lake. Can we just take a look at the course contents first?
So this was your doubt, and this is how you mount a data lake storage. So mounting a data lake storage is nothing but we are making our ADLS directory available to Databricks. You should give your storage account name, container name, and then mount point. Mount point is the name that you're giving for that particular part. So it's up to you. You can give whatever mount point name you want, and you can use this in future. Then we have to create a service principal, and we have to give the details of the service principal here. Then what you have to do is you have to use dbutils.fs file system.mount, and then you have to give all the container name, storage account name, and mount point. Once you have mounted the data lake, required.
Question. Yeah. So you start with the storage account name that is the same as the Azure storage account name, right? Like that's
Azure storage account. Correct.
container name. So container name, what will you give there?
The name of the container.
The Azure
Inside.
container only.
Yes, you have
Okay. Oh, it's all Azure. Okay. Those are all Azure things. Okay. All right.
Azure things, yeah. Okay. Then
The
in
mount point, what?
future,
How do you know what is the like mount point? You're just declaring, is it? You're just declaring a variable.
Correct. It's up to you. So let's say you put here X, and then next time if you want to access some file from within, let's say we are reading a CSV file spark.read.csv, and then inside you give path as mnt slash x slash. So by X, what happens is we will reach till the container. Okay. Then after that, the path from container. That is the whole idea. That's about mounting. Yeah.
Okay, so you'll declare that mount point, and then after that you'll use the dbutils fs mount, and then you'll mount that
Right.
using this. Okay, and can you just go back over the configuration? I wanted to kind of just look at that 1 second. For configs, what did you declare here? All these things are. Oh, there's a principal client. Okay, and the secret client, the client secret, and all these things. Is it okay?
Yeah. So after our session is over, right? When we will still have some time. So then I'll cover the service principle and make it clear for you.
Okay, sure, sounds good. Okay.
And you were asking few doubts also, right? And all of that I'll clear once our syllabus is over. This is an overview of Azure Databricks and Data Lake. So Delta Lake is nothing but it's an open source data lake technology. It runs on top of. First, we will just go over what is Delta Lake, and then we will dive into the practical part.
Okay.
So it is nothing but it's an open source the data lake technology, and it runs on top of Apache Spark, and it provides advanced features like ACID transactions and data versioning. So ACID transaction you should already be knowing atomicity, consistency, isolation, and durability. And data versioning, by data versioning, what it means is say whatever you do on the table, a version of that table will be created, and you will be able to time travel to the previous version, and you will be able to restore it to the previous version. So that's about data versioning, and there is schema enforcement. Basically, Delta Lake is designed to improve data reliability, simplify data integration, and make it easier to build robust pipeline. And the important thing is it provides a unified analytic platform that integrates data processing, analytics, and visualization in a single environment. So if we are going with the traditional data warehouses and all of that, we need two separate systems. We'll have OLAP and we'll have OLTP. So here, everything would be in one place. That's why it says it provides a unified analytic platform. Yeah. Then we will see what are each of these what is asset transaction. So basically, this is I'm going to talk about the advantages of Delta Lake. First is asset transaction. So it means that the data remains consistent, even if there are even if concurrent users access the particular data, it remains consistent. And even if there is system failure, also the data will remain consistent.
Okay.
That's it. About then we have schema enforcement. So that's nothing but it ensures that data is always in a particular structure. So if we are inserting some data some other format, then it will tell that the schema is not matching and it will fail that insert. So as to it will ensure data reliability. Then data versioning we already saw. Then efficient file management. So as in Delta Lake, when we insert data into Delta Lake, the backend files will be created, and it will we can manage the files by partitioning, by clustering, all of that. Then improved query performance. It provides optimizations such as caching and table compaction. So if we have large volume of data, querying the data is very easy. Let's see. We're gonna create our first data table. So this is so what I'm gonna do is I have created two sample CSV files. Okay, it's nothing but there are 3 rows: ID, name, and age. Then I have created like what 6 or 4 or 5 records. That is the only thing that's here. And this is how you create a delta table. The multiple ways you'll see all of the ways. So here you should give format as delta and mode override. It could be mode override or it could be append. We already saw that in reading and writing files. And then finally save and give the path of the delta table. So in future, if you want to refer to the delta table, we need this path to refer. So the delta table will be known by the path that we are referring here.
That path is a standard path, or is it just any path it can be?
Any path, any path. I just gave path. It need not be. It depends on your, as in where you want your delta table to have its files. Yeah. So it's taking take some time to start the question. So that is the
So you
first
load it.
step.
So can I just restate this just to understand this? So you load it into a data frame, and then you'll write it into a delta table.
Right.
Okay.
Yeah. And here, the next step, what we're going to see is, so here, these are the list of files that will be created. So we have a delta log at this particular path. There will be 3 files created. First one is a delta log. Sorry, it's not a file. It's actually a folder. And this is our transaction log. So whatever we do to the table, that will be each so that will be one transaction, and that transaction will be logged inside delta log as JSON files. Okay. Then the Parquet file is we have actually converted our data frame to Parquet file and stored it in the backend. And inside delta log, you can see we have this CRC file and JSON file. So JSON file actually contains our transformations. It gives all the information inside the transaction log for one particular transaction.
Okay.
It did write, and then it wrote it into 2 files, and then these are the parameters that we use. So all of this will be present in here. So now we have seen what is inside this. Now this is another way to create a delta table using SQL code. So we create the table, specify the schema. So even if we don't specify the schema and we use location, and then we could do something like as, and then if we have another table, we could do select star from, and then give the new table name. That is also another way.
Sorry, that was
So
you. So you'll say create table name using delta as. So you'll not give a location. That's what you're saying.
no, we will give a location. After
Okay.
location, say if you have an existing table and you need to convert that table to a delta table. In that
Okay.
case,
Okay.
you give as select star from your table. That's just another way to create a delta table. So the basic thing to understand here is delta table will be known by the path. We will see how to query delta table at a later point. So here, this is how we query a delta table.
Before starting with the session, I just want to know that if anybody is having any hands-on experience with Azure regarding the trial setup or everything, because as much as I am informed that we are going with the Azure free trial, right? So anybody is having any experience on top of that? Have you guys already set up the environment? Have you guys already taken up the subscription or something? I will just go through the procedure once, like how you can go for the subscription. Okay, so I will just show you. So anybody who is willing to take up the subscription, so first we'll go with that. You go into the Google and write Azure free account. So here you will get the link, create your Azure free account today. Okay, so once you go inside this link, you can click on start free. Okay, so once you click on start free, it will take you up into this site. Here you can use a create an account. You can choose to create an account. Okay, or if you are having an existing account, suppose I am taking up this existing account. Okay, so once you pick up this account, then it will redirect you to this site where you will be asked, I think, some questions regarding the agreement and all. Since I've already signed up, so I am not given that. Else it will ask you for some verification pictures and all, and it will ask you to enter some of the basic details like name and all. And post that, you can come into this screen. So here you can see like create your free Azure account. So the free Azure account comes up with a 30 days policy where you are given a credit of 13,300 rupees. And on top of that, there are a few services which you can avail round the year for 12 months, which are not chargeable. And almost 55 plus of the services are free, which we'll take a look into what are those services as well. Okay. Meanwhile, I would also like to inform you people that once you verify using this card details, here you need to click on this card details. Okay, and it will charge you 2 rupees, which is reversible to into your account. It will get reversed back into your account once you are done with that. And also it has no automatic charges as well. It is written after your credit is over, we'll ask you if you continue with pay as you go. If you do, you will only pay if you use more than free amount of, but still I will ask you to avail one more benefit. Okay, on top of that, in case you are skeptical that okay, if anything is charged on top of my credit card, so once you log in here using the credit card and you sign up, so you will get a mail in your mail ID from whichever bank you do, whichever bank credit card you use, a e-mandate one. Okay. So you can, whichever bank you use, you can go to a portal, suppose HDFC e-mandate login or something. Okay. So you can, there in your mail ID, you will get a link. Okay. So that link you can go and you can register inside that link, and whatever the e-mandate you have registered over there, you can disconnect the cancel that e-mandate link. Okay, so like that wise it will actually remove your automatic charges. So that way you can get rid, like you will be free, that you won't be charged even if your 13,300 rupees credit is over. So any doubts anyone regarding this sign up process? You're having any doubts? Once you are inside this, once you sign up, okay, so you come inside a portal like this. The portal is portal.azure.com. Okay, so you can type here portal.azure.com and you will directly land up here. You will directly land up here in this website. Okay, so and it will ask you to take a free tour and all. Okay, so first of all, we would like to see, as I was saying, the free parts. Okay, what are the free services and all? Okay, so it is showing me like it has given me a credit of 15,800 rupees. Actually, it's in dollars. So depending on the dollar value, it's gets you. So you can see how much credit I just signed up yesterday using a free trial account. Okay, so that's how it shows you 15,800 credit remaining. Okay, so if you want, here it gives you the option upgrade as a pay you go subscription. If you avail this, then you will be charged, or else you will not be charged. Like I am dismissing this notification here. So coming to the free services part of it, you can see that these are the free services which it gives you, coming from the, which will be valid around the year for 12 months. Okay, starting from Blob storage to Key Vault to Azure file storage, Azure databases for MySQL databases, Cosmos DBs. All these will be in your account for around 12 months of time. Okay, after you have taken the subscription, and everyone is every even these are also having certain limits. Likewise, this bandwidth is having a limit of 100 GB. Azure Cosmos DB is having the max limit of 25 GB. Azure SQL database will be having a limit of 250 GB. So likewise, there will be some limitations on top of uh, these services, which you can avail till 1 year of time. And it has got many AI machine learning services to uh, virtual machines, service buses, load balancer, and everything. And there are a couple of services which are always free for you. Okay, which includes Azure Functions, Active Directories, Azure DevOps. This is one of the new thing, Fabric, which recently came in here. So it is also coming it as free since it's in the preview version. And apart from that, you can see notification. Data Factory is also what the thing which we will be doing, data analytics also. So these will be present throughout, but again there will be limitations. Okay, and those limitations you can already see it is mentioned over here for which of the services you are trying to use over here. Okay, so this with this we come to the free service part of it, like what are the free services you can get once you log in with Azure. Okay, now coming once we are done with this, then so next we need to understand, before we jump into our topic of Azure Synapse Analytics, we need to understand a few things. The first and the foremost thing which we need to understand is how to handle this platform. Okay, so that going forward, when you all will be dealing with the clients and they will be coming up and asking you like, what are the services we'll get, what will be the charges for the same, how to take up the subscriptions, whether you can provide them with some uh, billing policy. Suppose you have a client who is coming in and they have got a fixed budget. Okay, and for on a monthly basis they have got a fixed budget. So on that scenario, how you can set up alerts so that when you consume 50% or 80% of your allocated budget, then you get a direct notification in your email IDs saying that hey, you are about to reach your threshold. Okay, so those are the things we need to understand on a granular level, so that while we deal with this cloud platform, it is we are quite knowledgeable on those areas as well. So coming to the subscription part, so once you get into a free trial, so it shows you the subscription name as free trial and the status active, which is valid for 30 days, 1 month. Okay, so once you get into the subscription, okay, so here you can see that there on the left pane there are a couple of options which are available over here. So what are these options, and out of this, which are the options which is very important to deal with the clients, to do the cost analysis and the budget analysis while dealing with the Azure platform. So if I go into this cost analysis, okay, so I think I have set up this platform newly. So here you won't see much, okay, because this is absolutely fresh one, but I will show you something, okay, with which you can get an idea like how the cost analysis platform looks when you start implementing everything on a project level. Okay, so this is just for your understanding, I will show you. Okay, see, so when you come inside this cost analysis part, you can see this cost analysis part has been segregated in three types, in three domains. One is service name, one is location, and other is called the resource group. What is a resource group? We will come into that later. Okay. So by service name, you can already understand that it is trying to say like whatever the services we were availing. For example, Azure Synapse is one of the service which are available. So here you can see that which service says it is giving me a monthly report. This is for the month of May. It is giving me a monthly report of one of my clients, like how much it has consumed. Like it has consumed $5,035 uh, for 1 month, for this May month as of now. For this May month is getting completed today. So it has consumed this amount, this much amount of money for these of the services, Synapse Analytics. It has consumed these SQL database, logic apps, and which of the services here you will only be able to see the services which you have logged in into. Okay, which you have created once and you are maintaining those services. So those are the services you can only see over here. Okay, it also shows you location wise. So we all know that Microsoft is having its data centers spread all over the world. Okay, so it is basically be it where US, be US East or West Europe or US West. So it has couple of data centers all around the world. So here it also shows on the basis of data centers. Means whenever you create any service in Azure, suppose Azure Synapse service you are creating. So at that point of time, Azure asks you like, where do you want to exactly place your data? Okay, do you want to place it in the East zone? You want to place it in the US West zone? So where do you exactly want to place it? So whichever location you choose while you are creating those services, so those based on those location prices, based on those location, this has been grouped. Means whatever the services I have under my USEs, so those services price have been cumulated and it is coming in this price like $5,392 or 334 based on different locations on which I have my services. There is something called resource group name which will come in very soon. So resource group is basically a place wherein suppose you are working for multiple clients. Okay, suppose you have a Azure platform, you have 3 4 clients and you are using the same subscription for all of them. So suppose for ABCD client, you are using one resource group, and for XYZ client, you are using another resource group. So resource group is basically a place wherein you put all your services which you have created for that particular client. So then it will be easy that all your services for a particular client will be under that resource group, and you can easily go inside that resource group and work on those, on whatever services you have created and all. Okay. And also resource group is also created so that many a times what happens, I have taken a pay as you go subscription, wherein suppose with a single subscription I'm going to handle multiple clients. Okay. So all of the clients are having data privacies that another cannot see or something. Okay, so in that ways, that resource group permissions you can give to certain persons so that they only have access to those resource groups, and the other persons who are using the same subscription cannot go inside that resource group and see what you are doing. In that ways, their things are also protected, whereas you all can leverage that facility inside the same subscription. Okay, thereby maintaining the privacy. So those are the two primary reasons of using resource groups. And whenever you need to create any service in Azure, you always need to define that you under which resource group you need to place the service. So by default, you need to create at least one resource group to place all the services you create. Without resource group, you cannot even create a single service in Azure. Okay. So this is one of the usage of resource group. And with respect to different resource group for my different clients, you can see like what are the prices and things it has. Now coming to this graph, what does this graph is showing? Okay, so suppose my client has said that my monthly budget is $990. Okay, so you can see that on May 5th only, you can see that monthly budget is 990 and the accumulated cost has already come up to 980. Okay, and the rate sign which you are seeing, which is spread so much, that is the overhead cost, means how much overhead you are going out of the budget. So as I am climbing above the ladder, you can see that your monthly budget plus overage is equal to the accumulated cost here. Okay, so that's the formula. Your monthly budget plus overage is equal to the accumulated cost. So as of now for this month, this is my accumulated cost which has been charged. Okay, so and there is also a forecasting which is being done from the Azure side, like based on the regular on the daily. Azure runs some algorithms behind based on your regular usage. Maybe you have used for 15 days, and for the rest 15 days you can calculate, for a month you can calculate that what is going to be your approximate forecasted cost. Okay, so it is saying based on whatever the services I am having as of today, so by the month end of this month, my forecasted cost will be around 6126, that is which is around $400 more than my present cost. Okay, so these are the things over which you need to do as part of cost analysis, so that whichever clients you are going to handle, because every client you handle, the first and the foremost thing when you are going to prescribe them with certain services, they are going to come up with a budget. So here, that is how you can see the budget, and you can do an analysis on top of that. Okay, so after this cost analysis, let's go to the budgets. So what is, there is a option here also called budget. So what is a budget here? So basically, a budget is an option wherein you can basically avail some of the facilities of giving you alerts. Suppose I have created a free trial today, right? So suppose I am creating a budget. Okay, so I'm just naming it as Synapse training budget. Synapse training budget. Okay, so I am creating this budget. Okay, So billing month is the period. So creation date, I have created it yesterday only. I mean May 29, and the expiration, I have a 30 days trial. My expiration is on 1 month. Okay. So I am here saying what is my budget of total. My total is I have been given a credit of 15,500, right? So suppose I am saying that whenever it will cross 8,000 rupees, it will give me a mail. Okay. So I am saying the amount as specifying the amount as 8,000. I am going next. Okay. Now here it will ask you the alert condition. So as I have shown you in the and cost analysis, there are two types of budgets. One is actual, another is forecasted. Okay. So suppose whenever I will reach 50%, sorry, actually I think I have mentioned here 8,000. My budget is here as 15,000, sorry. And whenever I reach 50% of my budget, which is 7,500, I want an action to happen. What is the action which needs to be taken? Suppose I want a mail in my mail ID. Okay, suppose I'm entering a mail ID over here. So this is a valid mail ID. Okay, so once I reach 50% of my budget, I'm setting an alert that please send me an alert for the same, and I'm creating it. Okay, so that is how you create budgets. Okay, so you can set here, I have set here one reminder. Here you can go ahead and set multiple reminders. I have set here one reminders actual and 50% when it will be reached, but here you can set multiple reminders as well for 50%, for 70%, 80%. Likewise, you can set multiple reminders, and once those are reached, then you will get a mail in your registered mail ID. Here also you can specify multiple emails as well. Okay, and that you are, likewise it will be a allowed for you. Okay, likewise my client has set here a budget of 9,999 USD. So likewise I have set here a budget of 15,000 monthly, and out of which on 50% basis I need a reminder. So this is the use of budget. Okay. Okay, now coming to the another part, is there is another important part of the part is access control. Access control is something which is a very important thing, another level. So whenever you will create any service in Azure, okay, in every service you will see there is something called access control. Okay, so Azure here provides you the feature wherein with respect to each and every service, whereas with respect to the subscription as well, you can have different level of accesses. Okay, so suppose what happens is, suppose assume that all of you who are attending the meeting today. Okay, so suppose all of you are not having credit cards, or all of you are not comfortable subscribing to credit card. Then what you can do is like you can have one subscription. Okay, and you can share among yourself as well that subscription. Okay, so once you share among yourself the subscription, okay, then you both or all of you can use it together. Okay, likewise there could be one use wherein with a single subscription maybe two or three people can use this Azure services. Okay, so here in this role assignment, yeah, sure.
Trial doesn't allow multiple resources, right? To multiple people to handle. It only is for one sub.
Trial does allow, I believe. Okay, though I have never given anyone the, because I'm also using this trial account because I generally use enterprise accounts. Okay, but since exclusive for this training, I have come up with a trial account. But I believe with the trial account also, you both with the trial as well as the sponsorship account, you can use. Maybe I can give any one of you a select member, and maybe I can enter a name as well. Maybe any one of your email ID, suppose I can enter and give you the access. Okay, so trial also does. Okay, okay, okay. Please feel free to ask such questions. Okay, uh, if you have any doubts. Okay. Um, so here you can select those members, and you can press select, and that member will get added up here. Uh, and then you can review plus assign and create to give that person that access. Okay, and in the trial account there are three types, not only in the trial account, in all accounts there are multiple level of accesses which you can see from here. Okay, that there you can give a different type of accesses are provided here, but primarily there are three type of accesses. Okay, those are owner, contributor, and reader. Okay, so what is the difference between the three? Owner, by the name you can understand only, he can do anything. Owner, he is the owner of the subscription. So when you give owner access to someone, then he can create resources, he can delete resources, and at the same time he can also give permission to other members, means he can also add role assignment for another members also. So whenever you are making someone as an owner, then that person by default has that role based access control by which that person can give assign roles to other person as well. Okay, on top of creating and deleting and whatever working with other resources. Okay, but when you assign someone with a contributor role, then that person also can work, create resources, delete resources, but that person cannot give or cannot add role assignments for other persons. That person cannot give access to other person. That person can only use, that person can only primarily use these things, use the whatever the resources you have inside. Okay, and the final one is reader, who can neither delete nor nor create anything, but only can go through. Maybe in your team, maybe you have a fresher who have recently joined, and you don't want him to give the full control. If he or she messes up something, then that wise you can give a reader access to that person, wherein that person will be able to go through whatever components has been created and have a glimpse of that. Okay, so that's all about the subscription and the trial things, which was I felt which was very important. Okay, uh, to start with this Azure platform, to have a basic knowledge about cost analysis, budgets, and how, because uh, to have a fair idea about all these things before you start up with dealing with different services in the Azure, because Azure is a platform where you go with pay as you go service, and many a times it you don't know, but a lot of whenever you will deal with Azure, you will face a fact in many a cases that wherein sudden charges will get deducted and you will get confused, like where those charges got deducted, man. I couldn't understand. So that's the time when you need to come to this cost analysis, and you can see it, and you can drill down it on a granular level, maybe on a day level, to see like how much price a single service is costing you for everything, so that likewise you can have a fair idea. Okay, so with that, my elaboration on the subscription part ends. If you have any questions, please feel free to ask. After that, we'll move on to our prime topic of Synapse. But before that, if you have any questions on the subscription part, on the sign up part, on the cost analysis part, budget analysis part, alerts part, access part, you can please feel free to ask.
Yeah,
And
most
just
of
one
them,
yeah, please
most of
please
them
please please.
don't have Azure free trial account.
Okay, okay.
So, so what we need to do? So, you want us to do today or tomorrow?
You can do it today as well, right now as well. Also, you can do, if you all are having your credit cards handy with you, then maybe we can have 5 minutes of time to set up the system, uh, uh, and get ready with our things, because it don't take more than 5-10 minutes of time for all of us to do it. And I
That
think, yeah,
yeah,
so
actually, we need to talk with management before giving that credit card details. So,
okay,
yeah,
herein herein if this is going to be your personal account, okay, this has nothing to do with your company part. Means if you are going with your own credit card, then it is the personal account you will be having, and you will not be charged anything. It will be free completely for 30 days. And even you, as I have mentioned in the beginning of my session, like if you are skeptical about the part, like whether or not you will be charged or something, then there is something called e-mandate, which is present for every bank. That is a website which has been designed for every bank. So whenever you take some subscriptions like Azure subscription or Netflix subscription or Amazon Prime subscription, so what happens? Auto renewal gets activated. Okay, and those auto renewals from whichever credit card, bank's credit card you have done, so those things get listed in that e-mandate portal. So once you go inside that e-mandate portal for that respective band, you can see with respect to that credit card what are the what are the with what which operators you are registered. Like Amazon Prime is one operator, like Netflix, Microsoft is one operator, and you there are two but options over there: edit and cancel. Okay, so you can directly click on the cancel button, just and then that auto mandate with that e-mandate will get cancelled. So even if uh, you are over your limit, okay, and even if you by mistake click on the pay as you go model, then also Microsoft cannot charge anything from you, because you have already turned off your auto renewal. So that is one safer option I am saying. You can do that thing as well, so that there is no chance of mistake.
okay. Yeah, tomorrow definitely we will create account.
Sure. Okay. Any other doubts or any other questions from anyone? Okay, then I will take it as a no. Uh, so moving ahead to the next part, which is our prime part, which is Azure Synapse Analytics part. Okay. So we are done with the free trial. Okay. So coming to the Azure Synapse Analytics, for which you all have enrolled. Okay. So what is Azure Synapse Analytics? Okay. So Azure Synapse is basically an analytical service wherein you get to explore or get to have the flavor of both data warehousing as well as big data analytics. And Azure Synapse Analytics is having two types of query data platform. One is called serverless and the other one is called dedicated. So those are the two types of resources which is present inside those and inside the Azure Synapse. So as and along we go with the practical sessions, we'll see uh, what are the how these serverless and dedicated. Your Azure Synapse Analytics is a platform where we can achieve both the data warehousing and the as well as the big data processing together. Okay. So apart from this, Azure Synapse Analytics brings together couple of components. Okay. One is you can have the flavor of SQL technologies over there. You all are familiar with SQL. So you can have so for the Synapse, so in Synapse it is called as Synapse SQL. Okay. So we'll see like what is the difference between the normal SQL and the Synapse SQL going forward. Okay. So apart from the SQL part, you also get the flavor of Apache Spark. So for your understanding now, Apache Spark is basically consider itself as an engine. Okay, Apache Spark is basically one type of engine provided by Microsoft to perform big data analytics operations, wherein you do all the big data processing activities using the Spark technologies. Okay. And the third part, which is used to perform all the ETL and the ELT activities, is data integration activities, wherein you get to design the pipelines, wherein you create the pipelines to perform all the data integration activities to achieve all the ELTs and the ETL activities. Okay. And apart from that, along with these services, Azure Synapse also has some of the it has also integration with Power BI, Cosmos DB, and Azure ML. Now, integration with it means it has a direct connection, means you can directly connect Azure Synapse with Power BI, with Cosmos DB, as well as with Azure ML, and you can get the data directly from the Azure Synapse to your Power BI and show it in the dashboard. So it has got an incoming connector, okay, with these things. So with these services, so that you can easily avail the data of Azure Synapse into these services. Okay. So this is basically Azure Synapse Analytics. Now I want to explain you one more clear understanding, which many people does while dealing with many people are having confusion of Azure Data Factory and Azure Synapse, and where lies the difference, and how Azure Synapse is very different from Azure Data Factory, and why this thing is very important for your understanding. Because the I believe the purpose of your training is so that you can get back to your clients and propose them with different features of Azure. Therein the client may ask you, so let's go with Azure Data Factory. We are not fine with Azure Synapse. So at that point of time, when you want to pitch about Azure Synapse, how you can do it, and you need to have a very clear understanding what Azure Synapse. Basically, what happens is like, suppose in the earlier things, what used to happen is like, there were multiple incoming sources. Okay. So in the traditional part, what happens in ADF, like there are multiple incoming sources. Maybe this is SFTP, maybe this is on premise, maybe this is from take data, ingest data from all these sources, and then you used to take up this in ADF. Okay, you used to take up this in ADF to perform the ELT and ETL activities. Okay, and then what happens after you have ingested data ADF? Okay, post that you need to store this in Azure Data Lake storage. Means you have ingested data from all these sources in ADF. You are performing ELT and ETL operation. So you need to store this data somewhere, right? So at that point of time, you need to store the data in something called ADLS. Okay, which is Azure Data Lake storage. Okay. After storing it in ADLS, what you need to do is like, you then need to do big data processing on top of that. You need to do different type of transformations on top of that. So at that point of time, what you will need, if you want to do all the data processing, at that point of time you need to come up with something called Azure Databricks. Okay, so at that point of time you need to come up with something called Azure Databricks. Okay, so that you can perform all your activities together in the Azure Databricks. Okay, after you are done with the Azure Databricks, after you are done with Azure Databricks here, so after you are done with Azure Databricks here, then post that what you need to do is like, you need to store this data somewhere. Okay, so where will you store this data? You will store this data in somewhere. I don't know why it is having this issue. Where you will store your data, you will basically store your data in a place called SQL data warehouse, right? You will store the data in a SQL data warehouse, right? So after storing the data in a SQL data warehouse,
So you will store the data in a SQL data warehouse here, right? So, and then you will get it into a Power BI. Okay. So these are the many level or steps you need to take care of. Okay. So I have a very good diagram from the Microsoft as well. I will show you. Okay. That diagram as well. So these are the couple of steps wherein you are using how many services? You are using Azure Data Factory here. Then you are having storing it in Azure Data Lake storage. Second service. Then you are using big data process Azure Databricks for big data processing. Okay, that is the third service. Then you are getting it into a fourth service, which is SQL data warehouse. Okay, that is the fourth service, and or SQL DB. And then you are getting into the Power BI, which is the fifth service, right? So these many number of steps you need to take, and these many number of services you need to subscribe in Azure. Okay. But now what Microsoft did is Microsoft came up with a Synapse platform in which you don't need to subscribe for all these activities. Azure Synapse is already having all of these activities in this single platform. Means uh, it is having the option to do the ETL activities, ELT or ETL activities, wherein you can create pipeline in Synapse. So your ELT part is solved. Then then to store the data in Azure Data Lake storage. So whenever you create a Azure Synapse Analytics, so during the creation only, you need to bind Azure Synapse Analytics with a data lake storage. Means whenever you are creating only, they specify a storage. So it comes up with a storage as well, Azure Data Lake storage, where you can store all your structured and unstructured data. Okay. And after, on top of that, then you need to perform the big data processing, big data processing. So previously you need to perform that in Azure Databricks, but in Azure Synapse Analytics is having its own Spark engines, wherein you can directly create notebooks and write codes in 4 different languages, including .NET, Python, PySpark. Okay. So it gives you that facility as well. And on top of that, it has its own data warehouse, which you just saw in the definition, that it is having something called dedicated and secure serverless pool, where you can directly store the data. So all of this, everything you are getting in a single platform. Okay. And it is having a connector to Power BI as well. Okay. Where you can directly have your reporting part. So this is the fundamental advantage of using Azure Synapse over Azure Data Factory, where you don't have to manage all these services differently, as well as you don't have to bear the cost as well of all these services. You can have a single service. You can there it provides you multiple options of handling with prices and all. Okay. So you can leverage this service, and that is the primary advantage of using Azure Synapse over Azure Data Factory. So if you see this Synapse architecture, which I just draw to explain you, see you have on-premises data, cloud data, SaaS data, streaming data coming inside the Azure Synapse. Okay. And there are 4 activities we discussed right now we need to perform. So Azure Synapse Analytics firstly provide with you the Azure Studio, where you have everything, where that studio itself comprises of the data integration, wherein you can data integration means you will develop pipelines to do the data integration activities. In the management part, you can do all the big data processings and all in the management and everything using Spark engines. Okay. It has also got monitoring tools as well embedded with that, and on top of that, it has its own security system as well, which will provide you a secure uh, layer for your data. Okay. And to perform these two, as I mentioned, that it will come up with SQL and Apache Spark. And on top of that, to store your structured or unstructured data, you are also getting a data lake. Okay. So it's a package you are getting in the Azure Synapse Analytics, and it is also having the direct connections with this Azure Purview, Azure Machine Learning, Power BI. So Azure Purview is basically a data map. So that is a complete different service. It's a place where you can have a data map. Means you can have all the data of your organization, and you can have a close view of that data map in Azure Purview, and you can do Azure Machine Learning as well as reporting in Power BI. Okay, so this is primarily the Synapse architecture and the advantage of using Synapse over Azure Data Factory. Okay. So coming to the next part is we have to learn the basic concepts before going to the Azure part. We have to learn some basic concepts of Azure Synapse. Okay, like these whatever the 5 things mentioned over here are the prime concept of Azure Synapse. Okay, what is a workspace? What is a link service? What is Synapse SQL? What is Apache Spark for Synapse, and what are pipelines? Okay, so all these are means when you will deal with Synapse. So even for the slightest operation of maybe moving a small data from here to there, you need to use all of them. Okay, so these are going to be your very important concepts in the Azure Synapse. Okay, so coming to the Synapse workspace. So what is Synapse workspace? Okay, so as I have told, like Synapse workspace is basically a cloud-based platform in Azure. Okay, and that workspace will consist of the data lake storage, which we just talked about, Azure Data Lake Storage to store structured and unstructured data. Okay, it will also have a file system embedded within that. File systems are nothing but okay, so the containers are created inside data lake storages to store unstructured data into the files. You can store unstructured data into the file systems inside the containers. You can have all the Parquet files and everything. Okay, the Azure workspace which it comes up with, it allows you to perform all the SQL and the Apache Spark queries, and the resources which are available for SQL and Spark Analytics are being taken charge by SQL and Spark pools. Okay, so this is the primary fundamental part of Synapse workspace. Okay, so before moving ahead, okay, so since we have a discussion on Synapse workspace, and we also had a discussion about data lake storage, and we also have a discussion about resource group. Okay, so those are the 3 things we have already discussed, and I believe we are very clear on top of that. Okay, so since we have already discussed these 3 things, then let's do some practical things on top of these things. Okay. Okay, so let's create those things actually in Azure platform. Okay, so whenever you log in into the portal.azure.com, you get this website. Okay, so herein you can search the resources which you want to create if you are aware. Okay, or else whatever the resources you want to create, you can create on create a resource, and you can see with respect to different categories Azure have listed different services. Okay, so here you can see, and over here you can search, as well as you can go one by one and see in the analytics we are having Azure Synapse Analytics Data Factory. So you can see one by one over here everything. Okay, storage will get the Azure storage, Cosmos DB and everything. Containers will get containers, databases. Okay, so what we'll do is like we'll first create a resource group. Okay, so you can see here is an option for me given resource group. So I am creating I've already created a resource group. I'm again creating one. You have to give the name of you have to select the subscription first, then you have to give uh, the resource group name, and then you have to select a region for the same. Okay, which region you want to create this resource group to. So I am selecting East US region. Then directly you need to create on review plus create. Okay, so then you will come in this tab, and then you directly need to press create. So then it will start validating. Okay, and it will spontaneously create you a resource group. Okay, Synapse training. Okay, okay. So inside this resource group, you can create multiple services and everything, like whatever the services and all you want to create. Okay, So next what we want to create is like a data lake storage account, right? Because we want to store our structured, unstructured data inside the storage account, and we just came to know that the storage account can be used for multiple purposes. Okay, so let's create a storage account. Okay, so how to create a storage account? So you click on create. First you need to give the subscription, which is free trial. You need to select a resource group, so which I have already selected, which has just created Synapse MindMajix training. Okay, then you need to give a storage account name. Okay, so maybe I am giving Synapse storage ADLS Gen. Okay, so I'm giving the name as Synapse ADLS Gen 2. Post that you need to select the region. Okay, which region you need to create it. Okay, and then you have to select the standard or the premium. So it is always prescribed to go with the standard. If not, you are having dealing with very large volume of data, maybe in millions or millions or something, matlab, huge millions of data. So standard is pretty good to go with. Okay, so the next you need to select the redundant storages. Okay, so generally there are three, these are the redundant storages: LRS, GRS, and so a locally redundant storage is like what does LRS helps you with? LRS basically what does it makes a copy of your data. It makes 3 copies of your data. Local redundant storage, what does it do? It makes 3 copies of your data and it stores in the same region, in the same place. Okay, it doesn't stores it in multiple regions. Okay, whereas uh, in geo redundant storage, what is the facility you are getting? It keeps 6 copies of your data and it stores in multiple places. Okay, it creates 6 copies of data and it stores in multiple places. And there is something also called GA redundant zone. There is also one type of redundancy which creates 9 copies of your data and stores across different places. So these are the 3 types of redundancies which you have. Okay, so we are going with the geo redundant storage, which comes as the default one. Okay, so after that you need to go to advanced. Okay, so in order to create there are different types of storage account you can create. So if I would have directly created it without coming to advanced tab, then it would have created a storage account but not with a hierarchical namespace. Okay, means not with a hierarchical namespace. And whenever you want to work with Azure Synapse Analytics, you need to create a storage account with a hierarchical namespace, wherein including hierarchical namespace means it creates a data lake gen 2 storage account. So what is the benefit of data lake gen 2 storage account? Whenever you created a data lake gen 2 storage account, then the capability of handling data is very huge, and you can handle very high volume of data when you are having this data lake gen 2 data lake gen 2 service creating. So we have to enable this hierarchical namespace, because if we don't enable this, then we cannot feed this storage account into Azure Synapse Analytics. While we'll be creating the Azure Synapse Analytics service, then we can't feed this storage account over there. Okay, so we please tell me.
So, so you are exclusively selecting data lake, right?
Right, I'm exclusively selecting data lake. Okay, if I wouldn't have selected data lake, then it would have created a blob account. Okay, blob
Yeah. So
service
what
account.
is the fundamental difference between blob,
Okay,
like both are unstructured?
so So what is the fundamental difference between, actually there are three types of things. So in whenever you go with a blob, okay, the for Gen 1 blob part, here if we create a Azure Data Lake storage, okay, then what happens, it will come up with four options, okay. So one, it will come up with containers, it will come up with queues, it will come up with table storage, it will come up with file storage. There are four options which it will come up with, okay. And what happens in blob, blob can also store unstructured data, but it has couple of limitations on the sizes. Means whenever you create a container inside a blob, then what happens is you are right, you can store unstructured data, but it has got a limitation on the size of the container as well as the file size you are uploading inside the container, okay. So to overcome that scenario, at later point of time, this Gen 2 came, wherein you can have high volume of data, or you can store large 500 MB, 1 TB of files directly inside a container, and you don't have to worry about any sizing part. So that was the fundamental difference between Gen 1 and Gen 2, which it came up with initially. That is. So is it clear? Okay, let's move forward then. So we are done with the enable hierarchical namespace. We have to exclusively check it to create a data lake Gen 2 account. Okay, and then we can directly click on review. You can go through this, traverse through these tabs of network, where you can have a public network, public access. So all it is prescribed to go with as it is things as it is. Okay, and there is something called enable soft delete. Okay, so what is this is something which you need to understand. What is soft delete? So soft delete is a feature wherein after you delete the files from your blobs, generally it gets deleted, right? But when you have soft delete feature turned on, so after you delete it, then also after till an amount of time, you can get back that file. Okay, so you can get, and you have with this Gen 2 account, you have that retention feature of 7 days. But whereas with the normal, means if you don't turn the enable hierarchical space on, then you have, I guess, that option of multiple days. Means it goes up to 10, 15, 30, 40, 50. Means you can, there is a slider which you can slide and select for whatever days you want to retain your data after you delete it. So that is called soft delete. Okay, so I will directly. Uh,
So data lake storage is nothing but normal storage.
Data lake storage is nothing but normal storage, but data lake storage is nothing but normal storage, but it has got the options of two types of storage. One is it can handle both structured as well as unstructured data. Maybe in the table data storage, which I will just show you once it gets created. In the table storage, you will you can store the structured data, whereas in the container you can store the unstructured data. Okay, so it is also a type of storage only. Okay, so the deployment is in progress, so it will take, I guess, 30-40 seconds, 1 minute of time to get it deployed. So we'll wait for that time. So so coming to the next part of it is like, as I mentioned, like once it gets deployed, so yeah, it has done. Let's go to resource, and you see there are four four type of data storages. You see, containers, file shares, queues, and tables. Okay, so containers and file shares are mostly data, and queues and tables are mostly used for structured data. Okay, so that is the fundamental idea about creating about the data storage. Okay, now coming to inside the containers, if I go inside the containers, okay, so there you can create containers. Okay, so maybe I can maybe I'm creating a container named Synapse demo. Okay, So here you can set the access levels also for the containers. Okay. So you can set no anonymous access or anonymous access. You can set like suppose this in these here here in these blobs also you can use it like like a Google Drive also. Like you can post pictures over here. Okay, and also you can have once you upload a picture over here, you can get the URL of that picture and you can post it to some of your friend or that link, and he can directly come up and access your picture. Okay, so this is the idea between the public and private access levels. Okay, okay, so anonymous read access I'm giving. Okay, suppose. Okay, or we can go with private also. Okay, so maybe Synapse demo, then I am creating it, this container I am creating it. Okay, so I have created so inside this container you can have all your files, whatever maybe. Huh. So inside these containers you can have your files. Okay, uh, so maybe I'm uploading a file. I'll just get the name. Okay, so if you have a same file with that same name, you can click on overwrite. Okay, but I will here click on upload. Okay, so we are uploading a in a Parquet file over here. Okay, so once you go here, go to properties. So you see you have a URL over here and you can use share the URL for the others to access and everything. Okay, so that is the idea behind creating a container and store the data. Okay, let's come to the next part. Okay, so we have created resource group, we have created storage account as well. Okay, the next thing we want to create is like we want to create a Azure Synapse Analytics account. Okay, so we will go here, search Synapse. Okay, so before going to that part, I forgot to say something. Uh, so as I mentioned at that point of time, there is something called access control, which is present in each and every service whichever you create. So here also you are having that access control part. The similar like the subscription one. Here also you can give accesses, or maybe you can regulate accesses to different people uh, based on your requirement or based on the project or the client requirement. Okay, so that thing you can also access over here. Okay, so and there is also something called Azure Storage Explorer. Okay, so Azure Storage Explorer is nothing but exe file of this storage account. Okay, so if you go to Google and download the Azure Storage Explorer, so inside the Azure Storage Explorer, if you open that, it's just like an exe file. It will if you double click and open it, you can see whatever the containers and all are situated over here. So that's like an exe which Microsoft has developed for the ease access of the user. But also you can access through portal as well. Okay. Okay. There is something one more thing I also want to tell you, that is access tier, which is there are two types of access tiers, which is called hot and cool. Okay. So what is this hot and cool thing? Okay. So what happens when you create a data lake? It is understand that in this data lake you can hot files are created whenever you want to retrieve those datas on a regular basis or on a very frequently basis. at that point of time you go with the hot part. Okay, and whenever you suppose want to create a blob account, suppose someone is asking me now, so why to go with a blob? So maybe you don't have the requirement of a data lake. Okay, maybe you just want to store your files or store your archived files in data lake storage. You can simply go ahead and create a blob account, uh, and then choose the access tab as school, because once you choose the access tab as school, then it means you are going to access those data very infrequently, not very frequently. And when you choose the access tab as hot, it means you are saying Azure that you are going to access this file very frequently. Okay, so those are the two primary difference between hot and cool. So that is one important point. Okay. Okay, so I think that's all on the storage account part. So here you will get a basic detail. Okay, what type of storage account create? I told you, na, it creates 9 copies. So that is called read access geo-redundant storage. So whenever you create a data lake storage, it creates 9 copies of those files and stores it in different locations. It uses that type of replication in this data lake storage part. Okay. Okay. So I guess that's all about the storage account. Anyone having any doubts in the storage account part or regarding the resource group part which we just created? Because now we'll be moving ahead to the next part, which is Azure Synapse. We'll go ahead and create that. But before going to that part, anyone having any doubts or anything? Okay, I will take that as a no and move forward. Okay. The next part which we want to deal with Azure Synapse Analytics, which we just read the definition above. Okay. So let's go inside. Let's go and create a Azure Synapse Analytics workspace. Okay. So you directly come here, click on Azure Synapse Analytics. It gives you create. Go ahead and click on create. Choose the subscription, choose the resource group. We have created this resource group. Okay. Then there is something called managed resource group. Okay. This is an interesting thing. What is a managed resource group? What happens is, like, whenever you by default on its own. Okay. So that's why it is asking that whether okay. So as I said, like, subscription and resource group you need to mention, and managed resource group is something which you don't mention the name, it will create on its own automatically. Okay. So now you need to give the workspace name. So I'm giving the name as Synapse Workspace. Okay. So I believe if workspace namespace, see, it says this name is not available. So so this availability of name also depends on the region you are selecting. Maybe in the East US this name is not available. So maybe I'm giving this name and maybe it is checking. It checks and sees that name is available. Okay. Now you need to give the account name. So we have created Synapse ADLS Gen 2 storage account. Okay. And also we have created this file system, right? Synapse demo. So we are taking this file. Okay. Or else what we can do is, like, you can also create a new one also. Okay. Synapse training. Okay. Synapse training we created. Okay. We are creating a new one with Synapse training. Okay, fine. Okay, then just nothing more. Review plus create. You just need to do nothing else, and then the big thing will come. That is the charge part. Okay. So you see there is something called serverless SQL. Okay. I told you, whenever you create a Synapse workspace, it comes with two things: serverless and dedicated. Create exclusively after the creation, but serverless is something which we'll get to know what is serverless but serverless is something which it comes by default once you create it. And here you can see the estimated cost per TB is like 392.67 rupees is the estimated cost of SQL per TB. Okay, so nothing to see much, and we'll directly press on.
Sorry, per TB and no time duration, like monthly.
No, what happens is like for serverless, what happens is like it's like pay as you go. Suppose you have executed a query, okay, so that query is taking 1 MB, okay, so you will be charged on 1 MB, okay, and maybe after 10 days you are executing another query, okay. So whatever the memory your query is taking, based on that memory this charge. So if your query is taking 1 TB of memory, okay, which is not possible at a glance also, but I'm just saying if something like that you have written, so then they need to, for that query it will take 392 rupees, but actually with 390 rupees you can have dozens and millions of I mean thousands of queries, okay. It means, so Synapse SQL is something which is serverless SQL is something which is very cheap, and dedicated SQL is something which is very costly. Because what is serverless SQL is something like you just think it of an engine which Microsoft is providing you, and the computive power has been provided from Microsoft side, and all the things have been provided from Microsoft side, and they are taking care of it. You don't have any headache of maintaining it, okay, or scaling it up. Maybe your whatever the query you have written, maybe that query is taking 1,000 data warehouse units to run, okay. So Microsoft will automatically assign 1,000 data warehouse units for that query, whereas your next query needs 100 data warehouse units to run. So Microsoft will automatically assign 100 data warehouse units, okay. So you don't have any headache on top of that, okay. But whereas when you go with a dedicated SQL pool, what happens is like you have lot of headache, like headache as in you have to maintain your environment, because that's an environment which you are creating on your own, and you are not letting Microsoft intervene in that, okay. So therein you are specifying your data warehousing units, you are specifying your networking protocol, security protocols, everything you can toggle, okay. So that's why it's more pricey, it's more costlier compared to the serverless. So serverless is for those who is working on a small scale project, and that project does not require a dedicated SQL pool, then they can go with serverless. And dedicated SQL pool, maybe you want to do the entire architecture on yourself, wherein you want to design everything, you want to have a poly-based design and everything. At that point of time, you can go with a dedicated SQL pool. So that is the primary difference between dedicated SQL pool and serverless SQL pool. Okay, I guess that answers your question, and we will learn more about them going forward. Okay, so I think for this the deployment is in progress. It will take some time for this to deploy, because this is it creates a very big workspace and all that. So it takes around 2-3 minutes or 4 minutes of time, I guess, to get deployed. Okay, so meanwhile, just some few tips and tricks. Like here you can see the whenever you create anything, this is the notification bar of Microsoft, where you can see uh, what is running, what is in progress, and whatever the things are successful. Okay, so I think it is getting it still now. Okay, and apart from that, this is a PowerShell Cloud Shell window which Azure provides. Here you can have you write your Bash or PowerShell commands directly. Okay, so instead of having PowerShell on your own, also write direct Cloud Shell commands in the Azure as well. I mean, suppose you are developing some DevOps thing. Maybe you want to schedule something. Okay, or maybe you want a storage account to be created, or a Cosmos to be deleted and recreated. Uh, every day, so that you don't have to pay charge for throughout the day. Okay, so in for that you need to create a Azure DevOps pipeline using PowerShell script, so you can leverage those using these PowerShell commands and all. Okay, so okay, so this deployment is complete. So let's go to the resource group. Okay, so you see inside this resource group, we have our storage account created. We have our Synapse account also created inside this. Okay, and also there is one more thing is like कौन सा था हमारा ये वाला. Okay, huh. So let's go inside the Synapse workspace then. Okay, so this is the Synapse workspace which is loading right now. Okay, so and there is some, and inside you see it comes with a built-in serverless SQL pool, but you cannot see any dedicated SQL pool or Apache Spark pool over here as of now, right? You can only see built-in serverless pool which is present. Okay, which comes, and here also you have the access control to give specific accesses like who can use and all. Okay, and for the new dedicated SQL pool, here you have an option like new Apache Spark pool, Apache Spark pool for Python coding or PySpark coding, and dedicated SQL pool for SQL warehouse. To create a warehouse, you can create exclusively using this. Okay, and apart from this, okay, apart from this, I guess nothing much. We can directly jump to open. So whenever you want to open the Synapse Studio, here you can see the open Synapse Studio. You have to click in here. So what is opening right now is the Azure Synapse Analytics. Okay. I believe you all have a hard drop at 10:15, right? That's what I haven't been informed, right? Or 10:15, 10:20. You all have a hard drop. Achha.
Yeah.
Okay, okay, okay. Okay, fine. Okay. So this is our Synapse environment, which we have been talking so much about. So there are a couple of options here. You can see home, data, develop, integrate, monitor, and manage. So these are the couple of options present, which we will talk about one by one as we go along with our presentation. Okay, let's jump to our presentation. So next important thing is like link service. Okay, so what is link service basically? So link service is basically like a connection. I think some last thing last day where you all were training that you guys have worked on SSIS. So link service is somewhat like the connection manager of SSIS. Okay, so it's like you just point to where exactly you want to connect. So maybe you want to connect your Azure Synapse with a Cosmos DB. So you need to create a link service for the same so that you can connect with Cosmos DB. Likewise, you can it has n number of connectors with which you can connect to different service like Cosmos DB, SQL data warehouse, normal Azure SQL, SQL databases, couple of Excels, CSVs. Each has got every sort of connector, so you can connect to different different services using this link service. So you have to create a link service for the same. Next thing is what is Synapse SQL. So Synapse SQL has the ability to like TSQL only, which we write in normal SQL server. On the basis of that, it can perform different Synapse SQL activities. But there is one added advantage in Synapse SQL, which we will learn going forward. That is in TSQL, in normal TSQL, we cannot query unstructured data. We can only query structured data. That is which is in tables format, right? The data which is in tables, that data only we can query. But in Synapse, we can query unstructured data also. Matlab I can query an Excel file as well. Suppose you have got an Excel file, I can directly query that Excel file from Synapse. And literally query means I can even do the group by and everything on that Excel. Okay, so that is the power of Synapse. Okay, and that level of fun you can have with Synapse. Okay, so it has two consumption models. Okay, so by consumption models, it is basically talking about its built-in features of serverless and dedicated. So it has got two consumption models, and it helps you in running the SQL scripts as well. Next come the Apache Spark. So the Apache Spark for Synapse has the capabilities of, actually the Apache Spark is an engine which is used to run your node, to run your Python codes, okay, or your PySpark codes, or rather I should say in a better way, to do the big data processing. Okay, so in ADF you need Azure Databricks to do the big data processing, but Azure Databricks, inside Azure Databricks, it is having Spark is clusters. Okay, so there you need to write the code. Okay, but here, as I told, Synapse is having everything within it. So here it is having Apache Spark inside it. So inside Apache Spark, you can directly code and all. Okay, means Apache Spark is the engine, you need to create it, and then you can directly write your Python codes or .NET code, PySpark codes, everything. Okay, so that's what is written over here. You can create Apache Spark pool in workspaces. When you start using the Spark pool, the workspace creates Spark session to handle the resources associated with that session. Means whenever you are having a window, like in SQL, whenever you open a new tab, upwards you have a section, right, where you can toggle between master database, or you can toggle between different other databases and all. You can directly select. So that's what, like, you can directly select all these, or if you have multiple dedicated SQL pool or Apache Spark sessions, multiple, so you can directly select from the top, like which Apache Spark session you want to execute that code from. Okay, and then the whichever Apache Spark session you select, the code will be executed based on that Apache Spark session. So now you can ask me, then why can we not execute all the codes in the same Apache Spark session? Because when we create Apache Spark session, there are some concepts of clusters and nodes which comes into picture. Okay, so those things are basically related in enhancing the query performance. The more the nodes, the more the cluster, the better the performance. So that's why maybe you have got a very big bunch of code, you want to execute it from a different Spark session or a different Spark Apache Spark cluster, or maybe you have a small piece of code which don't take so much of nodes and all, you can run it from a small Spark session. Okay, so that's the benefit of having multiple Spark sessions and all. Okay, so though there are two ways to use Spark in Synapse. One is Spark Notebooks and another is Spark Job Definitions. So Spark Notebooks, basically, as I have told, like in the Spark Notebooks, you can write in Scala, PySpark, CHAS, and Spark SQL. So these are the four languages you can write codes in Synapse. Okay, using these four languages. Okay, so these are available. Okay, and another feature of using Spark in Synapse is Spark job definitions, wherein for running batch Spark job using jar files, actually there is a place in Synapse where you can basically upload different jar files, and it will automatically run those jar files to fetch all the libraries and all inside, to all the libraries and all from that. Okay, so means I was once doing a POC on Cosmos DB, therein I require uh, one of the jar files to be imported into Apache Spark to get some of the libraries. Okay, so for those you can use those jar files here in the Spark job definitions. So that is one way of using Spark. Next, coming to another part is pipelines. So what are pipelines? Pipelines are basically uh, the ways how Azure Synapse provides data integration. So by data integration, what I mean, data integration means I can have certain set of activities. So we'll just see it by creating a small pipeline. So see, there is a tab called integrate. Here you can create a new pipeline. Okay, you can name the pipeline here, whatever name you want to give. Okay, and maybe you want to have a uh, copy data activity over here. I will tell you what is a copy data activity or how it is done in the progressive classes. But as of now, just to understand what is a pipeline, pipeline is nothing but a set of activities which it clusters together in a single batch. Okay, so suppose I want to have maybe have a copy data activity which helps in copying data from one place to another, maybe a lookup activity which I want to perform before copy data activity to maybe fetch what is the last recorded timestamp in the database so that I can fetch. And then on success, I can do something like this. I told you, right? If you are aware of SSIS, then it is very easy to learn these things because it is kind of same here also. So maybe post that I want to run a stored procedure or something like that, so I can connect it with a. We all have to configure this, but I am just trying to make you understand that what is the use of pipelines and what is pipeline. It's okay. And once they are done, you all need to publish those pipelines uh, before all you need to publish those pipelines to schedule and everything. Okay, so we will come to that part later. So basically, this is what a pipeline is. Okay,
So,
and that's how a pipeline is. Yeah,
pipelines
tell me.
in the Synapse which you are doing, are they
Hmm.
similar to the KDF pipeline?
Yeah, absolutely, absolutely. That's what I
So they
told.
can be
Key.
reused even there, entire pipeline can be reused
Yes, you can. Whenever you do it, this JSON code is generated. Okay, so you can copy this generation code and use over there.
and vice versa.
Yeah, vice versa also.
Okay.
But yeah, naming and all you need to take care of, and also the link service and all you need to, because this is just a drag and drop I have done, right? But going inside, you have to set up the connections and all, right? You have to configure the source and all, right? So whenever you will copy this JSON, if you don't have the same named link service over there, then obviously that will break. But
Right.
just to give you a fair idea, like you can do this, but yes, obviously you have to do some plus minus, so obviously you
Okay.
cannot just directly copy and paste. So in representation to that, whatever you do drag and drop, a JSON code is generated behind everything. Okay, so maybe for the lookup activity, this is the block of the code which is generated as of now. Okay, so this is the block of code for the lookup activity. Okay, and it will enhance when I will give configure it. This code will go big obviously, but as of now the default lookup code JSON looks like this. Okay, so uh, and also you can like create a pipeline, and maybe you want to copy this pipeline's data into this pipeline. Okay, so you can directly copy the JSON and go to this pipeline, go to the JSON. Maybe you can replace, just you need to change the name. Maybe you click on OK, and you see this pipeline is also, I haven't dragged and dropped anything in this pipeline. I have just copy pasted the code, and you see this pipeline is also uh, feed with those activities. Okay, these are pipelines basically. Okay, so pipelines are logical group of activities that perform a task together. Activities defines actions within a pipeline to perform on data such as copying data, notebook, SQL script. That's what I was doing right now, dragging and dropping copy data feature and all notebook. Notebook is also one of the activities to write Python codes and PySpark codes over here. There is something called data flows are a specific kind of activity that provide a no code experience for doing data transformation. There is something here called so in this data flow, if I drag and drop a data flow, okay, so what happens is like I suppose I don't want to code or I don't want to do anything, right? Means suppose you want to perform here any sort of processing, okay, So in that scenario, data processing, then in that scenario, you need to do some coding, right? Whether you do that coding in SQL or you do that coding in Python, but you need to do that code, right? But in this data flow, what will happen is like you can directly go inside this data flow and uh, without the no code low code feature directly, it has all the components inside it. Once you configure it, it has got all the components inside it, wherein you can basically um, uh, have without even coding, you can basically create a SCD type 2. Maybe you want to create a SCD type 2, right? So here, if you want to create a SCD type 2, you have to write codes, be it in Python or be it in SQL. But in this data flow, you don't have to code. It has got all these drag and drops and all. So you can use those drag and drops to have the fun. So this is also one feature provided by Microsoft Synapse. So the triggers. So triggers are same. You have also known those triggers in SQL as well. So here also we have triggers. Okay, we'll learn about those triggers and gradually and how to develop them in our classes. But yes, there is something called triggers as well here, where you can basically schedule your pipelines. Once you are done with the development, you will not run the pipelines on a daily basis from your side, right? You cannot wake up every day at 10 a.m. and run the pipeline, right? You need to have a automated system to run everything, right? So that's where comes up a trigger. So here you can have different types of trigger to do all those activities. Okay, so here in the portal I will show you. Here in the portal I will show you there is an option called triggers. Here you can go and create types of triggers. There are three types of triggers, four types of triggers, which we'll talk about in our upcoming classes. But as of now, you just this is basically used for scheduling purposes. Okay. uh, okay, so next is integration dataset. Name view of data that simply points or reference the data to be used in an activity as input or output. So what is integration dataset? So here what you need to do is like once you create that connection manager, which here is called as linked service, you need to point to the file, right? You point by developing a link service. You said, hey sir, go and connect with uh, Azure Data Lake Storage or Azure Cosmos DB. But you need to mention also, right, ki uh, inside Azure Data Lake Storage container, so there are n number of files. So which files you want to develop? Okay, so you need to say that, right? There comes the thing, you need to develop integration datasets to point to the files which you want to ingest ingest here. Okay, so that's where integration datasets comes to picture. So that going to this data tab, clicking on the plus button and clicking on integration dataset, you can create integration datasets. So you can say ki, I want to connect into the Azure Blob storage, and then inside the Blob storage I want to retrieve this file, I want to point to this file. So that's the purpose of integration dataset. So that's the primary difference between link service and integration dataset. Link service points to the source and integration database points to the files. Okay, so I guess these are the things which I have already elaborated you. Serverless SQL pool and dedicated SQL pool. What are they? Okay. So serverless, but there are three more things. Like I said, you in serverless SQL pool, what we can do is like we can here in Synapse where we can also query CSV files. Okay, right? Unstructured data we can query. So we can query that using open row set function, and also here we can see those results in a graph format. Okay, maybe in a pie chart format I want to see the result. Okay, I can see that. So these are the benefits. So we'll do those in practicals as well in our upcoming classes. And dedicated SQL pool, you know that it has dedicated and it's pricey, and there you get to do all the configuration. It is your personal SQL data warehouse. Okay, so let's jump into the portal.
So what I mentioned yesterday, that what is link service? Link service is more like connection manager in SSIS, where you point like where you want to connect to in with which service you want to connect to, or with from which service you want to fetch the data from. So how to create a link service now? Okay, so suppose assume we have a data lake storage, and we want to make a link service with the Azure Data Lake storage, because yesterday we have uploaded a few files in the Azure Data Lake storage. So herein we will see how to create a link service with the Azure Data Lake storage. So what you do is like you just create all this link service option in the manage tab. Okay, and then you click on new. Okay, and you type here data lake. It has got many components to link to. Okay, just I'm giving an overview, like Amazon RDS, Amazon S3 cognitive services, Azure database, MySQL database, data lake, and it has n number of file systems, FTPs, and this many systems. It has also got external. You can also connect to external services like SAPs, snowflakes, etc. So all these with all these services you can connect to. This much of services you can connect to. Okay, so also you can traverse by from the headers as well, which service you connect to. You want to connect with NoSQL. These are the NoSQL DBs present over here. So while you explore it, you can take a look in that. Meanwhile, we'll go with creating a connection for the Azure Data Lake Storage Gen 2. Okay, so post that, what we'll do is like we'll click on the continue part. So then we have to name it something. Okay, so we are naming as your data lake storage training. Suppose we are naming this as a training. Then you can put some description if you want to, and the integration runtime is always left as default for auto resolve. Integration runtime is the default engine of the Azure Synapse Analytics. Okay, now here you have the option of authentication type. So these are the 5 types of authentication by which you are authenticating. The most easiest way of authentication is using the account key, where you directly get to choose from 2 options. Ya to from Azure subscription directly, where it will give you the pop-ups. It will give you all the Azure subscriptions you have enlisted over here. For me, it's a free trial now. Okay, or else you can enter manually also the URL and the storage account keys. Okay, so Azure subscription, you get it from here, free trial. In case you want to enter the manually for all the details, then for all those manual details, you need to go to portal.azure.com, and then you need to go inside the storage account, which you have created. Suppose let's go inside this storage account. Okay, and then inside the storage account, if we go inside the storage account, here you will get all the uh, details about everything, about the keys and all, access keys and all. Here you get all the keys and URLs here. Here you can get all the keys. So these are the keys you need to give over there to get the access to. Okay, or else the easiest way to do is using the Azure subscription. You get to choose it from the Azure subscription from here. Then you need to choose the storage account name, to which storage account you want to connect to. Okay, and then you need to test the connection. You click on test connection to test whether the connection is fine or not, and then you click on create. Okay, so as soon as you click on create, Azure will start creating the link service. Okay, which you have created. So you see successfully created the link service Azure Data Lake Storage. So where can you see it? Which link service you have created? Here only you can see that you have created a link service named Azure Data Lake Storage. Okay, but what is this related to? Means it is not related to any of the pipelines. Means we have not created any pipelines, or we have not done input of any activities inside the pipeline. So as of now, we have not utilized this link service in any of the pipeline. That is, it is why it is showing as 0. Okay. Also, you can see it here as well in the Azure Data Lake Storage Gen 2.
you get all the services. Okay. Now, after the link service, what we discussed is something called as integrated data sets, right? So integrated data sets, what we said that integrated data sets is nothing but a pointer to the which data you want to, which data file you want to point to. So that is the pointer to the data file basically. Okay. So how to create an integration data set when you want to create an integrated data set? Okay. For the integrated data set, if you want to create, then you need to come to the data tab. This is the data tab. You click on the plus icon and there is an option of creating the integration data set. Okay. So you click on the integration data set and then you need to mention that where is your integration data set, where is your data set located, in which service is your data set located. In our case, it is located in the Azure Data Lake Storage Gen 2 only. So you click and continue. Okay. And then you need to specify that what is your type of file format. So these for the Azure Data Lake Storage Gen 2, these are the type of formats which are available: Avro, binary, Excel, JSON, Parquet, and XML. Okay. So yesterday we have NYC taxi Parquet file, right? So we will want to point to that data set. Okay. So let's click on the Parquet file and then click on continue. Okay. Then you can name your integration dataset what you want to. So let's name it as NYC trip taxi. Okay. And then you need to give the link service. So you just created a link service, right? So you also need to point to the link service, that what is that link service. So we just recently created this Azure Data Lake Storage Training link service, right? So we'll choose this link service and then here we have to browse and give the exact data set. Okay. So inside Synapse demo, our dataset is present. So we'll choose this Parquet file and we'll click on the OK. Okay. And from there, you can directly click OK. So once you click on the OK, it will start creating the integration dataset for you. And you see here your integration dataset has been created. Okay. And after this integration dataset has been created, you need to publish it. Okay. So that you can use it going forward. Okay. So if you don't publish it, what will happen? Like your whatever you have created, if you just close it, then it will discard itself. Okay. So whenever you create anything, you need to publish it whenever it asks you the option to publish. Okay, so here you can see it is showing that there is one event which needs to be published. Okay, so I am publishing this. So you see we have created an integration datasets also for our NYC trip taxi. So here you see we have a integrated dataset also which is listed as NYC trip taxi. Here you can see that. Okay. So this is how your integration datasets are being created. Okay. And as well as your link service are being created. This integration dataset and link services are a very primary things which you need to be aware of while dealing with Azure Synapse Analytics, because whenever you are doing any copy operations while copying data from source to destination, you always need to create this link services and the integration data sets. That is, while you want to copy a data from source to destination, you need to provide the input to the Azure Synapse Analytics, that from where you are picking up the data and which data set you are picking. So you need to create a source link service as well as a source integration data set, and you also need to create a destination link service and a destination integration data set. That is where you want to dump that data and uh, in which location you want to dump that data. Okay, so you need to create both the things. So in which table you need to dump the data. Maybe you want to dump the data in Azure SQL data warehouse and in this table, so that table becomes your destination integration data set. Okay, so that is how you create link services as well as integration datasets in Azure. Okay. So okay, now let's.
When we create link service, that itself we are pointing to the data lakes storage, right? Why again data set?
Okay, you are pointing to the data lake storage, right, while creating a link service. But your data lake storage inside a container, you can have multiple files, right? So how will Azure Synapse Analytics know that which is that file you want to pick up? How will that know? So for that reason, you need to point to the data set as well. Okay, because if you don't point into the data set, inside a container you can place hundreds of files, right? And while doing a source to destination operation, you might want to do for some specific files, right? So in that case, you need to create a integrated data sets for the same, right? Because if you don't create, then it won't it will not be able to identify, right? So that is the reason you need to create an integrated data set. Okay. Any other questions?
Will it handle multiple files at the time?
Absolutely, you can do use a for each loop. Okay, so you can you can put a for each loop, and inside that you can give a copy data activity. So what a for each loop does is, like, if you give a reference to a container, then and you want key, suppose inside this container there are 10 files, and you want to traverse through all of those 10 files, okay, at the same time, means one by one all of those 10 files you want to take in the same processing or in the same run, then you use a for each loop, and inside that you do a copy data activity. So likewise, that for each loop will enter inside the container, and it will take one by one, and it will copy the data from the source to the destination. Now you, at that point of time, what you need to do is you need to create a dynamic integration data set. Okay, dynamic integration data set means at that point of time you need to write some little bit of code in your activities, wherein you will feed, right? For the for each loop will traverse one by one inside the container, right? So whenever the for each loop will enter the container, it will take the first file, right? So and you are giving a for each loop, you are giving a copy data activity inside a for each loop. So you have to give the reference of the for each loop to the copy data activity, that whichever file that for each loop is taking up, feed that file into the copy data activity. Okay, so we are going to traverse through those use cases in our upcoming classes, wherein I will develop those pipelines to show you how you can achieve such operations. But the answer to your question is yes, it can handle multiple files as well using a for each thing. Okay, any other doubts? Okay, I will take it as a no, and we'll move forward. Okay. So in our yesterday's class, we also studied about serverless SQL pool, wherein we just for your recap, that Azure Synapse is having two types of pool: serverless SQL pool and dedicated SQL pool. And serverless SQL pool where the cost is very low, dedicated SQL pool where the cost is very high, because you can do all the configuration, maintenance from your side. So I said yesterday during our class that in the serverless SQL pool, the idea of creating the serverless SQL pool is like, in our in a normal SQL, you only can query structured data. Okay, but here in Azure Synapse, it provides or leverages you the option wherein you can also query unstructured data. Okay, by unstructured data, I mean like datas in files, or datas in normal CSVs and all. Those also files you can also query them on datas in Parquet formats, Avro format, CSV formats. You can do all those things. Okay, so now we will see that how we can query an Excel file. Okay, and we'll see how to query an Excel file, and also we'll see, I have also told you that you can see the results in different chart formats also yesterday, right? I told you, like, we can see bar chart, pie chart, and everything. So I will show you how to do that. For that reason, what we'll do is, like, we'll create an Excel, and we'll have 4 columns, suppose ID, name, salary, and department. Okay, so we'll just input some values here.
So we'll just say 10 records will take. Okay. Then we'll just give some random salaries for them. So, and we'll assign some department to them as well. Save this file. Maybe in our documents as details. And we'll choose save in type as CS. Okay. So now what we'll do, we'll go to our Synapse and what we'll do is like we will go to our data lake. Okay, so this is our data lake. Okay, so Azure Data Lake Storage Gen 2. This is our Azure Data Lake Storage Gen 2, which we created yesterday. And this is our primary container inside this. Okay, or maybe our secondary container also we can take. Okay, so maybe we want to upload of this file which we developed, which we created. I have one file handy here, so I will take this. Okay. This file is also, I believe it is also having same kind of data. Yeah, okay, I will take it. Okay, so I will take this file and I will upload it here. Okay, fine. So let's go to desktop. I will upload this file, employee details here. Okay, so this file has got uploaded. Okay, so now employee details.csv. Now I want to create an SQL script by which I can use this file, right? So what you can do here is directly new SQL script, select top 100 rows. It leverages you the feature to do this. Okay, whenever you create on this, okay, and you can name your SQL script here. Okay, and then suppose let it be SQL script 1. So suppose I'm removing, it's an auto generated code, I'm removing this, and maybe I'm running this directly. Okay, and let's see what result it gives. Okay, and while it is running, I will explain you everything. Okay, um, this open row set function, okay, this is what I was writing. This open row set function allows you to access files in Azure storage and returns the content as a set of rows. Okay, so select start from open row set, and in bulk, what is this bulk? In the bulk, you need to give the URL of the employee details CSV. Okay, how you get this URL? So you have uploaded this employee details file here, right? So you right click here, you go to properties, and you click this URL. So this URL is the same. You can directly copy it from here, copy to clipboard, and this URL is the same URL which you need to give here. Okay, and then you need to give the format. Then there is something called parser version, which is 2.0 for everything. Then you are publishing it as result. So if we see the result, we can see that our column ID, name, salary, department which we have given is not the is has came in the row part. Okay,
it has not arrived, it should arrive as a header, right? So it has arrived in the column part. Okay, so to in order to give that, in order to take it from row to header, what we need to do is, like, there is something called header row. We need to mark it as true. Okay, so if we mark it as true and then run our query, so we'll see that our our header have gone to the header part. Okay, and this is our data. I will just scroll it up. So this is how we can query it. Okay, so after this, maybe we want to see, like, you can also apply group by functions over here as well, right? The things we do in SQL. Okay, so maybe you want to see that department wise what is the total salary. Suppose you want to see that we have 4 departments over here, right? So maybe you want to see that department wise what is the total salary which people are drawing, right? So in that case, you can do directly group by department, and instead of star you write department comma sum. You can also use aggregate functions as well. Sum of salary as total salary. Okay, so if you do this, you will see. Okay, okay, potential conversion error while reading varchar column name from UTF encoded text. Okay, so this is the error you are getting. Change database collation to a UTF-8 collation or specify explicit column schema and assign in UTF-8 to varchar columns. Okay, I think second should not give me this columns. Okay, okay, so here what is the problem? It is like I have misplaced this department name. Okay, so if I run it, so you see that department and wise you are getting the total salaries which is mentioned over here. Now suppose you want to see this salary in a chart wise, right? We also discussed, right, see it in a chart wise, right? So you want to see it in a chart wise, then we'll go to the chart. Okay, so you see it is giving me a line chart. Okay, so suppose instead of this line chart we want to see a pie chart wherein we want to see that department wise what is the total salary. So we see the department in the category column. Okay, and this total salary as the legend. So this is somewhat similar to Power BI stuff also. So you do these things in Power BI as well, right? You select different legends and all. So once I do that, you can see that department wise, what is the total salary? The finance department is drawing this much of salary, IT is drawing this much, logistic drawing this much, and HR is drawing this much. So this is the beauty of Azure Synapse, that you can even query the files, you can do groupings on them, you can do aggregates on them, and not only that, you can also export the results in graphs format to show it to your clients, maybe some insights of the data also. So this is the all, and also you can save it as an image as well. Okay, so this is till this extent you can work with files. Okay, and we have done this using the uh, Synapse serverless pool, right? We can see that you have connected to built-in pool. So built-in pool is the serverless pool. Okay, so that is how you query the data from the files. Okay, next going to the next part of it, like we'll see some things about serverless SQL pool as well. Every Azure Synapse Analytics workspace comes with server SQL pool endpoints. Then you can use to query data in the data lake, Cosmos DB or Dataverse. Okay. So, and in the Azure Data Lake, you have different formats. You can query Parquet, Delta Lake, delimited text formats. You can query multiple things. Okay. It allows you to query the data in the T-SQL syntax directly. You saw that the syntax was my T-SQL syntax without the need to copy or load data into a store. And it's like pay as you go service. I am only charged for only the query I have executed, not like it. I am not doing anything now, so it is not charging me anything. Okay, it's only when I am executing the query. Okay, now let's come and understand some of the advantages and disadvantages of the SQL pool, which is again very important. Serverless SQL pool offers T-SQL querying surface, something called LDW. Now, what is LDW? Okay, so there is something in serverless SQL pool which is called logical data warehouse. Okay, now what is this logical data warehouse? Because you told me that uh, in case of serverless SQL pool, what it does is like we store the data in a data lake storage, and then you come to the Azure Synapse and you directly query what is stored in the data lake storage. Any files you directly query it from the Azure Synapse. Now, what is then logical data warehouse, and why even we need a logical data warehouse here? Okay, so what happens is like you can even create databases in for a serverless pool, right? Generally, we know, right? We can create databases for in the Azure SQL DB or for a dedicated SQL pool. You have everything like which you can open in SQL Server Management Studio. You can have a database and all over there. But here also you can create databases. Okay, so we'll see how to create database in the serverless SQL pool. Okay, we will open an SQL script, okay, and we will write create database training DB. Okay, maybe we want to create this database, and where we what is we are using? We are using serverless SQL pool, that is built-in pool. Okay, and let's execute this, and you see that my query got executed. Now let's go and see, just a second. Okay, next one, I think I need to publish it. It got published, right? No, no, why it's not coming here? Should. Okay, we'll see it. Okay, so in short, you have created a database called Training DB in your serverless SQL pool, wherein you can store you can store all your external tables as well as your external schemas as well as your external views in this training database which we have created in the serverless SQL pool. Okay, so okay, so in serverless SQL pool, you can create these things: database schemas, views, stored procedure, and external resources. Okay, I will just see to it where I can show you the training DB. Okay, but before that, let me continue with this thing. Okay, serverless SQL pool, what we can create. So for the serverless SQL pool, we can create databases, schemas, views, stored procedure, and external resources. Okay, so for the databases, as I showed you, this is how you can create a database in serverless SQL pool. Okay, you can create schemas. Okay, schemas is like a normal database schema. Okay, you can create views, stored procedure, and external resources like data sources, file formats, and tables. Now, what is this external resources like data sources, file formats, and tables? Okay, so because all these things were what are all these things? Okay, so here tables are not the tables which is exactly you see in a dedicated SQL pool or in normal SQL. Here we create external tables. Okay, so what is the funda of external tables? Okay, so if I show you, if I am having handy external things, what is external tables? So basically external tables are not physical tables. External tables are basically uh, logical views of the tables wherein you don't actually store the direct data inside the tables, but it acts like a pointer wherein it directly fetches the data from the Azure Data Lake storage to you and displays it to you. Okay, so external tables, which we'll discuss in our future classes, will create external tables and all, but as of now, for your information, external tables are basically logical views which we create here. Okay, I will show you if I'm having some external tables here. Okay, so let me check if I'm having. Okay, I'm having few external tables over here. Okay, so let the open. I will show it to you. What are how these external tables are. This workspace is the place where you will see all your databases and all your. So that's what I was expecting, that it should show the databases here. Likewise, it is showing here like what are the databases you have created. Okay, so I will just check for that. So it should also show the external database we create for the logical data warehouse, right? For the serverless SQL pool, it should show it over there. Okay, so we'll see that. Meanwhile, it is opening. So what I was telling you is like data external tables are basically the logical views. And what are the disadvantages of serverless SQL pool? The disadvantages of serverless SQL pool are like you cannot create normal tables. Okay, you only have to create external tables, means it does not hold a physical table what you do in a normal regular database, or a normal SQL database. Okay, it you cannot create triggers in the serverless SQL pool. Triggers only you can create in a dedicated SQL pool. You cannot create materialized views. So normal views you can create over here, but materialized views you cannot create. So materialized views are basically one type of views wherein they are having their own memory allocation. Okay, so normally what views is, views are logical objects, right? They don't have their own memory allocation, right? They are directly pointed to the query which fetches you the data, right? So that's what you can create in TSQL, but that's what you can create in serverless. But you create materialized views which is having its own memory allocation. You cannot create that. No DDL and DML operations are supported in the serverless SQL pool. So these are the basically the disadvantages, and the advantages are you can create normal external tables which will act as a pointer to your Azure storage, and you can create view stored procedures, schemas, everything. Okay, so once you create a external table, it's you can, it somewhat looks like this. So if you go inside these tables, there is something called external tables. So you can see these external tables look like this. Okay, so maybe if I could show you one. So you, these external tables are having all the rows like the normal ones, and if I show you the normal create code of this external table also, so it somehow looks like this. Okay, it will take I think some seconds of time to fetch the script for the same, but it is also the if you see, these external tables are also holding all those columns which you have created for normal tables. So these are like normal tables, but they don't have any physical copy of it. They are all storing the logical copy of it. Okay, so they basically hold the query and the pointer to the data lake where you are storing the data, and directly fire the query and fetches the data for you. Okay, so this is the somewhat the syntax of an external table, and there are multiple concepts like data source, location, file format, reject type, and all, which we will be discussing in our upcoming classes, like what is a data source, how to create a data source, why is it needed, what are the types of file formats we can use over here, and everything. Okay, but as of now, this is for your information. Okay, let's go forward.
Arnab, is this server serverless SQL part of the data lake storage?
This is a part of the data. No. Serverless SQL pool is not part of data lake storage. Data lake storage is a place where you store the data. Okay, this is part of Azure Synapse Analytics. Okay, data lake storage is a different service. Synapse Analytics is a different service. Inside Synapse Analytics, there are two types of databases. One is serverless SQL DB and one is dedicated SQL DB. So it comes under Azure Synapse Analytics, not Azure Data Lake Storage. Okay.
So why didn't we create a link service for this?
Link service for what?
For this SQL pool.
No, you don't need to create. The link services are required to be when you are using pipelines. Okay, you don't need link services for SQL queries. Okay, you need link services for pipelines. Means whenever you create a pipeline, okay, whenever you create a pipeline, like whenever you do a develop a DTSX file in SSIS, right? And you do maybe you want to copy a data. Okay, so when you drag and drop this copy data activity, then it asks you the source data set, right? So in the source data set, you need to feed the data set, right? Like which data set you need to. But here you are directly in the SQL code, you are directly giving the path, right? In SQL code, you have the option to directly give the path, right? Here you see you are directly giving the path of the CSV here, but when you are developing it in a pipeline, you don't have any option to give path. You can only feed the data set. Okay, and in the JSON code, it will take the path, because behind Synapse pipelines, it generates JSON code, right? We talked about yesterday, right? There it will automatically take the path and everything, but you have to feed the links. You have to create link service and integration data set, and you have to feed the data set over here. Okay.
What is the use of SQL pool then? Like, why are we creating those?
The SQL pool, inside the SQL pool, you can directly query all these unstructured and structured files. Suppose you from your source systems, you maybe one of your source client is having some systems, and in batch, with the help of batch processing, they are posting all those files in your Azure Data Lake storage. Okay, that's how this data engineering solution works. Your client is having some files which they will push in terms of batch processing to your Azure Data Lake storage, or you will take that or you will connect with different sources of clients, and you will get the data into your Azure Data Lake storage. So that data in maybe in different format, not necessary, because Azure Data Lake storage can store data in both structured and unstructured data, right? So if your client is having unstructured data, then and the, right, the unstructured data can be in a very tedious format. It is not possible for you to open the file and understand. So how are you going to understand what is there in the unstructured data? How are you going to structure that unstructured data if you don't know what is inside it, right? So Azure Synapse provides you or leverages you the option where you can take a glimpse of the unstructured data. Okay, you can take a glimpse of the unstructured data and you can directly use it. Okay, not only this, you can create a SQL script here as well, and you can directly use that SQL script in the pipeline as well. Suppose you are using a SQL, developing a SQL script here, and you can use that script in the pipeline as well.
No,
Okay.
I'm talking about those serverless SQL pool. Go back to
Where?
database. You showed database.
Okay, yeah, Azure database.
No, there was another account you used.
Query you are saying?
No, not query. Go to that account, different account. Here.
This is a
This
dedicated SQL pool. This is not a serverless SQL pool. This is a dedicated SQL pool.
The second one. Second one is serverless.
Konsa? This one?
Yeah.
This one is a serverless SQL pool. So that's why.
What is the purpose of
this database, because this is what I was telling about logical data warehouse. I told you, right, there is something you can create, because you can see what are the external tables over here. Because if you create external tables, you also like if you have a dedicated SQL pool, you can go here and see, right, like what are the databases over here, you can expand and see, right? So suppose if you don't create a database over here, then how will you see that what are the external tables you are creating, what are the external resources? See, for a dedicated SQL pool, you have option of tables, external tables. You can see here, as well as you can go in the SSMS and see, right? But for this serverless SQL pool, you cannot go inside SSMS and see. You need to have a data warehouse like structure, right, where you can see. So that is why it is developed over here. So you can create a database like the code I executed. So it will come over here with the name, and inside this external table you can see whatever all external tables you have created.
So are you saying that will be our destination which we want to see?
Right, it will be your destination which you will want to see, right? A wholesome view of the destination which you will want to see. You are creating random SQL scripts to create external tables, but you need a wholesome view of your destination, right? That where will you create it? Okay, and what are the things present? What are the views present over you? So that you can directly have a glimpse of it in a data warehouse like structure over here. Because these things are very tricky things. I means you will not get so much of elaboration everything in the website or in the net. Okay, because these things because these are normal pipeline, how to develop normal use cases you will get everywhere. Okay, but these things you won't get everywhere, these details. Okay, because what is this dedicated SQL, what is this server SQL pool, and how you can create these SQL scripts like that, or the question you just now asked. Okay, so if you have any doubts like that, please feel free to ask. Okay, because these are very small things, but you need to have that understanding very much. Okay, for now I will take it as a no and I will move forward. Okay, so that's what. So that's what I was saying. Like, if you the way I created a database, right? So that way, under the workspace, you should see the database like this, and you will have your external tables, which I showed just now. You will have your external tables listed over here, which you will create in your serverless SQL pool. and you have external data resources. What is external resources? External data source or file formats are nothing but a part of external tables, wherein external data source will basically hold the data source, means that URL of your file where it is located, and the file format will hold the format of the file, that whether it is Parquet, Avro, CSV, delimited text, whatever. And these views will hold all the views. These schemas will hold all the schemas, which is in normal database, and the security is also like normal ones. Okay, so these are the options we build for a normal logical data warehouse which you develop in serverless SQL pool. Okay, so that's all. With that we end our entire story of serverless SQL pool. Next we'll move to the dedicated SQL pool. Okay, we discussed about dedicated SQL pool yesterday, but today we'll create it, we'll see it and everything. Okay, now dedicated SQL pool, as we discussed it, it's a billable resource. If you are not using also, then also it will charge. Okay, but yes, there is an option in dedicated SQL pool wherein you can pause the pool to reduce the cost, means you can stop the pool, but make sure once you stop that dedicated SQL pool, then what happens will, you cannot even fire a query, or if you have something scheduled over there, maybe you have a pipeline schedule which runs every day at 10 a.m. and you have paused your SQL pool, then that execution will get failed. Okay, so, and your dedicated SQL pool will be associated with dedicated SQL database, like the one I showed you just now, right? Your dedicated SQL pool will have their own dedicated SQL database. Okay, like this. So now let's go ahead in our login and create a dedicated SQL pool.
So one minute. So can I use in a pipeline data lake storage as source and serverless SQL pool as destination?
You want to use serverless SQL pool as source, means you
No,
want to
destination.
uh,
And
you want to
data lake
use
storage and CSV you have, right?
again
Destination
again
source, data lake, sorry, serverless
again
SQL pool as destination.
again I told you that in serverless SQL pool you cannot store something. It's a logical view, it's not a physical view, so you have to store it in Azure Data Lake storage. So you can, so what, so your question should be something like this: can I have my source as dedicated SQL pool and my destination as Azure Data Lake storage? Because serverless SQL pool after all points to Azure Data Lake storage, right? Because serverless SQL pool is not having any memory allocation. It is just holding a logical view of your data lake storage, right? Or so, or whichever connection you are giving it to. Logical view, logical log by
Storage.
right. For or data lake storage or whatever storage you are creating, wherever you are pointing it to. Right now we are pointing it to data lake storage, right? We are saving our file in the data lake storage, right? So it is having it is giving the pointer to the data lake storage. You see, I have executed this query in the serverless SQL pool. You see, I am not storing or doing the data anything here, right? What I am doing, I am given the reference to the data lake storage, right?
Okay. Okay.
Okay. So
Can
your
you
question
where is
should,
the script saved in the
sorry,
serverless?
sorry.
Where is the script saved? The SQL script one. Is it in the serverless pool? Yes, sir.
This SQL suite is for serverless SQL pool only, na?
Where is it saved? Can you show where is it saved?
Okay, this script you are asking.
Ah,
This script is saved here. Develops SQL script one. Here your scripts are saved. Okay.
this is nothing but our serverless pool, right?
And this is nothing but your scripts are saved inside the server. This is the SQL scripts you are saving. Okay.
Hmm.
And your serverless again you need to understand. Okay, I think you are confused between SQL pool and SQL database. Okay, you need to understand SQL pool is an engine, SQL pool is not a database. Okay.
Hmm.
Okay, so don't confuse between pool and database. Okay, pool is an engine. Pool is an engine which helps you to fire the queries and do all the analytical things. Okay, it doesn't save anything. Okay, so you save your data in some other storage options which you have, like Cosmos DB, Data Lake storage, etc., etc. Okay, So serverless SQL pool is just an engine which helps you fire the query. Okay, it doesn't help you store anything. Okay,
Okay.
okay, you got it right. Okay, so this is where you are having all your SQL scripts. Okay, and this is the and that's all. And in your workspaces you can see what are the databases you have in your. You can see serverless DBs as well, which I termed as a logical data warehouse. You can also see dedicated SQL pool, which are going to develop right now. So let's move to the dedicated SQL pool now. Okay, any other questions regarding serverless SQL pool? Any other questions regarding serverless SQL pool, or else I will take it as a no and I will move forward.
Yeah, where we can use external tables in real time.
In real time you can use external tables to create a polybase design of the database. Like suppose as I said, your client is having a source system where from in batch using batch processing he is posting your data into the Azure Data Lake storage, right? So you have all your Parquet files in the Azure Data Lake storage right now. Now you want to perform some operation so that you can take all the data from the Azure Data Lake storage and post it into your Azure SQL data warehouse, right? So what you can do is like, and you want to design it in such a way so that you do all these transactions very fast in a very fast way. So there is something called polybase design, wherein what happens, you create these external tables which will act as a staging table. What happens, you create an external table. What this external table will do, external table will basically hold the reference to your Parquet file which is saved in the data lake storage, right? And after that what you do, you apply a copy data activity, in which what happens is like you copy the data from the external table and you post it in the Azure SQL data warehouse. Okay, so that is how you use the external tables. You use the external tables as a staging table so that you can do your data transfer very fast. So the primary use of external table is like a staging table. Does that answer your question? Okay, let's go now to create a yeah, SQL pool, dedicated SQL pool. Okay, so this part is also very important. Okay, how to create a dedicated SQL pool, and because primarily we use dedicated SQL pool because to store structured data. Okay, because structured data we cannot store in serverless SQL DB, right? We have to use dedicated SQL DB to store structured data, right? So let's create this pool. So once you come here, you directly come into this monitor tab, go to the SQL pool. Okay, you can see that I have only built right now. We have only built-in serverless SQL pool over here. Excellent. Okay, is it something that it doesn't? The options to create. See, just give me 1 second. No, sorry. You come to the manage and then you come to the SQL pools. Okay, and then you click on new. Okay, then you click on new. So this is your dedicated SQL pool. Now you need to give the name. Okay, what name you want to give, and this is the performance level. So performance level includes data warehouse units. Okay, so these data warehouse units directly is referenced with the performance and nothing else. Okay, the performance level selected is currently limited to this range. An error which is giving right to me.
for me, I will create a data warehouse of 100C. But yes, you can create data warehouse up to 30,000 C, which will give you 30,000 data warehouse units, which will be super duper fast um, if you have like huge data. Okay, and this is the cost per hour. Okay, for this 35,000. Okay, but for now we will create a normal estimated DW 100C, because this is for the training purpose. So maybe we can create with the name Synapse Training DB. Okay, so we are creating of 100C. Okay, just for your information, it all depends on the query. This utilization of data warehouse units depends on the query or you are using. Okay, right now, just to show you a glimpse of it before I proceed with the creation. Okay, to help you, make you understand. Okay, so because there are some scenarios which I can show you from here. See, I have some of my queries developed for my client, which consumes up to DW500C. Okay, so I am having this pool with DW500C units data warehouse, and you see I have some of my queries are taking DW500 up to 400 500C, and when it is taking 500C, you see on the right hand window active and queued queries, it is around executing around 26 queries together, and 26 concurrent executions happening, means maybe around 26 queries are getting fired at the same time based on whatever codes I have written. Okay, so based on that, it is having taking so much of DW. Okay, so it matters on what level of core, what level of joins you have done, what is the data you are having, how much records you are fetching, what type of distribution, we will talk about distribution next, what type of distribution you have applied on your tables. So it all depends on all those factors. Okay, so that's how it is very important. Okay, so let's create this DW100C. Just click on review plus create, nothing to see, and it is costing us 118.59 cost per hour. Okay, okay, then let's create it and then I will tell you. Okay, whenever you guys are creating it, okay, see, you all are having a limited credit, right? So my advice will be that when you are using this new dedicated SQL pool right now for your training, I am saying, when you are using it, you create it, it's very fine, okay, but when you are not using it, you pause it, because if you don't pause it, it will keep charging you 115 rupees per hour. So that wise it will cost you in 24 hours, it will cost you around 100 rupees into 24, 2400 plus 15 into 24, it will cost you around 2600 rupees per day. So that way your everything will get expired in a only 10 12 days only. You cannot even have the option to enjoy this service for 1 month. So please make sure to pause the pool. Okay, so once it is getting deployed, I will show you how to pause the pool. Meanwhile, I can show you. So once it gets created like this, it will create you a pool. Okay, dedicated SQL pool. Okay, you can also search it from here. So so you go inside this Cogent SQL dedicated. Okay, so inside this Cogent SQL dedicated, you see there is something called pause. So you can pause it using this, and it is advised for you to pause it once when you are not using it. Okay, and then there is something called scale. Scale is the unit. So scale is something like, suppose you have assigned 500 units today, but tomorrow you need to increase it because your data got increased. You need to enhance the performance and all. You can directly increase it by increasing this slider and click on save, and it will increase it. Okay, so those two are the primary things. Okay, access control, I have always told you that there is something called access control in every service, where you can give the accesses to your whoever person will be using and everything. Okay, so let's go back. see our Synapse training DB has been created. So you can also directly pause it from here as well. If you click on pause, it will get paused. Okay. You can also scale it from here. So it is successfully
One
deployed.
thing here,
Please ask. Tell me.
yeah, actually, individual account we can pass, but in real time, while working in client,
You
how
cannot
we
pause.
can handle.
Okay, there is a scenario you can handle it. So what you can do is like there is something if you want to save on the cost. Okay, so in real time scenario, how you can handle it is something like though in most of the case and most of the clients I work with, they don't stop it. Okay, as you see, I'm working, but yes, because if your data is getting maybe your data is getting yes, you have scheduled something every to run every hour. Okay, so you cannot pause because what I'm doing for my client is I'm running every hour, so I cannot pause the pool. But suppose your scenario is like you run it once in a day at 10 a.m. and throughout the day you don't use it, then so there is no purpose, right? That you should keep it on for the whole day, right? So in that scenario, what you can do it, you can write PowerShell scripts. Okay, and you can create a Azure DevOps pipeline. So you have to create a Azure DevOps pipeline where you can write PowerShell scripts. So that what that PowerShell script will do, that PowerShell script will basically pause your DB, okay, and then restart your DB. Means maybe you have developed a Azure DevOps pipeline in which you have written a PowerShell script. That PowerShell script will basically maybe pause your DB at 12 p.m. every day in the morning, okay, and then restart your DB at 8 a.m. in the morning. Okay, so maybe your pipeline runs from 10 to 11, so you are pausing it at 12 and then resuming it at 8 a.m. So you can write a PowerShell script and you can deploy that in Azure DevOps pipeline, and then that's the way you can handle it. Okay, see our SQL database.
Is there any option automatic
Sorry.
automatic pause and restart?
Automatic pause and restart. No, automatic pause and restart is not there. Means by timing you are saying, right?
Yeah.
By no, for by timing you cannot pause and restart.
Okay.
You have to create it. Means I did one thing because I was developing one thing, right? I was this similar scenario I faced when I was working with Cosmos DB. My Cosmos DB is also the same. Okay, it charges you constantly. Okay, so and there is no point of me, right, to get charged continuously, right? So at that point of time, what I did is the same. At that point of time, I what I did is like I created PowerShell scripts deployed in the Azure DevOps pipeline. I used to delete that Cosmos DB every day night, and I used to resume it in the morning. Okay, I used to store that whatever was there in the Cosmos DB. Azure Data Lake storage is very cheap. You can store anything. I used to store the data in the Azure Data Lake storage. And in the morning, I used to create a Cosmos DB and revive the content from the Azure Data Lake storage and put in the Cosmos DB. So that way, similarly, you can also avail here. Okay.
Okay.
Okay. So our dedicated SQL pool is created. Okay. So now. There are a few things we will deal with. We need to understand in the dedicated SQL pool and the Synapse SQL pool architecture before we go ahead and start doing all the queries and all from our next classes. Means tomorrow we'll create all the tables and everything, create the shading patterns and all. Okay. So before that, we need to understand some Synapse SQL architecture components. Okay. So let's start with that, the Synapse SQL architecture components. Okay. So you see in Synapse, there are two concepts. One is control node, another is compute node. Okay. Now, how Synapse is designed is like Synapse charges you separately for storage and separately for processing. Okay.
Synapse has designed itself in such a way that you don't get charged when you are not storing anything. And again, you don't get charged when you are not doing any processing activity. Like you are not querying, you don't get charged. So Synapse has developed itself in such a way that you get charged differently for storage and for processing. So in that way, you can save cost. Okay, you are not giving the cost for the activity which you are not doing. Okay, so for that reason, Synapse came up with two features called control node and compute node. Okay, so what happens? What is a control node? What happens is something like whenever you do a query, okay. Suppose you said select star from table name, okay. You fired that query, then that query goes to the control node, okay, and then the control node basically distributes that query into 60 parallel queries, okay, and then pass it on to the compute nodes. Okay, then those 60 parallel queries are being passed to the compute nodes, and from those compute nodes it is getting passed into the storage. Suppose you are fetching it something from the storage. Okay, so that is how the Synapse has been designed. The distributed query engine runs on the control node to optimize and coordinate parallel queries. It means the control node is the main node which optimizes and coordinate the parallel queries, and this control node passes your select star from query to different compute nodes. Okay, and when you submit a T-SQL query, the control node transforms it into queries that run against each distribution in parallel. So that's why Synapse is having the MPP engine, which is called massively parallel processing, because your control node is distributing your query into different compute nodes, as a result of which it can perform in parallel. All the compute nodes perform in parallel. It helps you give faster performance. So that's why it is called massively parallel processing engine. Okay, coming to the next part, what is compute node? Okay, distribution maps to compute nodes for processing. Okay, what I said is control node passes it to different compute nodes for processing. As you pay for more compute resources, distributions are remapped to available compute nodes. Okay, so whenever you are developing something, there is a fund of nodes, I told you, right? So the more nodes you assign it, the more nodes, the better performance you get. So that's how the control node and the compute node works. The number of compute nodes ranges from 1 to 60 and is determined by the service level for Synapse SQL. So the compute node is just CW you use from 100 to 30,000. Then likewise, the compute nodes are also from 1 to 60. It depends on you how much compute nodes you want to assign. Based on that, your control node will pass on to those nodes. Okay, so this is the work of control node and the compute node, which helps in massive parallel processing of the engine. Now there is something called data movement service. Okay, so what is this data movement service? Okay, so you see this DMS which is there with every compute node. So this DMS service is the data transport technology that coordinates data movement between the compute nodes. So what happens is something like whenever your control node receives it, your control node passes into different compute nodes, right? But there is a service which is called data movement service. This data movement service helps to coordinate the if suppose you have a query which needs data movement. Suppose you are trying to fetch some data, and control node has passed it to different compute nodes, and maybe one of the compute node needs some reference to from a different compute node to get the data. Okay, so at that point of time, DMS is activated, means data movement service gets activated, which helps to coordinate this data movement between these compute nodes. DMS ensures the right data gets to the right location. Okay, so that is the work of the DMS, that it should know that whichever the data it is going to different nodes, it should go to the exact location. So that is the primary use of data movement service. So and at the end of the day, maybe you are storing something in Azure storage. Since your data is stored and managed by Azure storage, there is a separate charge for your storage consumption, as I already said, right? Azure Synapse is designed in such a way that it charges you separately for processing and storage. Okay, so if you are storing something after doing these operations, then it will charge or else will not charge. But if you are storing something, it will have a separate charge for you based on your whatever storage you are using, right? So it is not mandatory how much storage you are availing, but it charges you how much storage you are consuming. So there also lies the difference. Okay, it's not like you are availing this much of storage. You have taken a standard subscription of Azure storage, and it is having suppose 20 TB of it storage, and you are using 1 GB of storage. So it will charge you for 1 GB of storage, not 20 TB of storage. Okay. Now Azure data is stored in three patterns. You can choose which sharding pattern to use to distribute the data when you define the table. These sharding patterns are called hash, round robin, and replicate. Okay. So whenever you store data in any in Azure Synapse, the data are primarily stored in three patterns. Okay, one is hash, round robin, and replicate. And this is very important, trust me, because whenever you create the tables in Azure Synapse, you need to mention what type of table you want to create, whether you want to create a hash table, whether you want to create a round robin table, whether you want to create a replicate table. Okay, so you need to exclusively mention that. If you don't get the usage of these these sharding patterns, then what you will end up with, you will end up with having a wrong design, which will help you suffer a lot when you will have a huge volume of data and you will start querying those data as having multiple joins and everything. Okay, so you need to understand these sharding patterns very well, so that whenever you create tables, whenever you create fact tables, whenever you create staging tables, you create log tables, you must be sure, you create dimension tables, you must be sure that what type of sharding pattern you should use while creating those tables. Okay, now let's talk about the first type of sharding pattern, which is called hash distribution. Okay, what happens in hash distribution is like, suppose you have a table. Okay, each table is having a number of columns, so you need to define one hash column. Okay, so in hash division, what happens is like, you define one hash column. A hash distributed table can deliver the highest query performance for joins and aggregate on large tables. Okay, so hash distributed tables are basically used for joins and aggregations on large tables. They are primarily used for fact tables. Okay, and the tables which have around data of more than 2 GB, it is prescribed that you go for hash distributed tables. Okay, so it will give you very good result and a very impressive result. Okay, to shard data into a hash distribution table, a hash function is used to deterministically assign each row to one distribution. What does it mean? It means, as I said, whenever you want to create a hash distributed table, you need to create a hash column. Okay, like we used to create primary keys on the tables. Likewise, you need to create a hash column on the hash distributed table, and based on that hash column, your distribution of the rows to the compute nodes will be done. Okay, it means your hash function is used to determine each row to the one distribution. Okay, so basically whatever the hash function you design, you define it over here, based on that hash function it will distribute your data into the different nodes. The hash function uses the value in the distribution column to assign to each row into distribution. Okay, so suppose I am giving you an example. Suppose there is a scenario, consider you are making a hash column. Okay, in one of your table, and suppose that it is having 60 rows of 1 and 2 rows of 2. Okay, so how the distribution will be done? All the 60 rows will be distributed to one of the nodes, and the two nodes and the two twos which is having in that row. Okay, you have two rows with two values, so that two values will be passed to a separate node. So that is how the distribution is being done. So whenever you are trying to fetch it, so what happens, the records which are having 60 rows of one, that is given to one node. So it is very easy to fetch records if the distribution has been designed like that, because Azure Synapse Analytics know in advance that which compute node is having which data, which of the data. So it can easily help you retrieve the data, and and it will be very faster, right? But suppose what you do is like you create a hash column on a date column, suppose, Raghu. So then that is a mistake, because you have thousands of records in the table, and every date is different. So what happens, it will pass each and every date to different nodes, right? So it doesn't make sense that every node will contain only one data, right? So it doesn't make sense to design your data to put a hash column for a to make a date column as a hash column, because it won't get you the desired result or the faster performance, because it will be every date will be distributed to different nodes. Okay, so it won't be helpful in that scenario. Okay, so I hope you are clear when to create a hash distributed table and why to use it. It is primarily used for fact tables, and which where data size is larger than 2 GB of data. Now, what is round robin distributed tables? Okay, there is another sharding pattern called round robin. Okay, what happens in round robin is like, firstly, round robin also deliver fast performance, but round robin is prescribed for staging table, means for loads, means where you are dumping the data. You are not using that table to retrieve the data. Like fact tables are used to retrieve the data, right? But in the staging tables or in the one-time load tables or in the one-time load tables, what you do is like you do a direct dump of the data, right? You generally don't retrieve or the information like you do in the fact table, right? So in those types of tables, in the staging tables, you can make those staging tables like round robin tables. Because what happens in the round robin distributes the data to different nodes, but in a skewed fashion. What does mean by skewed fashion? In a random fashion. Okay, means it is like in a hash distribution, it is having one pattern, right? It will distribute all ones to one node, twos to another node, but it will divide the node, it will distribute the data randomly. Okay, it will distribute it to multiple nodes, but it will distribute the data in a very random nature, as a result of which uh, if you want to if you use it in for loading that for in the tables which is used for loading, then it will give you very fast result, because it will randomly split up the data into different compute nodes and will help you store the data. Okay, so that is faster. But if you want to retrieve, use it for retrieving, so it is not having a definite pattern. It has used random pattern to share to divide the data into to distribute the data into random nodes. So at that point of time, it won't give you very good result. Okay, so you should use it for staging tables, or with the tables which is having maybe data of 1 GB, you can also use round robin over there. Okay, because it is having small amount of data, then it will be very easy to fetch it, not very difficult. Query performance can often be better with hash distributed tables, as I told you, that if it's having a okayish table maybe of 1 GB or something, you can use it. Joins on round robin tables require reshuffling data, which takes additional time, because the data is in a random pattern. It is not in a proper shuffled way. The data has been reshuffled to different nodes, so it will take obviously additional time. So that's round robin. The last is replicated tables. Okay. So what is replicated tables? Replicated tables provide the fastest query for small tables. So when you have small tables which is not having so much of data, so you can use maybe you are storing an information, like maybe once a day your pipeline is running, and you are storing the pipeline related information like data factory name, time and all, maybe in a log table. So those type of tables you can make it as a replicated table, because those will be small tables. It will have a single entry for each record for each run. So you can make those types of tables as replicated tables. And what happens in the replicated tables, primarily in case of replication, what happens, the same copy of the tables is being given to multiple nodes. Okay, a table that is replicated caches a full copy of the table on each compute node. So how much or whichever compute node you have assigned, it will basically distribute that entire table content to all of it. Okay, so basically it will hold multiple copies of it in multiple nodes. Okay, the same copies in multiple nodes. Okay, consequently replicating a table removes the need to transfer data among compute nodes before a join or aggregation. Query performance can often be better with hash distributed tables. As I have said, if you are doing query, if you are retrieving something, fetching something, then it is always better to go with hash distributed tables, because uh, it gives you faster result. Joins on round robin table require reshuffling data, which takes additional time, as I told you, and replicated table is prescribed for small tables, as it holds a copy of the same data in multiple tables. So it is basically consuming more memory, right? So when you are having the same volume of data and you are replicating the same volume of data in your multiple tables, then what is the thing you are doing? You are basically, you are ending up consuming more memory. Okay, so hence, as a result of which the performance can be impacted. So it is prescribed to use for small tables. Okay, so till yesterday we discussed on these replications, on the shading patterns and everyone. I hope everyone is clear on top of that. Okay, so yesterday, if you remember, we are facing some issues with uh, uh, seeing the workspace, right? We are facing these issues, like we were not unable to see the workspace on the left side. Okay, so what happens is, so whenever I will tell you this, so whenever you will create it, so there is something called a refresh button over here, right? So you need to click on once you create any spool or any workspace, you always need to click this refresh button over here, so that this entire window gets refreshed. In the After this window gets refreshed, we will able to see this. Means once I click on this, entire window will get refreshed, and then it will be able to see me. Or you can directly close this and reopen this from here. Okay, and so one more thing I want to show you. I created a dedicated SQL pool yesterday. You guys remember? Hope so. You guys remembered. You see, I forgot to uh, turn off that dedicated SQL pool. I just created it yesterday only, and I forgot to turn off that thing. So what it resulted to, I will show you that in only one day I end up spending 2,500, around 2,000. Got me a credit of 15,000, near to 15,800, I guess. And right now I am left with 13,742. Okay, so you see, it has charged me, means the Azure keeps updating itself. As of the point it has got updated, okay, it is showing me as 1,210 rupees. Okay, so but it has charged me around, I guess, 2,000 rupees, because I was having the credit of 15,500 or 600. Okay, so in one day this much. So if you going forward, if you guys are creating the dedicated SQL pool from your work environment, okay, from your free trial environment, please make sure that you go ahead and uh, pause it. I will show you once how where to pause it from. Okay, uh, so this is the training DB we created. You can directly pause this training DB from here. You can click on this pause and it will take some time, 1-2 minutes of time, and it will pause you. Okay, and only with 100 cc I am having this cost. If I would have taken more than 100 cc, then it would have costed me much more. Okay, so this is the thing, okay, I wanted to tell you about. Okay, so now today we will do some activities with dedicated SQL pool. We'll do some activities with the
Spark pool. Okay, so let's go to the dedicated SQL pool we created yesterday. Okay, so this was the dedicated SQL pool we created yesterday, Synapse Training DB. Okay, you can also see this here if you go to the data tab, and if you see in the workspace, there are two DBs you can see, right? One is Synapse Training DB and one is Training DB SQL. So this Training DB SQL is the logical data warehouse which we created yesterday on the first thing. The logical data warehouse is related to the serverless SQL DB. Okay. So as I told you yesterday also that serverless SQL DB consists of external tables. So you see there is external tables and external resources and everything. And in the Synapse Training DB, whereas Synapse Training DB is the dedicated SQL pool which we created yesterday. So if you see both the dedicated SQL pool and the serverless SQL pool DB, you see the only difference between the two is here you are getting only one extra option, that is tables. So this table can contain the structured data. So you can create structured data over here, but here below it you can be in the server logical data warehouse or serverless SQL pool DB, you cannot create structured tables. So it is pretty clear from this, right? It is pretty clear from this thing. Okay, now the next thing I want to show you, till this point we worked yesterday. Now the next thing I want to show you, right, once you have created the dedicated SQL pool, where can you find it from the home page and how you can use SSMS to directly log in into that. Okay, so let's go to the home page. So this is the home page. Okay, so what you need to do first is like you have a workspace, right, listed over here, Synapse workspace, which was under which we were putting all our resources. Okay, so inside the Synapse workspace, sorry, Synapse inside the resource, where sorry, click from inside this resource group, if you go, you see all your everything has been listed over here, all resources. Spark pool I've created today to show. I will show you later on. Apart from that, till yesterday we created a Synapse workspace, we created a storage account, and we created a dedicated SQL pool. Okay, so if you go inside this Synapse workspace, you will be able to see a few informations. One is SQL admin username. Okay, one is dedicated SQL endpoint, one is serverless SQL endpoint. Okay, so this SQL admin username is going to be your username. Okay, it's pretty clear. Now when we created dedicated SQL pool yesterday, you might have noticed here when we created the dedicated SQL pool from here yesterday, when we created this dedicated SQL pool from yesterday by clicking on new, we just put the name over here and we press review plus create and create. But there was no area where we could have chose the password or you would have given the password or something, right? So there was no option of that. Okay, so what happens when you create it from here and click on Azure Synapse here, so admin username you get by default as SQL admin user, but the password, for the password there is an option called reset SQL admin password. Okay, you can click on this reset SQL admin password and create a new password and re-enter the new password and click on save to get your password by your own, which I have already done. Okay, so you can create this, you can give some password here and here and click on save and it will save your password. Okay, so once you are done with that, next come to the dedicated SQL endpoint and serverless SQL endpoint. So what are these dedicated SQL endpoint and serverless SQL endpoint? So this dedicated SQL endpoint refers to your server name. So whenever you try to just so whenever you try to go inside, go and try to connect with the database engine, here it asks for the server name, right? So here in the server name you have to give, I have already given yesterday, that's why it's here. Here in the server name you have to give the
endpoints. So like you see, I have given here the endpoint of the dedicated SQL pool. This is the dedicated SQL pool endpoint which I have given it over here. Admin and password I have given, and if I press on connect, so if I press on connect, the SQL server will get connected to the dedicated SQL pool, and whatever you can see over in the portal, you can directly do it from here. So you see, if I expand the databases, there is something called Synapse Training DB. It takes the name by default, whatever name you give as the dedicated SQL pool name, na? Whatever you name you give as the dedicated SQL pool name over here, it takes this name here. It takes this name directly over here, Synapse Training DB. And going inside this training DB, you can create the tables and everything it is having. Like a normal SQL server, it will have all the options to create tables, views and all. Okay. So, so today we'll do some actions. Okay. I have already created some things. I will drop those. Okay. And we'll do some actions over here. I will drop this too. So I've dropped this too. Okay. I will do some actions now. So to do some actions, the first action, what I want to do is like, I want to create a table here and do some actions over. I will just go ahead and create a SQL script, which we have already done before as well. Okay. I'm leaving it as SQL script 1 as of now, the name. Okay. Now I will directly do some activities over here. Okay. So I will try to create a table. Okay. So to save time, I have already written some codes. So I will go through the codes and try to explain you everything. Okay. So if you look at this code, so here when I will try to execute the code, I have to select Synapse Training DB here first, okay? Because by default, this SQL script gets connected to the serverless. So I have to exclusively select this Synapse Training DB, okay? Connect to the Synapse Training DB, it will take the database. If you have multiple databases, then you have to select it from here, but or else it will take the Synapse Training DB database, okay? So what is this code showing is like, if this table does not exist in this database, then create this table. This is the first piece of code I have written. First I am checking in the system functions, which you can do in normal SQL also. You do, right? sys.objects to and join with to check whether this table is already present in on there or not. So if this table is not present, what you do is like, you go ahead and create this table. Okay. So this is the code you write generally. Okay. So now I have given all these. Okay, the data types here are also mostly similar to SQL only. Int, float, and numeric, and all these things are accepted over here. Now you see, yesterday we talked about the distribution patterns, right, or the sharding patterns, right? Wherein we discussed about heap, round robin, and also we discussed about replicated tables, right? And I told you that the hash partitioning you use using with a hash column, when you have a fact table or something which is having more than 2 GB of data, but whereas when you are normally you can work with the round robin or the replicated ones. Replicated table, round robin, you do it for the staging table or where you have small amount of data. So you can always go for the round robin, and replicated tables can be used exclusively where you have very small amount of data, and maybe you are maintaining some log tables for to record all the Synapse Data Factory informations and everything. Okay, so see, I have given that the distribution will be a round robin and a clustered column stored index, which is same as the clustered index which we were talking about yesterday. Okay, I have exclusively mentioned that. Okay, next there is one more thing. So in how to write with distribution, so this is one extra thing which you don't generally do in your normal SQL tables. So along with the create table code, inside a bracket you have to write with distribution equal to round robin, and if you want to put some indexing on top of that, you can write that. Okay, so this is one thing you do generally. Okay, and the same thing what you do is like, and the same thing if you want to create a fact table, okay, or if you want to create a hash distributed table, so you need to write something like this. You give the table name. Okay, you give the entire table name, what is the table name, and then or what is the table columns, and then you need to give the distribution a hash, and you need to mention that on which column you need to make yourself a hash column. Okay, so here you can see I have made here the product key as an hash column, right? So I told you yesterday, right? So you need to make a column as hash column, which you find when you have n number of data id columns or something. So all different id and you have maybe all different type of repetitive ids, right? So in that case, because product key is, it's a fact table, right? In the fact table you are do the hash partitioning, right? So it can have repetitive values of product keys, right? So here what you will do, right? Suppose you are having 20 product keys with value as 5 and 40 product keys with value as 10, and the list goes on with that. Then what it will do is like, it will uh, allocate those different product keys to different control nodes. Okay, wherein they will store all the different product keys in different control nodes, so that at later point of time when you query the data, it can fetch the result much faster. Okay, so that's why you do need to do it like this. Below it, there is something I have written, dbcc uh, uh, dbcc pdw show space used. Okay, so this is a by default stored prog. I have where you can pass the table name. In this stored prog you can pass this table name, and you can check that how your data has been skewed. Yesterday we talked about skewing, right? Skewing means putting the datas or distributing the datas in different nodes, right? So you have a fact table, and you have already inserted all the values and all. So after you do this distribution, you will see that your data will get, you can clearly see that whatever product keys you are having, whatever number of product keys or whatever different values of product keys you are having, so that has been distributed to different nodes, that has been distributed to 60 different nodes. Okay, so that if you are having uh, those things, it will get distributed to 60 different nodes, so that you can see clearly if you execute this stored prompt. So this is just for the knowledge purpose. Okay, you can see it at the background what is happening. Okay, next is for the replicated tables. If you want to create one, okay, so likewise I have made the distribution equal to round robin. So you just need to change the distribution as replicate. Okay, the code remains the same. Instead of round robin, you need to put replicate over here, and you need to run the code. Okay, so this is the way to create replicated tables, hash distributed tables, and round robin partitioning tables. Okay, so you guys, once we are going to, before we go and create this table, take an example and create this table. So we'll go ahead and create this code, create this table. We'll try to create this table and see what happens. Okay. So I have connected to the Synapse Training DB here and it will run it. Okay. So you see it gives me query executed successfully. It means it should have already created the table for me. So I will go here. As of now there is no table. I will refresh and you see we have the table over here. We have created the table successfully over here using the round robin method. Okay. So similarly, you can change the round robin with a replicate. You can clearly change it with a replicate and to do the replicate, and also you can do the hash. I have already given you the code for hash also here. You can do using that hash also. Okay, that you can try on your own once you go back and create these SQL DBs. Okay, you can try on your own those things. So I've given you a small example for the same. Okay, so next what we are going to do is like, so our database is already our table is already created in the database we created yesterday, table we created today. Okay, now post this, suppose what I want to do is like, I have what I want to do is like, so I have created a dedicated SQL pool here. Inside that I have created a DB and I have created a table. Okay, but this table is having no data, right? As of now this table is blank. If I execute, this table is blank. I want data here, right? So what I will do is like, we yesterday or day before yesterday, what we did like, in the storage account, in our storage account, where is the storage account? Here is the storage account. So in our storage account, in our one of the containers, we have uploaded this nic trip small parquet file, right? Day before yesterday we did this activity, right? So what I want is, this parquet file here in the storage account is already having the data. Okay, I want to get the data from this parquet file and I want to insert that data in this table in the dedicated SQL pool. Okay, so as you all know that this Parquet file is having a unstructured. We are having unstructured data in the Parquet file, which we can query only in the EA part. So what we'll do, we'll get the unstructured data, because I told you that you can have structured unstructured data over here, and we'll get this, and you can query files over here. So we'll get the data from a Parquet file over here and we'll try to put it in a structured way in a table over here, right? So how to do that? So for that, there is a code which I will discuss about. Okay. I think it is visible to you, all right? Yeah, I think it's visible. Yeah. So the code is like, copy into dvo.nic taxi trip small, which is the table I have created. Okay, and you give all the table names over here, all the column names over here. Okay, and then what you need to do is like, you need to pass like, from where, from where it will copy. It will copy from the storage account, inside which storage account container, inside which you have your Parquet file. So you need to give the path over here. Okay, so where will you get this path? I've already told you before as well. This path you will get it when you will go to the data tab. You will go to the link tab, and then you have your storage account linked over here. You will click here. This is your container where it is where you have uploaded the Parquet file. You will just click on this Parquet file. You will right click it, click on properties, and this is the URL. You need to copy the URL from here and then you need to paste it over there. Okay, it's very simple. So that's what I have done. Okay, and then you need to uh, mention some parameters. Okay, wherein the file type is Parquet. Max is one of the parameter, you can ignore it. Okay, I have already put as 0, and identity insert is like off. Okay, now identity insert is, you also do it in normal SQL as well, you know that. So now I want to execute this block of code. You can select this block of code and you can click on run. So you can see query executed successfully. So it took only 15 seconds to copy all the NYC Parquet file data into this table. So what is the count? So it is having 1, 2, 3, 4, 5. So 1 lakh data is it having. So within 15 seconds of time, okay, it copied all the data from there to here. Okay, it's quite fast. Okay, and now you can just, if I give you a glimpse, so you have all your data listed over here. Okay, so it successfully entered everything. Okay, so you are done with this thing part, right? So you created the table, you inserted the data. So directly from a file, you queried a Parquet file over which is present in the data lake storage, and you directly copied the data into here also. Okay, so at later point of time also, if you have a client who is having uh, many files coming in and uh, into your data lake, and you want to copy the data to your data gated SQL pool, you can avail these things, this technique. You can do that very easily, right? It's very easy, right, to do all these things. You can query it, you can directly insert it. Okay, there are a couple of other methods also to insert, copy the files and insert the values over here. This is one of the methods I am showing you as of now. Okay, as we go forward, we'll see more methods and all. Okay, so the next thing what we want to do is, suppose what more activities we can do from here. Is it only table creation and this thing? No, we can even in the workspace we can even do we can also, so suppose from this data maybe you want to this thing I have already showed you once. Okay, but with this I will show you one more added thing. Is like uh, I want to calculate the average of whatever data you have right now, from which I want to calculate the average and sum of your trip distance miles. Okay, and what I am doing is like I am taking this piece of data from here and I will create a new table and put it into there. Okay, and I will see what happens. Okay, so the codes are already written, so that also you can do from here. Means everything you can do from the here itself. Okay, so it is retrieving the query results. The idea is to show you that how fast it is. Okay, queries so you can write, I know, but idea is to show you how fast it is. Okay, that out of 1 lakh data it will do all this sum, average, everything within seconds, and it will just create a table and will do it. So if I refresh it, so you have created another table, and so you have created another table and you have done all the some distance, average strip distance, everything, right? So and also you can see that it also came over here as well, because I also have written the select star a statement over here also, and the same thing you can select in a chart as well. Okay, you see that this line chart is showing some of the values, because the legend is having the passenger count and the sum of trip distance. Okay, so this is how you create table, how you create database, create dedicated SQL pool, create database on top of that, create table on top of that, and insert the data from a Parquet file stored in Azure Data Lake storage to the dedicated SQL pool, and on top of that you can even query that table and put the queried result in a different table as well, and you can show line charts and everything. So this is an end-to-end flow of your dedicated SQL pool, how to do all such activities. Okay, so next we'll move to Apache Spark pool. So before I move to Apache Spark pool, so do you have any doubts? Please feel free to ask. Do you have any doubts?
Yeah, one doubt here. If you get
Yes.
any error loading data into destination, so where should we see error log?
Sorry. Oh, acha, error. If I would have given a missed a comma or something or here, so if I would have removed it and executed it, would have given the error here on the results tab on. That's what you asked, right? Where it shows you the error, right?
Yeah, so while loading into the destination table, so where we
So
get
it will
error log.
loading into the destination table. It will give you the error logs, or you are asking about where it will show you the error.
Yeah, error. So can you show
Error.
me? So
Sure. Suppose maybe I have removed this here, so it should show me a error, right? This is the error. Parse error at line 47. Expected but did not find a closing quotation mark after the character string. So this is the thing we are asking, right?
yes. So is there an error in the source? How we can
Source.
resolve? Yeah.
Source, there is no error in the source. Source, so you have uploaded it manually, right? Source, so you have just uh, gone to the source. Where is the source? Storage account. Okay. Source, so you have manually uploaded it. Means source, what error you will get. Suppose you go to the containers. So inside this container, you are manually uploading it from here. Source. Okay. So if you design a pipeline to add data here, then you get any error, then from wherever you are doing that activity, there only it will show you the error. If you are doing this activity from here, then it will show the error in the messages section. If you have designed a pipeline to do that, then in the pipeline execution window only it will show you the errors. Okay, there is, this is the place to show you the error. Okay, but as of now, whatever activities we have performed, we haven't performed anything in the pipeline as of now. That is an upcoming thing we'll do. But as of now, you are doing a manual upload here. So what is the thing you can get? The error it can give you is, suppose if I want to upload a file, suppose if I am uploading the same file, okay, and I haven't selected, suppose I haven't selected this is the error how it gives you in the source. The following files already exist. Okay, so if you click on override, then you can upload. You got my point? So this is how it gives you the error. Okay, as of now what we have seen. Okay, so this is it. And the thing you are asking is like, you have a pipeline designed already from source to destination, and that thing is giving you error and all. Okay, so that will come going forward. We'll see that. Okay, that if you are having, we'll do some mistakes in while developing the pipeline, and we'll see how it throws you the error. Okay, so even not only that, also what happens is like, uh, uh, there in pipeline also, I'm just saying it since you asked me this question. Okay, so you create a pipeline. Okay, so suppose you dropped here a copy data activity. Okay, so if I want to run this copy data activity now, it won't allow me to run even, because before you want to run it, your copy data activity needs to be validated. Okay, you see it is giving me direct IA. So the first step is validation. What is validation? The validation is a basic step where it expects you that whatever the important parameters marked as star over here, you should pass those parameters correctly first. Means likewise you done a stored proc, right? Execute stored proc and you don't pass the parameters and all. Okay, so obviously, right, yeah, it don't run, right? So this is right a validation for you. That first level of validation is you should always have all the things, all the source dataset and sync dataset, everything should be mapped. And then the next level of error is like you have done some thing in your data, or your data is having some problem. Maybe in the source part you have integer, maybe source in the source in the you have one field as string, and in the destination where you are dumping that field is an integer, right? So obviously it cannot integer string into an integer field, right? So at that point of time it will give you a error over here. Okay, this is the place where it will run and it will give you a error over here. Okay, so or maybe when your everything will be scheduled, if I show you in real time how it happens, I will show you. When your pipelines will be scheduled and you have everything done already in an automated process, so there is a tab called monitor. Okay, here also you are having this tab, you see here also you are having this tab called monitor. Okay, so here is a tab called monitor and you can monitor all the pipeline runs over here. Okay, so see all of these pipelines are succeeded. So maybe if I select last 7 days, you can select how many days loading. So you see I should have one of the failed pipelines over here. Okay, see this is one of my failed pipelines. Okay, and it cannot connect to a database when it is paused. Means what thing is that at that point of time I was increasing the DWU of the database. Okay, so before increasing the DWU of the database, I just went ahead and paused the database uh, to stop all the concurrent executions, and then I started it and increased the DWU. Okay, so that's why it gave me that failure. It failed and gave me that cannot connect to database when it is paused. Okay,
So this same copy data can you do with serverless pool also, with database attached to that serverless pool?
okay. So when you are working with the pipelines, okay, so copy data activity is an activity. So serverless SQL pool, and so what you are asking is, suppose I will give you the use case. Okay, you have to understand the use case first. So in a copy data activity, what you do, you have a source, you have a destination, right? Okay, so your source is suppose Azure Data Lake storage, that NYC trips Parquet file we have uploaded here, and your destination is the place, should be the place. Now your question should be that can I use a copy data activity to load data in a Synapse serverless SQL pool DB as well as a dedicated SQL pool DB? Yes, you can. Okay, but one thing I have already told you, that serverless SQL pool DB is not structured. I have already shown you here in the workspace that you don't have tables here, you have only external tables here. So you can create external tables. Okay, but you cannot create normal tables. So in order to have to store data in a structured table, you have to use dedicated SQL pool only. Is my point clear?
What do you mean not structured? Like if I attach a
Means
external
you,
table, SQL table,
sorry, if you attach the external tables to
if I attach an external SQL table to the serverless pool, it is dedicated.
uh,
Sorry, it
uh,
is It is structured
Again,
only.
again I have told you that what is an external table. The external table is a logical view of the table. It's not a physical table, right? External table doesn't store data, right? External table, if I have shown you the code for the external table, it just holds a pointer to the table, right? It just holds a pointer to the data which is stored in the data lake storage. So what it does, it basically it basically directly queries the data in the data lake storage directly, right? It doesn't query your table. You cannot write select star from table name, right? In the dedicated SQL pool, or you cannot use your facts. You cannot develop your facts and dimensions on top of your uh, uh, data lake storage, right? You anyways need to bring that data into your normal table, right, to develop facts, dimensions, and everything, right?
Hmm.
Because you will not only create a single table, right? Suppose if you want a one-time load and you just created an external table, pointed the reference to your Azure Data Lake storage, that is fine. But if you want to create a complete data engineering solution, which we generally do, creating one-time load, creating incremental load tables on top of that, to have because incremental load we create so that it don't have take any duplicates. One time load might have duplicates and all, right? So incremental load, we do the delete and insert or update and insert operation, right? So in the you create incremental load. On top of that, you create your dimensions. On top of that, you create your facts and then your views to access everything. So you need to come here. Okay, you need to put the data in your physical tables, right, to do all such activities. You cannot do all such activities based on your Azure Data Lake storage, can you?
Okay.
No, right?
So can you go back again?
Go back where? Tell me. Sorry. Go back here.
So
Okay.
what you showed in training DB, can you show the training DB? The serverless pool.
Yeah, this is the serverless pool training DB. Yeah.
So the pointers to the tables here, where will they point to?
It will point to the Azure where your file is located. You have placed the file in the Azure Data Lake storage. It will point to Azure Data Lake storage container.
Okay.
That's why you right click over here, go to the properties section, and you select the URL from here, right? It points to this URL.
No, not this one. Go back to the external tables in SQL. This training DB. So if I have a table here, what is the table pointing to? Like you said.
I will open an external table from you. Okay, I will open a code of an external table. It will be clear for you. This is the thing I was saying. See, okay, it is giving you a location. It is a data source equal to data lake external source. Okay, yeah, what is this data lake external source? Actually, this data lake external source have been already coded with this URL. Okay, so this is a variable we are taking here as of now, but this already has been coded behind with the URL of the source, which is this URL. Okay, so this has been already, since I am passing, I have coded it with this URL and I have saved with this parameter, and then I am passing this parameter over here. That this is the data source parameter. Okay, and then I am also giving the location over here as well, that inside this is the folder where you can access the file, and inside that folder the format of the file is Parquet file format. Okay, so that is how you do it. Okay, so in our tomorrow class we'll work with the external tables only, means we'll create external tables, we'll see how a data source is created, we'll see how a location is created. So tomorrow's class is based all of the external tables on. So that is the only part remaining in this. So in tomorrow's class we are going to cover these things in detail. Okay.
So
Let me.
the meaning of that is basically to query your data lake storage.
Right. Absolutely. Okay. Absolutely. You query your data lake store. You got it right. Any doubts? Does that clear your doubt? Does that clear your doubt?
Yeah.
Yeah. Okay. Any other doubts?
But our data lake storage can have unstructured also, right? So only blobs which can be properly queried, I think those will go to serverless queue, right? Serverless pool.
Right. Which you can properly queries and all. Right.
Like that Parquet file which is
Right, this Parquet file and all. Means you can query Parquet files, you can query what
CSV
I
and
should say, CSV, Avros, XMLs and all everything. So what are the formats I showed you yesterday, na? Over delimited text, okay. I think around 10-12 formats you can query. You can have files in those 10 to
whatever
mostly.
can be queried can be moved to serverless pool, basically.
Right. Whatever you can query, you can move to serverless pool. Right. Spark pool. Okay. So we talked about, as of now, we talked about two pools, serverless SQL pool, dedicated SQL pool. The last one is the Spark pool, which we are going to see. Okay, so let's go. So here we'll use PySpark coding to do. It will also be interesting for you. So where is our presentation tab? Okay. So what is a Spark pool? Okay. So Apache Spark is a parallel processing framework that supports in-memory processing to boost the performance of big data analytic applications. So on the very first day, if you remember, I told you that when I was explaining you the differences between uh, Azure Data Factory and Azure Synapse, you remember, right? I told you that the analytics runtime is having something called as Apache Spark, which helps you. If you see in this diagram, it is something called as Apache Spark, which helps you to do the big data analytics work, okay, or the data analytics processing. In our, if we would have gone through our Azure Data Factory part, then at that point of time we have to use another resource called Azure Databricks to do all the big data processing, okay, big data analytics processing, and then we have to bind Azure Data Factory and Azure Databricks together, okay. But here in the Synapse, it gives you the Apache Spark pool or the engine within itself only. You don't need any other service to subscribe to. It will give you the engine itself only, so that you can perform all the big data operations, okay. So that is the Apache Spark pool, okay. We can create serverless Spark pool under management hub menu in Synapse Studio. That is what it is showing you, where we can create the serverless Spark pool, okay. The next thing is understand the serverless Spark pool. A serverless pool is a way of indicating how a user wants to work with Spark, okay. When you start using a pool, a Spark session is created. So what happens, like when you create a Spark pool over there, okay. So I told you yesterday, right? Spark pool has its concept of clusters and nodes, right? So what is a Spark pool basically? So when you design a Spark pool at the back end, you create some clusters and nodes based on which, based on those cluster and nodes, what it does is it does the processing, right? It does your big processing of your coding, right? Or whatever big data analytics processing you want to do, right? So, and when you connect to that session, like in the SQL scripts, whatever you are doing right now, we used to connect to the built-in SQL pool or the dedicated SQL pool, right? Now here we need to go and create a Spark pool, and then we need to connect to a Spark pool, okay. And here, instead of SQL scripts, we will create notebook scripts. Here right now we are creating SQL scripts, and to write the to do the big data analytics things, we need to create notebooks where we'll write PySpark code. It supports you 3-4 languages, I told you. And and what happens, and then a Spark session gets created, okay, and then you can execute one by one your line of codes and everything that we'll go and see. Okay. The pool controls how many Sparks resources will be used by that session and how long the session will last before it automatically pauses. Okay. What happens whenever you create a Spark pool, okay, and then you connect to the create a notebook script and connect to a Spark pool, what happens is like, and you write a piece of code, then the Spark engine or will basically determine that whatever code you have written, how many nodes it is required for to execute that. Okay, so you can have 3 to 10 nodes, 3 minimum, 10 maximum. Okay, so maybe you while creating this Spark pool, okay, if I show you, so you see there is something called, right now we created dedicated, there is something called Apache Spark pool. Okay, so if I create a Apache Spark pool here, I need to give the name. Okay, suppose Spark pool 2. Okay, then you see uh, node size are of, these are the node sizes you can. Okay, these are the different cores present over there. Small core, medium core, large core, X large, extra, double extra large. Okay, so you selected suppose small core. Okay, so in the small cores, first come the concept of cores, which is basically a VM type thing, and then come the concept of nodes. So inside a core, how many nodes you have? Okay, so you can have starting from 3 to 10 nodes. Okay, so if you do, if you leave it like this and click on create, so you see estimated cost per hour will be 130.05 to 433.51. Okay, it's a huge one. 130 to 433 means you are leaving it on your Azure Spark engine. Key boss, I have written this code. Now you see key, if this piece of code requires more nodes to be executed, I am leaving you freely. You dynamically determine that what will be the best result or the best performance I can get to run this code, to run this block of code. So I'm leaving the node on you. If you require 10 nodes, you take 10 nodes, man. I don't have any problem, but I want the best performance result. Okay, so that's how you can leave that on the Apache Spark engine. That Apache Spark engine or session will dynamically determine the number of nodes it will require, and then it will run and give you the performance, give you the best optimal performance you can get. Okay, but when you should create it, it is advisable that you do it only 3. Means here you are saying ki boss, nodes maximum 3. Okay, not more than that. Okay, because here is a pricing factor, because if you leave that up to 10, so maybe you have written a big piece of code, and maybe it will take 433 to give you the best optimal performance. But I don't need, I mean, since we are using for trial, I don't need performance here. Okay, so yeah, I see the cost from 130 to 430 has got from 130 to 130 only. Okay, so post that you can click review plus create. Okay, and you can click on create to get it created. It takes 3 to 4 minutes of time to create this Spark pool. Okay, I'm not creating it right now, then it will again take some time. Okay, so I have already created it, but it will just, you need to press on create and it will create. Nothing else, nothing else. Okay, this card changes. You see, I have, and once it is created, it will give you a message like this: successfully deployed the Spark pool to the workspace. Okay, so once you get this message over here, then it means your Spark pool is created. Okay, and once your Spark pool is created, you can see in here in the Apache Spark pool that your Spark pool is created with 4 core, 32 GB, 3 to 3 nodes. Okay, this is your Spark pool. Okay. So whatever configuration or workspace you have given, it will create. Okay. So this is how you can create your Spark pools. Okay. The pool controls how many Spark resources that I just told you, or and how long the session will last before it automatically pauses. See, a Spark pool works like a serverless SQL pool. Okay. So the concept behind serverless SQL pool and Spark pool is kind of same. Okay. The Spark pool here works with the policy of pay as you go. Okay. You pay for the Spark resources used during that session and not for the pool itself, right? For dedicated SQL pool, what happens is I left that running for throughout one day and I'm charged around 2000 rupees, right? But serverless pool I have also left. I am not charged anything because I am getting only charged for serverless uh, uh, when I am executing the query. Okay, when I am querying the data lake storage. Okay, but here in the EA pool, dedicated SQL pool, I am automatically charged for every hour. But for Spark SQL pool, what happens is it is also like serverless SQL pool. You only get charged when you are Python code, PySpark code, or whatever codes are getting run. When it is not getting run, you are not charged anything. Okay. So you can keep the Spark pool on. You don't need to delete it. You don't need to close it. Okay. There is a Spark pool. Okay. And in the case of dedicated SQL pool, you need to pause it. Here also, you can think key configure the pause setting for the Apache Spark full. So key, how many minutes it can be idle. Okay. So idle means how many when before it gets paused on itself. Okay. So once you create a Spark session, once your notebook gets connected, okay. So and you start writing your notebook code and then you create on run the code, then your this spark pools get started. So once this spark pool takes 2 to 3 minutes of time to get started. Okay. And then suppose you are done with writing the code and then you are writing the next block of code. So spark pool will wait for 15 minutes of time. Okay. So those 15 minutes of time it will utilize, it will charge you, right? Because spark pool is on. Okay. But once after 15 minutes of time it finds that you are not executing the spark pool or anything, then what happen, it will turn off the spark pool automatically. It will automatically go to the uh, off phase, means it will off. But before 15 minutes if you write a block of code and then click on execute, then it will give you the result in seconds. Okay. But after 15 minutes it will again take 2 3 minutes of time to start the pool, and then 15 seconds or 20 seconds or 30 seconds of time based on your code what you have written to give you the result. So this is the way how the spark pool works. Okay. So this is the automatic pause setting you can do over here.
Can I explain that again on idle time?
So whenever you create, suppose here I will show you, then it will give you a better idea because I've already written the code. See, when I wrote all these codes and all, okay, I have attached it to the Spark pool. Okay. So if I right now click on run cell, I will show you when I will start explaining you the codes. If you right now click on Spark cell, it will take 2 minutes of time to start the Spark pool. Okay. And then it will take a few seconds of time to execute this code. Okay. But once I execute this block of code, the Spark pool is on, right? Then when I will execute this block of code, then it will give me the result spontaneously. Okay. But if after 15 minutes, okay, I again press on this line of code, then it will first take 2 3 minutes of time to start the Spark pool, and then it will give me the result. Because it was idle for 15 more than 15 minutes. If it's idle, then it pauses the Spark pool. Okay, got it, right?
So every 15 minutes it will take a pause.
So that idle time you can set over there. You can set to 30 minutes as well. You can enable, disable that, everything you can do over there.
What if the query itself is running for more than say 17 minutes?
Then it will run. Once you are not using it, then it will. Once you are not doing anything, then if it is running, it is a running process, then it will keep run. So idle means what? Idle means the Spark pool is not doing anything. When you say that your desktop is in idle mode, it means you have left the desktop like this. So after 10 seconds, if your desktop finds that you are not doing anything, then it will automatically lock itself, right? What we want to do is like, we have a file called we have created a Spark pool, right? So once we create a Spark pool, what happens? There is something called a lake database. Okay, it gets created. Okay, this lake database had got created, right? You see, this is something called lake database. It has got created, right? So I will just delete this. Okay. So I will just give you the overview, then I will delete. So what is my intention? My intention is I have this NYC trip small Parquet file in the Azure Data Lake storage, right? So what I want to do is like, right now I want to write some Python PySpark code to get the data from this file, from the Parquet, from this Parquet file, and I want to perform some operations on top of that, and I want to store the data in the lake database or the Apache Spark pool database. Okay, so I have created Apache Spark pool database. So I want to write some code to uh, store it in a Apache Spark pool database. Okay, so that is the operation I'm planning to right now do. Okay, so I will delete this. Okay. So in order to delete this, what happens is like, when I click on delete, so it will automatically ask create a PySpark code. Okay, so these are 2 lines PySpark code. Okay, what it is saying, percentage PySpark. What is percentage PySpark? So whenever you need to write any Python code, you need to exclusively mention that you are writing Python codes. Okay, so once you write percentage PySpark, then here it will select the language as Python, and these are the 5 different languages you can choose. Okay, to write codes. Okay, so since I have written percentage PySpark, in the language tab, it has automatically taken PySpark. Okay, Spark.sql is a function. Okay, Spark is a library, SQL is a function wherein I am writing drop database if exists and my taxi cascade. Okay, so I'll run this code. So once I see, when I create on run, so you can have multiple block of codes here, right? So here it gives you an option to run single block of code or multiple block of code. Okay, so I am having this single block of code here, so I want to run this. I will click on this. If I would have had another block of code here, okay, it something is written, I want to run all of them together, then I will click on run all. Okay, then it will parallelly execute all the blocks of code. Okay, so I'm running this. So you see, right now it is connecting. Okay, then it is ready and then it is running. So it will take some time. Like, please wait a few minutes while your session starts. What does this mean? That means my session was idle for more than 15 minutes and Spark pool has gone off. So it is now resuming the Spark pool. So as I told you, it will take 1 or 2 minutes of time to start this Spark pool, and then 1 second or 2 seconds of time to execute this block of code to drop the database. Okay. So once the Spark pool gets started, whenever I will write another line of code below this, it will run. It will not take any further time to start the pool. It will run the code spontaneously. So that's it. Okay.
So we have to wait for some time, means 1-2 minutes of time for this table to get dropped or the database to get dropped. Oof. Okay. Okay. Also, meanwhile this is getting dropped. So as soon as you let's go inside this resource group. Okay. So you see here that as soon as you create a Apache Spark pool, something like this, like a dedicated SQL pool you have created, something like this gets created. Okay, this Apache Spark pool gets created. Okay, so workspace name is there, location where it is get created. You can have this access control to give access to particular people and everything. So these are the things. Okay, and this is also the idle setting, or this is the scale setting. What does the scale setting is all about? The scale setting is all about if you want to or him to change the codes or then increase the nodes and everything. Okay, so these also are the settings present over here. Okay, so okay, and also see uh skills on- यहाँ पे तो नहीं है कुछ. Okay, fine. So let's wait for this to get created. I think it is ready. See, your Spark pool is right now ready. Okay, so this session is already ready. Okay, so it is running this code. So here all of you work on SSIS mostly.
Yes.
Okay, so okay, okay, so you see that this got executed. Okay, this part got executed. So I will just refresh it. Apache Spark session started. Command executed. I'll just refresh it. Okay. See, it is gone. Okay, you only have default here. Okay, that code is gone. That database is gone. Okay, so let's go to the uh, part to understand every block of code. Okay, so okay, so but before that you need to know how to create a notebook. Okay, so in order to create a notebook, you come to this develop tab, you create on this one plus button where we are using SQL script. Right now we'll create notebook scripts. Okay, so let this name as notebook 1. Okay, so first of all you need to attach it with a Spark pool. Okay, Uh, and then you need to select the language. Even if you specify percentage PySpark, it will automatically take the language. Its default language is only PySpark. It takes up that language. Okay, next you need to write the codes one by one. Okay, so suppose I am copying this code from here to here, and then I will explain you everything. So the first line you already know. Now next thing is df equal to spark dot. So what df stands for data frame. Okay. So what is a data frame? Okay. So a data frame is nothing but a logical table where it stores the data. So you can treat data frame as a logical table. Okay. And where it will store all the datas, whatever it is for means it is used to store the datas. Okay, it's a logical table which is used to store the datas. Okay, so that is what is called data frame. So when you are writing Python codes or PySpark codes, it's a very basic thing. Okay, data frames. Okay, so and you will use it very frequently. Okay, to store the data and everything. Okay, so data frame equal to spark dot read dot load. Okay, so this spark dot read dot load, this function is used, this under the Spark library, these functions are used to read and load the file. Okay, so what you are doing, first you are reading the file and then you are loading the file into the data frame. Okay, so that's why this code is written spark dot read dot load. Then once you click on this load and you click on this, it will show you what are the parameters you need to give over here. Okay, so it has got couple of parameters. One is path, another is format. Okay, so you need to give the path, right? Like from which path or which file you want to load, right? So what you give, they when you go to your data lake storage, when you go to your data lake storage, you select this file, click on properties. You see right now, as of now, for the SQL you are using this URL, right? But for the Python you have to use this abfss path. Okay, so this abfss path will be your path for your PySpark coding. So you copy this path and you paste it over here. Okay, and then you are specifying that the format should be Parquet, right? So and then maybe you are saying key display 10 records for me. Okay, from this data frame, because you have loaded this into a data frame. Now you are asking to display 10 records from this data frame. Okay, and now you are running this cell. Okay, so once you are running this cell, so it is running this code. Sure. Okay. So got it. So here it is already ready. Now we are writing this code here, right? So that's why it gave me the thing here. Okay, so maybe we can run it over here. Okay, okay, so you got the results. So can any one of you tell me like what happened right now? Like why it gave me this error, and since I am explaining you these things, so can any one of you tell me what happened right now? Why it gave me that error? Any one of you?
I think all that runtime was consumed by your other notebook.
Right, right. So what happens is like, since I have already created this notebook, and Apache Spark pool was already running in this notebook, right? You see the Apache Spark pool is already ready, okay, and your session will expire in 29 minutes, okay. It is showing me, so it is already ready with this, and I have selected the smallest one, small core and all, okay. I cannot run this in multiple sessions, okay. So that's why it is saying that the Levy session has failed. Okay, so your thing is already has a zero ports available right now because his pool has already consumed all of my ports. Okay, so I have zero ports available, so it cannot run it. Okay, so that is why this error. Okay, so you see what happened, that I have got this code inside this data frame. Okay, and it has given me 10 rows out of the entire data part. Okay, so I read this. Okay, so then this is another block of code. Okay, df.print schema. This code is used to print a schema. Okay, so maybe I can clear cell output. So when you click on this, likewise you can clear the cell output like this. So if I run this code, so you see it is now giving me the results in seconds, right? Because it is already in running phase. Okay. So you see it has given me all the columns and its data types and everything. Okay, so it is giving me the schema, right? There is also one beautiful feature is like this. Suppose I have already put this data in a data frame, right? Now what is my next block of code? My next block of code says, I'm clearing this cell output from here. What is my next when once you have written percentage spicer, you don't need to write every time as well. Okay, what is my next block of code? My next block of code said create database if not exist nyc taxi. Okay, and see, I have already executed this block of code. Okay, and it is in ready state, right? So in its memory, it is already holding whatever the data is inside this data frame. Okay, now I will directly execute this block of code, and I am saying that create a database in the first line nyc taxi, and the second line I am asking that whatever things you are having in this data frame, means is data frame में जो भी उठाया हो, whatever you have picked up in this data frame, you write that in a table. Okay, override means I am saying if some data is already present over there, override that data. Okay, and I am saying key whatever data is inside this data frame, just save it in a table named nyc taxi.tree. Okay, and if the table is already present, then override that table. Okay, that is why this code. Okay, so this part is already executed, right? I don't need to re-execute this part again. Okay, I will just click on this part and see it is created. Okay, so a database has been created here in the lake database. If I click on refresh, see nyc taxi has been created, and you have also got a table named trip. Okay, inside it all the columns you can get here. Okay, so this is how you can write codes as well. Okay, so let's see some more coding. Okay, okay. So suppose So whatever values you have created, whatever table you have created, I want to see the data for the same. Okay, so that you can write by saying display me the data. Okay, so in a data frame df1, in a new data frame, I am selecting a query spark.sql. So .sql is used to write a, why it is called by spark.sql mein you can write the SQL queries also. Select start from nyc.taxi.tree, and display is used to display whatever in this is present in this data frame. So you see it is displaying me all the data present in this data frame. Okay, so it is displaying me all the data present in this data frame. Okay, everything. Okay, so you are clear on this part. Next, let's see something more what we are having. Next, what I want to do, is like I want to create a query. If you remember, we have used this query before as well in our dedicated SQL pool as well. Suppose I want to select the sum and average of this data, and I want to save it in a different table, right? We did this operation with passenger count stats as well, right? In the dedicated SQL pool, okay, right? So we want to do this operation here as well, okay? So data frame equal to spark.sql, okay? So now whenever, this is one thing I need to show you. So whenever you need to write this type of big select clause, you need to enclose it with 3 braces, okay? If you don't, then see it will give you this error. If I am running, it is saying invalid system, perhaps you forgot a comma. You give, oh shit. Am I audible? I'm audible, na? Hello. Once you are done with this, you display the data, whatever. I took this data inside a data frame, okay, and display the data frame, and also df.write.save as table, means whatever the output is coming up okay here, you write this output for me in a table, okay. So if I execute this block of code, you will see, and if I refresh this table, you will see another table called passenger count stats created. So I'm already displayed df I have written. So it is displaying whatever was in the data frame or whatever is in this table. This was the output it is displaying. So like this way you can create blocks of codes, okay, here. And suppose you have written many block of codes over here, and as you want to create run all, so you can create run all at the same time to run all these codes, and you can create clear cell output to clear the output of the cell, and suppose cancel. So and from here, suppose you would have want to execute this, uh, you want to utilize the spark pool in this session, then you need to stop the session, right? It was giving you this error, right? So you can stop the session from here. So once you stop the session from here, then you can go and start writing code in that session, okay. Acha. And I guess as of
Yeah,
now,
one question.
tell me na.
How can you debug this script? What if there is something wrong and I want to see?
Debug you have to write, so that is why this data frame concept came into picture. So right, you have to debug using this data frame only. So you have to start seeing that what you picked up in this data frame, okay. So that is for that reason you have to use some other IDs. You cannot directly debug over here. You cannot directly debug over here. Okay.
So normally scripts will be quite lengthy, right? It not be just 2-3 lines.
Obviously. So in that case, you have to write. You have to use some ID to debug and everything. You cannot directly debug your codes over here. And here you can only debug. That's why these blocks are given, right? So if you have, you can have 1,000 lines of code, right? So but you always can add a block of code and you can write that small piece of code and execute, right? So that is why this structure has been maintained for this reason only. Though you can have 2,000 lines of code, but you will need a new line of code, right? Maybe you want to need to add something, so you will do that in a new line of code, right? So you can create a block of code and you can use everything to debug that. So that is why this feature has been given, to break down your codes into small pieces. Okay. So going forward also you can add parameters over here. Suppose by parameters I mean maybe in this pipeline you have created a pipeline and maybe you are using some loops and all, and you are passing some parameters which you want to feed in this code. Okay, so you can also do that. Okay, that will see in our upcoming sessions. Okay, how to, but you can do that thing. I'm just saying you can give us do the toggle parameter of toggle parameters was one of the options where it was. So you can add the parameters over here as well. Okay, toggle with parameters and everything. So you can do all these things together at the same place. So this is the things you can do in and this is how you can copy the data from the data lake storage, and you can create a lake database, and inside this lake database uh, you can create tables and everything, can load the data. So this is the analysis service. Okay, so what you need to do is like you need to create this analysis service. Okay, and once you create this analysis service, you go here, create analysis service. So I can show you how to create this analysis service, but Visual Studio I don't have in my machine. Okay, so I will tell you the procedure for the same. You all have Visual Studio in your machine?
Yeah.
Okay, so you have to give the server name, you have to give the subscription, you have to give the resource group. Okay, you have to give the location, which I already told before that you should always choose the location where all your resources are. Okay, then these are the query processing units, so you can select the minimum one as of now. Okay, so this administrator link, you have to get it. You have to add a server administrator from here. Who will be the server administrator? I am selecting mine from here. Select. Okay, and then you can tap on this create option to create it. Okay, so once you create this, you just create it. Okay, so once you create this, parallelly you have to install this what I say your Visual Studio, and get the uh, package over there installed. Okay, Azure Analysis Service package in the Visual Studio, and once you are done with that, then you can go and select the endpoint. Your endpoint I showed you, right? The endpoints are, you can get a, should I did create, I will show you. Okay. So this dedicated SQL pool endpoint you can give. Where is the, okay, you will get under Synapse. This SQL Server endpoint you have to give. Once you give this SQL endpoint, dedicated SQL endpoint over there, and you give your ID and password, okay, it will prompt you. Then it will get connected to your dedicated SQL pool, and there what you can do is like you can directly get your tables and all views over there. Then whatever operations you want to do, you can do those operations in your Visual Studio. Then in a Visual Studio in SSIS also, whenever you click on a project, you right click, you have an option called deploy, right? So once you click on that deploy, then it will ask that where you want to deploy. At that point of time, you will give the credentials for this analysis server, and you need to deploy it in the analysis services. So it will just ask you to sign in to your Azure, and then you will deploy it over here. And once you deploy it over here, then you can directly use it to connect to Power BI and get everything done. Okay. So when you'll be deploying it, it will be asking you the server name. Okay. So you will give the server name and all, and then it will connect to your analysis service. It will be deployed over here in the analysis service. And once it gets deployed in the analysis service, at that after that you can directly connect Power BI with the Azure Analysis Service to get your visualization done in the Power BI. So does that answer your question, Santosh?
So yeah, so basically you're saying it's only a deployment.
Basically what I am saying is Azure Analysis Service is a gateway. Okay, so you have your Azure Synapse, and so it is something like this. Azure Synapse is here where you are doing all your ETL activities. Okay, you might have Azure Data Factory, Azure ETL. Okay, you have a number of ETL services over here. So what happens is like the architecture is somehow, then just assume that for both of them, the gateway is Azure Analysis Service, where you deploy your models. Okay, and then comes your visualization, which is Power BI, Tableau, whatever. Okay, so this is the architecture, and in the left hand side you have your storages and all. And in the left hand side, if I just shift it a little like this, then here comes your storage account. The entire architecture is something like this. So you have your storage account and all here. Okay, from where you are taking everything to do all that Parquet files and all. Okay, and then you are doing using the ETL operations, and after doing the ETL operations, you are basically storing it in a dedicated SQL pool, DSP, and then on top of that you are using Azure Analysis Service to connect with your dedicated SQL pool, and then you are visualizing your data in Power BI. So this is the entire architectural data flow. So maybe if yeah, whenever what happens whenever any client comes in, you always need to give a presentation diagram, right? How your flow will be. So your flow goes like this. The first is storage account, then is your ETL things. From the ETL you get stored in data warehouse, it is called DSP, and from DSP you have to deploy it in Azure Analysis Service, which is nothing but a gateway. This gateway connects your uh, ETL with Power BI. Okay, so that is how the architecture is.
Now, if
Okay.
ETL, I mean, Data Factory and Synapse are doing the same thing, then
Same. I told you now the first difference on the first day, like Data Factory in Azure Data Factory, you don't get directly the Spark clusters and all. For that, you have to integrate Azure Databricks with Azure Data Factory. and you don't have a dedicated SQL pool or any warehouse in your data factory, you have to connect either with Azure SQL pool or you have to create a data warehouse separately. But in Synapse, you get it as a complete package altogether. So that's the difference. Okay.
Why would we use Databricks? I thought Databricks was used for some building only.
No. The Azure Databricks is primarily used for the PySpark coding, means the coding in different languages. Okay.
To execute those notebooks, you're saying.
Right, to execute those notebooks, right. So that is how the architecture goes. So in this analysis service, you have to get everything deployed over here so that you can go ahead and use this gateway and everything. Okay. So I don't have Visual Studio and all everything means for this. Okay, or else I would have shown you the entire flow or something like that. Okay, but what I can do is like I can suggest you a good video or something where everything is explained in a very detailed way. Okay, so you can refer to that video. Okay, I can give you the link for that video. Okay, where everything is detailed by one of the Microsoft person. Okay, where everything is mentioned in very detail. So you can have a watch of the 20 minutes video. You will get a clear idea of how you can use this Azure Analysis service to get it done. Okay. So does that help you?
So in your project, don't you use cubes? What is that you do with Synapse?
No. I don't use Q. I totally deal with the data engineering part, wherein in my project what I do is something like my client have a system called ClickUp. Okay, so what happens is like, so in that ClickUp, so basically they have their own datas. Okay, so basically they are using a third party application called ClickUp. So there they are that using that platform, like there is a platform called ServiceNow, na? So that wise there is a third party service called ClickUp, and they are using that ClickUp service to get all their data stored in the ClickUp. Okay, so from that ClickUp, what happens is like they are but there is a backflow, like in the ClickUp they have those data in the Excel and all, which is not good. So they want a proper visualization and a data engineering solution, and in the ClickUp the data is in the raw format. Okay, so what happens is like from the ClickUp using the .NET, one of my team member is there who does the .NET API coding. Okay, so using the .NET API coding, what he does is like he takes up the data from the ClickUp and post into Azure SQL. Okay, normal Azure SQL, not dedicated SQL pool, normal SQL, Azure SQL. Okay, so when I say normal Azure SQL, when you write here SQL, so there is something called Azure SQL. Okay, normal this Azure SQL. Okay, so basically this is an cloud SQL server, not an on-premise. So what he does is like he drops all the datas in that Azure SQL in that Azure SQL server. So from where I pick up all the datas. Okay, I using means I pick up all those datas and then I post those datas in the form of Parquet. Okay, into the data lake. Okay, so once I post those in the form of Parquet into the data lake, what I do is like then I use external tables. Okay, to refer to those Parquet files. Okay, so once the external tables are being created, post that what I do is like I consume the data from the external tables to my one-time load tables. Okay, from that operation is done using the pipeline. Okay, so after the one time load this part is done, I take care of the incremental loads So once that incremental load is done, I prepare my facts dimensions on top of that, and from the facts and dimensions, I have couple of views from which the reporting goes, which the clients access gain gain primary access to their reporting database. So I have developed a login for exclusively for the client, which the client uses for the respect, which they have access, where they have access to respective tables which they will require. So they use those tables for reporting in Tableau. So that's how the architecture is. Even for the last project for the Flipkart which I worked on is somewhere like the same. I'm just giving you an idea of how these things happen, or how the or different types of data engineering solutions are. Okay, so there also what happened was like Flipkart was having their offline stores, okay, all over India. Okay, so what they wanted is like they have, for the offline stores, they have primarily two products. One was grocery and one was fashion. Okay, so for the grocery and the fashion, what they wanted is like they wanted to see some KPIs in the Power BI dashboard. Okay, so for that, what they were doing is like they have n number of files, okay, in their source system. They were having their source system, okay, batch processed source system. So using the batch processing system, they were basically posting all of those. They were already having the data in some format. So and they were having their own pipelines, okay. So using the batch processing system, what they were doing is like they were posting everything in a storage account, okay. So but they were having a typical format of posting that in a storage account, wherein what was happening is like for a particular, so assume these six are the different they are different sources, okay. So for each of the source, okay, for each of the source, what was if you go inside, then every hour they were a folder gets created, and inside that folder whatever files they are sharing for that hour is present, okay. So once that is done, then in the next hour what was happening, another folder was getting created, and inside that folder there was files for the hour, for that hour, okay. So they were posting it in this format. So what I needed to do is like needed to design a solution wherein, so that I can pick up all the hourly files, okay, from their system, means whatever they were posting on an hourly basis, so that I can pick up all the files which came in an hour. And then what I used to do is like you opened up a PySpark notebook, okay. So those Parquet files were having in number of fields which we don't require. So we require specific columns, or specific metadatas to for loading our KPIs. So what we used to do, we used to retrieve those columns from those Parquet files. Some of the transformations were needed to be done on those columns. So we used to do that in PySpark. So once that is done, what we used to do is like we used to post the data. We then used to develop a pipeline. So that pipeline used to post the data to the dedicated SQL pool, and on the dedicated SQL pool, we used to develop stored procs to develop facts and dimensions and views. And finally, from the views, those Power BI reports used to get populated. Okay.
So,
So
like,
these
you
these
said
are the couple of structures. Tell me.
you said you receive Spark.
Right. I see part of it.
So on top of them, you used to write the PySpark code.
PySpark. Right. Okay. But the challenge was something like they were having different folders for every hour, okay, for different spaces, okay. So means for different sources, okay. So that was the challenge, like you need to design a solution wherein you need to pick up those hourly files and you have to make sure no files gets missed. So you have to design the pipeline in that way, okay. So using the get metadata activities, using the last modified dates and all. So
we used to get every details of those files inside the folder. We used to pick up those files, and then we used to store whatever file that came in 1 hour. We used to store in a container which we created for ourselves. Okay, so from that container we used to have a for each loop, and traversing that for each loop we used to get all the files one by one in the notebook, in the PySpark notebook, and then we have a specific code which used to run and then post the outputs into the dedicated SQL pool. So mostly the data engineering solutions are kind of like this only works, means mostly whatever you go do for your client, mostly will like roam around this only, left right, not more than that. Okay, mostly around 80% I can say, mostly whatever the requirement comes, so mostly it will this the specification or the requirement will roam around what I said. Okay, sometimes a client will be having a third party application, sometimes client will be having their own application, sometimes they will be having their own source systems, they will uh, post the data. Okay, so all in all, whatever be the thing, you always make sure that anyway you need to get the data in the storage account. Okay, because until and unless you don't get the data in the storage account, nothing can be done. Okay, so storage account is very must, and that is why storage account is so cheaper. Storage account is very cheap. Okay, so you have to get the data in the storage account, and there is another reason for getting the data in the storage account. So maybe for the ClickUp you could have asked me for this project what I am doing, you could have asked me, right? Or no, you are already getting the data in the Azure SQL, so why don't you directly do a copy data wherein you assign the source with as Azure SQL and destination as dedicated SQL? It will give me a very slow result, very slow result. Okay, because database to database, when you do the copy activity, then it's very slow, ultimate level slow. Okay, but when you do it from storage account or a data lake account to that place, to the dedicated SQL pool, then it's very fast. So you always have to make sure you have to get the data in the storage account, and then whatever you want to do you can do.
So when you want to you migrate from storage, data lake to dedicated SQL pool, you would use PySpark.
That depends on you. If you have a requirement where you don't need to use PySpark, then you can directly ingest the data from the storage account. You can write your stored procedures also. If you don't require, if you to do
So they are
any such
file
transform,
mandate. So we could use
any
as well use pipeline also, correct?
so you can use pipeline only na. Pipeline तो anyway you have to use, even if you are using a PySpark code notebook, तो pipeline के अंदर ही आपको देना पड़ेगा ना. You need to give that
No, like
drag and drop.
PySpark, I understand where should I utilize it to get the maximum out?
You
Only
should utilize it when you have a lot of
huge data involved.
transformations in your code.
Huge data involved? Is that okay?
Sorry?
When there is huge data, then we should use PySpark?
When there is huge data, when there is huge transformation.
How will you write transformation in PySpark? We have to write
Transformation, by transformation, what I mean to say is like you assume that you have 100 you have 200 columns, and out of which 100 in around 80 to 90 columns you have to write some of the logics to do. Maybe you have to extract the data from few of the columns, and then you have to do some aggregation on top of that. So, or maybe you have to convert some timestamp to something else. Okay, so maybe any transformations, like maybe you have to get that data and put it in a derived column or something like that. You have to create an, so maybe if those transformations are for around 70, 60, 70 columns, then you assume now if you do it in a pipeline, so you need to create n number of activities, right? So which is very difficult for you to monitor as well, right? So maybe tomorrow you leave the firm, next person comes up, then it will be very difficult, and that will not be a very good design, right? At that point of time you should go with the proper PySpark, and where you should go with uh, some PySpark, some notebook coding, and some pipe and some with pipeline activity, some with SQL coding. Okay, where you find that the way I did in the Flipkart project. Okay, the first round of uh, converting the timestamp and extracting the yeah, extracting the columns. Okay, so actually that was happening, like every row was containing around 200 around values of 200 or 1000 varchar things, so I need to take up till certain extent. Okay, so those type of thing I was doing in the PySpark. So after doing that, I was posting it in the one time load table. So after that, I was using I have written stored proc for the facts and dimensions, and for the stored procs I have used this stored proc activity. I showed you na copy using stored proc. So I have used this copy using stored proc activity to refer it in the pipeline. And here I was referring my stored procs one by one. So it was getting executed. So that you need to decide based on what is coming in. But overall, I will say when there is huge data, many transformations or many logics you need to put inside, so at that point of time you go with PySpark completely. If you have like uh, or if you find maybe sometimes what happens, like you have done using SQL only, right? You might have faced even in SSIS also, you have done something in SQL, and maybe that is taking a lot of time, right? Means that query is taking a lot of time, right? So you have faced it, right? That query is taking a lot of time. So maybe you go inside and find out that you have done couple of inner joins which was not necessary. You could have done a left join, right, to avoid that. So that is the improvisation you are doing, right? So here also, if you find that it's taking a lot of time, then at that point of time maybe you have to partition it. So whatever is taking more time, you do that part in PySpark and the rest part in SQL. Okay. And the pipeline is nothing but here it is just for the flow, right? Like what will happen after what, it is just a flow. It is not like what you do in SSIS, that for every aggregate you don't see, like for aggregate or something you don't have a drag and drop, right? You can't find a drag and drop for aggregate joins, you can't find anything, right? So it is just for operation. It is like you can do respective operations over here, but not you cannot write means you don't have functions in means inbuilt functions declared over here. Okay, so for that you have something called data flow, okay, which you can use. Okay, so I will give you a glimpse of that today. Okay, so which is kinda same like SSIS, you can relate much. Okay, so which we will cover today. Okay, so but before that, okay, let's close this. Okay, let's close this. Let's publish the list.
And when will you use external tables? That concept. I mean, when will actually that be you utilize, or when should
you
we
can
have
use you can
thought of?
use external tables are for polybase design, I told you, right? So you
Mhm.
can use in two ways, right? Either you can enable if you are using a copy data activity. Okay, so you can use a copy data activity and enable staging over there to do the polybase design. Okay, you are having, right, copy comment polybase. Okay, so you can do using that also. Okay, or suppose if you have like 10, if you have like 10 sources, okay, which you need to copy, you can drag and drop 10 copy data files. Okay, assume you have 100 sources. Okay, you cannot, it's not possible for you to drag and drop for 100, right? It's tedious, means every time anything fails you have to scroll, means you have to scroll and see like 100 like this and this and this, which is not possible, right? At that point of time you go ahead, create an external table, um, and then you point the reference of an external table to the data stored in data lake, to the Parquet file stored in data lake, and then you load the data from the external table to the dedicated SQL pool. This is the real-time use case.
Sorry, I didn't get
Got
you.
it?
So you said
Sorry.
you load data from Parquet files into external table and then to dedicated pool.
Right. you can do that when you have a lot, around 100 sources you wanna configure. So if you want to do for 100 sources, like you have a you might want to have 100 copy data activities, right? Okay.
Hmm.
Or maybe at that point of time, what you will do is like you will have a for each loop, and then you will point a copy data. Okay, then you will do it, right? So then
Hmm.
also for each is also, when you are looping something, it is also very slow.
And moreover, when you are loading 100, you don't need to have 100 staging tables also when you use external.
Right, you don't need to have 100 string tables
So
when you use
that
external.
that is the major uh,
Right,
advantage using external tables, right?
right. Okay, so what we'll do is like uh, we'll have one more use case today. There was only one left from the iteration, which was switch. Okay, so uh, so like what is, switch statement, right? You specify a certain condition. If that holds true, a case statement will execute itself. If it doesn't hold true, that another case statement will execute itself, right? That's what a switch is all about, right? So what we want to do is like we want to get a file from the source. Okay, and we want to get a file from the source, and then what we'll do is like we'll specify two statements. Okay, what you do in a case statement, we'll specify two case statements. For whichever statement my condition holds true, the flow will pass into that statement, and after going inside that statement, it will, whatever is written inside that, or whatever is present inside that space, that part will get executed. Okay, so that's what we'll do inside a switch statement. So first of all, what I'm doing is like I'm creating a pipeline parameter, giving folder name, giving the default value as output 1. Okay, so what I'm trying to do, like I will give two cases. If the output 1 is holds true, then it will copy my files to the output 1 folder. If the output 2 holds true, if the output 2, I will have two cases. One is output 1 case, another is output 2 case. If the output 1 case holds true, then it will move my files to output 1 folder. If the output 2 case holds true, then it will move my folders to output 2 folder. Okay, so folder name I have given. Then I'm dragging and dropping a switch statement. Okay, so name description you already know. Okay, user properties also you already know. So the only thing is activities. Okay, so in the activities part, what I need to do is like I need to add a dynamic content over here, right? So what dynamic content I need to add? Basically, I need to pass my whatever I have passed in this parameters, in the pipeline parameters, I need to pass that inside the switch statement, right? So I'm just passing it pipeline.parameters.folder name. You are quite accustomed with this code, okay, as of now. Next, what will happen is like whenever I will press on the debug, it will take this parameter, pipeline parameter. It will see that it has got a parameter called folder name with a default value called output 1. Then it will see that this switch activity is present in this space, okay, in this console space. Then it will see that the expression is holding pipeline.parameters.folder name. So basically it will, from the pipeline parameters folder name parameter, it will take up its value. What was its value? Its value was output 1. So at that point of time, it will try to find if it could find any case with output 1. Okay, so maybe here I am giving a case wherein I am saying this case as output 1. Okay, sorry, what happened? So I'm giving this case as output 1. Okay, so output 1, if so, yeah, so this condition will hold true, that it matches this case, then it will go inside this. Okay, so what I'm doing is like I'm doing a copy data activity over here. If this condition holds true,
you copy the file from one of my locations. You copy the file from the input folder, this file, we have done it previously, Synapse training input folder, this file, and you paste and you drop it in a location. Okay, so what is that location going to be? You drop it in a location, so drop it in a folder. Okay, so what that folder name is going to be? That folder name is going to be, we have to parameterize it, right? Because we have parameterized it in the pipeline parameters. We have parameterized this as output 1, right? So inside this we have to parameterize this. So so if I go in first, if I go inside the sync data set, you already know I have discussed this, like whenever you need to parameterize a folder name, how you can do that inside a integrated data set. If you go to parameters, click on this new, add this folder name string, and then come back to connection. Here you need to specify like this @dataset.folder name and click OK. So this integrated dataset will get parameterized. So once you parameterize this integrated dataset, then automatically here also this folder name will come up, and you need to add a dynamic content over here. So this dynamic content will also be my folder name, pipeline.parameter.folder name. Basically I'm saying that please copy my file inside the output 1 folder. Okay, so that is what I'm saying over here. Okay, so that is my statement. So that is my output 1 statement, and assume that there is another case I am giving, and I am saying that maybe this is output 2. Okay, if I would have given in the pipeline parameter the value as output 2, then what operation it will perform? So let's go inside and say, take a copy data activity and say that configure the source dataset with the same binary one integrated dataset, configure the sync with the same for each activity, and add the dynamic content of the folder name here. So what will happen is, like, I will go back and elaborate it one more time. So first what will happen is, like, I will elaborate it one more time for you is, first what I have done is, like, I have created a folder name. I have created a folder name parameter of type string, and the value is I have passed for the folder name is output 1. It means if I whatever value I pass this, it will try to match with my case statement. Okay, so it will find here output 1 as the value, then it will go inside switch statement. It will inside the expression I am passing that folder name value only. So here till here it will get the value as output 1. Now it will try to see these are the case statement it is having. So it will try to find which case statement is actually meeting, which actually matching with the pipeline parameter value. It will find that this case statement is matching with the pipeline parameter value. Then it will go inside this case statement, and then inside this copy data activity, it will take the file from whatever source has been given over here, and it will drop the file to whatever folder name has been given. So the folder name was directly passed from the pipeline parameter as output 1, so it will directly drop the file inside the output 1 folder. Before I execute it, do you have any doubts? No, right? Okay, so I will just execute this. So the expectation it will drop the this output. It will drop a file called sp dynamic text inside this output 1 folder. This is the expectation. So let's go ahead and check the output 1 folder. So you see it has dropped a file at 9:19:39 seconds. sp dynamic space dot 10.txt. Okay, so if I would have passed in the pipeline if I would have passed output 2 in the pipeline parameter, then it would have dropped the file inside the output 2 folder. Okay, just for your reference, I'm running it and showing it to you. So let's go ahead and check the output 2 folder. So you see it has been passed, okay, to output 2 folder. Okay, so this was the expectation. Okay, so that's all about, that's how you can use uh, uh, that's how you can use this. No, I'm just deleting this file. So that switch activity, and also there was one more case called default. What is default? Default means when none of the condition holds true at that point of time, default condition runs in a switch case statement, right? So if you want something to execute as default, then you can go inside default and give any condition. Okay, so that's on you. Okay, so that's all for this switch part. So let's move ahead. The next is the next is a very good thing we want to do. I think Santosh requested me this yesterday. We did this get metadata activity, na? So you wanted to have a CD type 1 thing, right? Wherein fetching the last date and all, you wanted to do that, right? So let's do that part also. So let's do that. Okay. So what is our goal over here? So our goal over here is we want to basically first what we'll go ahead is we'll create a table. Okay, let's go ahead and log into our database. Okay, so I'm creating a table. My screen and voice both are audible and visible, right?
Anyone?
Yes.
Okay. So I'm creating a table of let us give the name instead of this. Let's remove this. Remove this. Okay. Okay. So let's name it as source and execution start date. Okay, suits me. Okay, so let's go ahead and create this table. So this table got created, right? So I have a control table over here. Okay, wherein I am having two fields. One is called source and one is called execution start date. Okay, so maybe the source refers to basically which source I'm working with. It could be employee source or it could be any source system from where your data is coming. When you are trying to do a SCD type 1 or something, you need to get the execution date, right? So you need to store it in a control table, right? Next, what I'm doing is like I'm writing an insert into statement. Table, my fields are source, comma, execution start date. Okay, execution start date. Okay, so next I'm passing the values. Maybe I'm passing employee as the source. Okay, and I'm passing a date. What is the date for 2023? Next is what is the default format here? Let's check once. Okay, I'm passing a date of tomorrow. Okay, yesterday, that I have executed something yesterday. Okay, uh, okay, okay, so let's insert this record. Okay, so okay, next is do we having that property? No, that's not it. Fine. Okay, okay. So next is like we are creating a small stored proc. Okay, which will basically fetch our DVR, which will basically fetch our last date, last load date. Okay, um, as you can also directly query it also. Select. I am having a single row over here, so I'm just selecting select execution start date. If you are having multiple rows, then you can select max of execution start date from table name. Okay,
Okay, so let's create this proc. It will get us the execution start date. Okay, next. Okay, next is like create another POC which will require to once the load is done, we also want to update it, right, with the newly loaded timestamp. We also need to update it, right? So dbo dot, let us say usp underscore update last execution date. Okay. And okay, and maybe I'm passing this execution date because this execution date I can pass. Okay, execution date, the date execution start date. I need to give. Okay, so date, or directly you could do from a query as well. Just showing you. Copy. That. You can pass it like this. Okay, update dbo set execution start date equal to at the rate execution date. For me there is one entry, no need to write where clause. Okay, so at the rate execution started as the date time I have given. Fine, as update. Okay, fine. Okay, fine. Let's run this. Okay, done. Okay, ठीक है. Next, let's go ahead and create a pipeline. Okay, the pipeline is already created. Okay, so but before that, we need to create I'm creating a folder. Sorry, I'm adding a folder scd. Adding a folder. I'm uploading the file. Okay, here from my system, that nyc file. Uploading it. So it has been uploaded. Okay, next next what I need to do is like I need to go to my pipeline. Let's drag and drop a get metadata activity. Okay, so these are the same things you already know. User properties also you know. Settings. Let's create a data set. Okay, Azure Data Lake Storage Gen 2. This is our Parquet file. Let's name it SCD execution. Okay, SCD execution. Azure Data Lake Storage Training. Let's select the file. Where is the file located? The file is located in SCD. Okay, so we have said we have given the file. Next, what I want I have field list. I said new. I want the last modified, right? Last modified time or date, right? And next, what activity I require? I don't need to do anything. Okay, next I am dragging and dropping a lookup activity. Okay, going to settings, training database. Okay, I have selected. Stored procedure is there, right? Which will return me the USP last load date, right? This was my stored procedure name, right? There is no parameters. Okay, and I'm returning the first row only. Okay, there's only one row. So first go ahead and let's debug it. Okay, and see what is the output we get. So the output I am getting for the first row is 2023-6/12. That is yesterday's date. And the lookup, the output I am getting is, sorry, get metadata, the output I am getting is 2023-6/13. That is today's date. So lookup is giving me yesterday's date and get metadata is giving me today's date, right? So it means that my pipeline will run, means whenever my last modified date is greater than my last execution date, then only I will perform any copy activity, right? Means whenever my last modified date will be greater than my last execution date, then only I will load the data from the source to the destination, right? So if my last modified date is less than my last execution date, then I should not, right? So you got it, right? The concept. You got the concept, right?
Yeah, yes, Allah.
Okay. So next, what I need to do is like I'm dragging a if condition over here. Okay. So, and I am attaching the output of both of them. That is, okay. So I am giving both of their output in the if condition. Okay. So what I am saying is like pass the output of both of them inside the if, right? So once I pass the output of the both of them inside the if, what will happen is like then what I need to do is like I need to go to the if condition, right? So general you already know, user properties also you already know.
activities. Let's do it. So here I have to give some expression, right? So what is the expression I need to? Basically in the expression I need to pass the value of the metadata and the lookup. Okay. And I need to say that if in the if condition I need to say that if my last modified date is greater than my last execution date, then kindly perform the activity which corresponds to true. Okay. Add dynamic content here. So actually there are functions I will show you. So there is a function called greater or equals. Okay. So I'm clicking on this function. Okay. Then what I'm doing is like uh, next what I will go to the activity outputs, right? So get metadata activity output I require, right? So here activity get metadata 1 I've written dot output dot last modified I need, right? I need the last modified one, right? And I want to do it with the lookup, right? Lookup activity first row, right? So activity name is lookup one dot output dot first row dot column name, which is execution start date, right? Okay, so it's done. Okay, simple. So I'm checking if my last modified is greater than my execution start date. Okay, I'm pressing OK. So also you can see the name of the columns here as well. Last modified. This is case sensitive. Okay, so make sure to give it like this only. Okay, the next one is lookup one execution start date. You can give like this. You whatever is written over there like that. So next, if this condition holds true, I need to go inside the true activity and maybe I want to copy the data from the source, from this source to my destination. Sorry, from the source to my destination. What is my destination? So maybe I want to copy the data in this SQL pool. Okay, I need to copy the data here. Okay, I'm selecting polyway, so you can select polyway or copy command both. Okay, so let's go with the copy command. Okay, so I want to it here. Okay, so I think I have a table here already with the same name, which is NYC tracks. So also I could have done this also. I think there was a stored proc I have already done right now. dbo.copy data. Okay. Okay, chalo. Okay, fine. Then it is done. Sync dataset is already passed. Okay. And copy command is also passed. Okay. Table option. I'm giving auto create table. Okay. Auto create table. Okay. Okay. If this condition holds true, then it will execute this. And let's see if
that works. Copy data is done. It is done. Let's go ahead. There are already 4 tables, 5 tables, sorry. So NYC, taxi trips. This is where I give it, right? Okay. So that's how you can do the operations when you are doing using when you want to do the SCD part. So you can, that's how you can compare this and pass the value inside a if condition to perform certain operations. Okay. Any doubts? Any doubts from anyone? Okay. Okay, I'll just publish this. Okay. Okay. Next is one more thing we need to want to do, that is like something called data flow. Okay, so we'll have a quick look into that. Okay, so what is data flow? Where, okay, so I told you, right, something called data flow is present over here in this. If I create a pipeline, something called data flow is present in this, wherein you can do operations like SSIS and all. Means you can do the transformation here. All you have inbuilt functions over here to do. So that you can do, and how you can do, let's see it. So for that, first what you need to do is that you need to go to the data tab. Sorry, you need to go to the develop tab. Okay, click on this develop tab, click on this plus button, click on this data flow. So when you click on this data flow, your data flow debug will be off. I have turned it today morning only. So you have to click here to turn it on. So once you turn it, when you will turn it on, so it will ask you for how many hours you want to turn it on. 1, 2, 4. So I have given 4 hours. That's why it is still on. Okay. So after 4 hours, it will automatically shut itself. Okay. So what we can do here is something like, first what you need to do is like inside the data flow, it's same like what you do in SSIS. You first need to add a source. Okay, you click on the source, this part comes up. Next what you need to do, you need to add a data set, right? So let us add one data set. So go to select. I just created something called SDC execution, right? So I'm pointing the same over there. Okay, and you can test the connection also. Connection successful. Then you can view the options also. Let's go to data preview, click on refresh, and let's wait for some time.
You can see your data here as well. So see, your data is here in the blink of an eye. Okay. So the next thing you need to do is like you want to perform some operation on top of this, right? So I will show you some small operation today. Okay. So here you can get a glimpse of the data. So maybe what operation we can do is like maybe we can check for the trip distance. We can do a derived column over here and we can check like if the trip distance is greater than or equal to 1, then return true or else return false. Okay, so we can do that check. So for that you need to click on this plus. You need to click on this plus. What was the name of the column we decided? Name of the column was trip distance. Okay, you need to click on this plus. So once you click on this plus, you will see you will get n number of options here: join, conditional split, exist. So if you have multiple sources over here, you can even join them. Okay, by doing this. Okay, then you have conditional split. On the basis of condition you can split it: exist, union, lookup, derived column, select, surrogate, aggregate key, surrogate key, pivot, unpivot, window functions, rank, eternal, cast, flatten if you want to do some formatting, row modifier if you want to do. Okay, all of this, everything is present over here. Whatever operation you want to do, like, so I am doing a derived column operation. I'm clicking on this derived column. So a derived column activity gets opened up. So what is inside this activity? So here inside the activity you have the output stream name. Okay, incoming stream is mentioned over here. Then you need a column. Maybe I'm giving as output. Okay, and now next is you have to give an expression. Obviously you need to give an expression builder, right, to perform like which column and what thing we want to do. Once you click on this expression, a new tab gets open wherein you have an option to select from the functions like what operation you want to do on the derived column. You have n number of functions listed here. Okay, array, ASCII, at, between, everything. Every sort of function is listed: coalesce, character, column names, compare, concat, contents. Everything what you need more or less is listed over here. So you can directly use it from here. Okay. So for our case, we are using greater or equal. Greater. Okay. So if it is now, if you hover on this, it will say greater expects minimum two number of parameters, means at least it expects 2 parameter. Okay. So you have to give this 2 parameter. It will, if you hover on it, it will show you even. Okay. And if you hover here, it will show you that what it returns as well. Comparison greater operator, example greater 12 24, then it is false. So 12 is the source and 24 is the what value you want to search when the what value you want to see for which is greater than. So obviously 24 is yeah, so that is what you need to pass. Okay, so if you go inside, next if you go inside the input schema and trip distance, right, we decided trip distance. Okay, comma 1. Okay, so I am saying that give me all the trip distance miles which are greater than 1. Okay, so if I click on save and if I refresh here for the data preview,
It is fetching the data for me. So you see it is giving me here all the trip miles which are greater than 1. Okay. So I click on save and finish. Okay. Next I need to add a sink as well, right? So let's click and go down to add a sink where I need to drop it. Okay. So for the sink, you need to give a sink also. So here is one thing, there is a limitation that I should tell you. Like you cannot directly drop it in a data dedicated SQL pool. You have to go for Azure SQL database and all. So these are the things which is present over here. These are not present. Okay, these are under preview as of now. Whatever you can see, you cannot select these things. Normal SQL server, REST, these are the things. Whatever SQL database, data lake, those everything is present. Okay, so I'm dropping this Spark file in a data lake. Okay, so for me, I will not create it since I have already created one just some time back. Okay, so maybe I would like to drop it inside NYC trip taxi. Okay, so if I open this, so it's so it I'm dropping it inside Synapse and output one folder. Okay, so if I do it, okay, I'm testing the connection as well. Okay, so my flow is ready. Okay, so after you create the flow, you have to publish it first because you directly cannot run the flow from here. You have to refer this flow in a pipeline only. Okay, publish completed. Let's go to pipelines. Let's create a new pipeline and let's drag and drop this data flow over here. Okay, go to settings, select the data flow. Our data flow was data flow 2. Compute size, you can select small, medium. We are selecting small as of now. Loggings and you all select. Staging, if you want to drop in Azure SQL database, you can select a staging to perform the polybase operation. Okay, so that you can do. And parameters, it is showing as 1. It is a glitch from their end, so no parameters are there. Okay, it's a glitch from their end. Okay, so if I now debug it, then it should load the data from my source to destination with a derived column named output. So let's, do you have any doubts? This is something new we did. It is succeeded. So let's go ahead and check. We have dropped it inside the output folder, I guess. Okay, you see 9:59:31 seconds, a file got created over here. So let's go ahead and check that file. We know we can directly query a Parquet file. Output 1, maybe I will just go back and refresh it once. Okay, select top 100 rows. I'm running it. So by default it gives first 5,000 rows. Okay, So I've connected to the serverless SQL pool for running it. So primarily this is when you use serverless SQL pool when you are doing the development and you want to check on certain files and all. So at that point of time, you mostly use this serverless SQL pool. Okay. So this is primarily for your development only. So if I go, see there is a column called output, whereas can shift this here, it doesn't come like that, na? In like SQL. Okay. So you see true, true, false, false. So I said greater than 1, right? So for first two values, it's true. For second two values, it false because those are not greater than 1. It's absolutely equal to 1. That's why true, true, false, false. Okay. So that's how you can achieve this operation using a data flow task. Okay.
So you are saying only to view data will use SQL Server School?
Mostly in SQL Server SQL, you can perform two objectives, right? One was like create external tables you can create over here and store data. You cannot serverless, so don't support you to create physical tables, right? You can
Hmm.
only create external tables and you can write these select clauses. So when you will write these select clauses, normal select clauses won't you can only write a select clause when something is stored somewhere, right? So you cannot write a select clause on a physical table here. You can only write a select clause on something which is stored in external table or something you have a file like something which is stored and that you want to query. So then only you can use serverless SQL pool, right? So that's why I said like it's mostly for the developers. So to watch and have a look. It's not for the business. I did an operation of SCD wherein basically in SCD type 1 what you do, you basically check what is the max timestamp you are having, and on top of then you check it, then you get the data from the source, then you load it, right? You basically update it. Okay. So for that you just need another SQL stored proc to update your statement. That's it. You you will write the code in SQL only, normal SQL. We can do that, not an issue, but maybe we can take this for the last day. Means we have couple of exercises to do more, so maybe we can take this up for the last day on the doubt clearing session day. Okay, where we can do that SCD type 1 or something. Okay, so nothing more na, you will just you are already doing the last modified date and uh, what I say, last load execution date. If you are checking it, if it is greater, then you are loading the data. After loading the during loading, what you do? You basically write SQL queries that if that data is already present, then you update it, and if that data is not present, then you insert it. If the data is already present, then you update it, and if data is not present, then you insert it. And for the SCD type 2, you maintain the history with a row expression timestamp column, right? In the row expression. So all these you will have to do in SQL only. So just you have to use the stored proc activity to refer your SQL code, and that's it. Code so you have to write either in SQL or PySpark. There is no other language. Means you can write in .NET as well, but mostly people do SQL and all. So if you are using SCD type 1, that's a database thing. So you can write SQL codes for that, and you can reference that inside a stored proc to achieve the same.
With our first question. So the first question says, what is Azure Data Factory and why is it used? So guys, Azure Data Factory or ADF is a cloud-based ETL. ETL is nothing but extract, transform, and load, an ELT service that helps you move and transform data from different sources to destinations. So it is widely used for building data pipelines that integrate data from on-premises databases, SaaS applications, and cloud storage. Just to give you an example, so you can use Azure Data Factory to pull sales data from an on-premise SQL server and load it into Azure Synapse Analytics for reporting purpose. So basically, Azure Data Factory is a cost-effective and serverless. That means you don't need to manage any infrastructure. The next question is, what are the different types of integration runtimes in Azure Data Factory? So guys, there are basically three types of integration runtimes or IR in Azure Data Factory. And as you can see on the screen that they are Azure IR, self-hosted IR and Azure SSIS IR. So if we talk about Azure IR, so basically this is used for data movement within the Azure infrastructure. If you talk about the self-hosted IR, so they are used to connect on-premises data sources securely. And last but not the least, the Azure SSIS IR, it's used to run the SSIS packages in Azure. For example, if you want to copy the data from an on-premise SQL server to Azure Blob storage, so here you would use a self-hosted IR. The next question is, explain a real-time scenario where you used Azure Data Lake. So let's suppose there's a retail company storing daily transactions from the POS systems across 1000 stores. Now these retail company can use Azure Data Lake to centralize the raw data. Over here, the data is ingested into Data Lake Gen 2, either in the JSON or the CSV format, and then it is transformed with Databricks before being consumed by the Power BI for dashboards. So over here, the data lake acts as a single source of truth for structured and unstructured data. So guys, this scenario was just an example. If you're actually asked these kind of questions like explain a real-time scenario, so over there you have to like if you have experience in working, like there's a project or these kind of things, so even those examples are relevant for these particular kind of questions. Okay, so now let's move ahead and discuss the next question. So the next question says, what are the main differences between Azure Blob Storage and Data Lake Storage Gen 2? So guys, both are these storage services, but Data Lake Storage Gen 2 is built on top of the Blob Storage with additional capabilities. So it supports hierarchical namespace such as folders and directories, and which makes it easier for big data analytics. If you talk about the blob storage, so it is good for general purpose file storage, while Data Lake Gen 2 is better for the advanced analytics. For example, let's consider that there's a company and this company might store images in the blob storage, but on the other hand, large log files are stored for Spark processing in the Data Lake Gen 2. So guys, let's move to the next question. So in a real-time project, how do you handle incremental data loads? So incremental loads means only loading new or changed data instead of reloading everything. So in Azure Data Factory, this can be achieved using the watermark columns like the last modified date. For example, if you are moving the order data daily, so you can filter only records with last modified date and the last run date. So basically, this procedure saves the cost and improves the pipeline performance. The next question is, what is Polybase in Azure Synapse Analytics? So Polybase is a technology that allows Synapse to query data directly from external sources like the blob storage or the data lake without importing it first. For example, you can query a CSV file in the data lake using a TSQL as if it were a database table. So this reduces the data movement and speeds up the analysis. The next question is, so guys, in the actual interview as well, there will be, apart from the theory questions, there will be a lot of scenario-based questions as well. So by asking the scenario-based questions, the interviewer wants to test how much of the practical knowledge and skills do you have related to Azure Data Engineering. So guys, this particular question is a scenario-based question, and the question says, how would you design a pipeline that loads data every hour from the multiple APIs into Azure SQL database? So first and foremost, what you would do is you would create an Azure Data Factory pipeline with a copy activity that calls the REST APIs every hour using a trigger. So the raw API response would then be stored into a data lake for audit and then transformed using the mapping data flows before being loaded into Azure SQL database. So this ensures reliability and reusability in case of APIs fail or the schema changes. The next question is, what are the linked services in Azure Data Factory? So linked services define the connection to external data sources such as the databases, APIs, or the storage accounts. So think of them like the connection strings. For example, if your pipeline needs to move data from the Azure Blob storage to SQL Server, for that you would create two linked services. So one for the Blob and the other one for the SQL Server. The next question is, how do you handle schema drift in a data pipeline? So guys, schema drift happens when the source data schema changes unexpectedly. So in Azure Data Factory, what you can do is you can use mapping data flows with schema drift enabled so that the new columns are handled automatically. For example, if a new column discount is added in the sales dataset, the pipeline will still work without breaking. The next question is, what is the difference between Azure Synapse Analytics and Azure SQL Database? So guys, Azure SQL Database is designed for the transactional workloads like the OLTP, while Synapse Analytics is for the analytical workloads like OLAP. SQL Database is used for the applications with frequent inserts or updates, whereas Synapse is optimized for running complex queries on large volumes of data. For example, an e-commerce website uses SQL database for customer orders, but Synapse for analyzing the purchase trends. So guys, with this, we have covered the beginner level questions or the questions that were meant for the freshers. And now the next 10 questions are for the intermediate people, like those people who have at least 2 to 3 years of experience working in the domain of Azure Data Engineering. So now let's move to the next question. So the next question says, how would you migrate an on-premise SQL Server data to Azure in near real time? So guys, first and foremost, what you need to do is you need to start with an initial bulk load using the Azure Data Factory. And over here, you will be using the self-hosted IR or Azure Database Migration Service to seed the target in Azure, ensuring schema compatibility and indexes are in place. For near real-time changes, what you can do is you can enable change data capture or CDC on the source SQL server to capture the inserts, updates, or deletes, and then stream those changes to Azure using the technologies like the transactional replication, change tracking, plus ADF incremental pipelines. Or you can also use a log-based connector that pushes event hubs or Kafka. On the Azure side, what you can do is you can use a lightweight consumer to apply the CDC events or the upserts into Azure SQL or a Delta table. Over here, what you need to do is you need to also ensure idempotency so that the duplicate events do not corrupt the targets. You can also consider latency, ordering, and transactional boundaries. Some business scenarios require strict ordering, which affect the architecture choices. For example, a CRM system might use the transactional replication to synchronize critical customer records into the Azure SQL for near real-time reporting, while the large-scale events streams may use the event hubs plus Databricks for eventual consistency. The next question is, explain how Azure Databricks fits into a data engineering architecture. So guys, Azure Databricks is a managed Spark platform that excels at a large-scale data processing, ETL, interactive analytics, and machine learning. So it is commonly used as the heavy lift compute layer in the modern data platforms. Databricks integrates tightly with the ADLS Gen 2, Delta Lake, and a variety of ingestion sources, enabling efficient transformation, streaming processing, and model training within notebooks or scheduled jobs. So the common roles for Azure Databricks include cleansing and aggregating raw data into curated Delta tables, building feature pipelines for machine learning, and performing ad hoc analytics that require distributed compute. Databricks supports Delta Lake, which brings ACID transactions, time travels, and efficient upserts to data lakes critical for production grade pipelines. For example, raw clickstream logs into ADLS are read into Databricks, deduplicated, enriched with reference data, and returned into partitioned Delta tables for reporting and modeling. The next question is, what are the pipelines datasets, and activities in Azure Data Factory. So guys, you must be seeing a lot of questions around the Azure Data Factory concept. And guys, believe me, if you are into Azure Data Engineering role, Azure Data Factory is a very crucial topic. So that is the reason you will see a lot of questions around this particular topic. So over here, you have to explain what are pipelines, datasets, and activities in Azure Data Factory. So if you talk about a pipeline, so pipeline is a top-level workflow container that groups related activities to implement an end-to-end data integration scenario. So basically, the pipelines provide parameters, control flow, and retry policies. If you talk about dataset, so this describes the structure and the location of a data, like the table, file path, or a folder pattern, and acts as a pointer used by the activities. Basically, datasets do not contain the data themselves. Now, if you talk about the activities, so an activity is a single action inside a pipeline, and it basically represents a unit of work. Activities can be composed with the control flow, constructs such as if condition, for each, wait, and execute pipeline to build complex orchestrations. The next question is, let's suppose there's a scenario, and in this particular scenario, your pipeline failed due to a timeout error while connecting to a SQL database. So how do you troubleshoot this particular situation? So first and foremost, what you can do is you can begin by inspecting the Azure Data Factory activity run details and diagnostics logs to capture the exact error message, stack trace, and the timestamp. So this narrows down whether it's a transient network glitch, authentication, or a resource saturation. The next step is to check the networking. So over here, you have to ensure that the firewall rules and VNet service endpoints are configured correctly. And you also have to verify the integration runtime being used has the network access to the database. So if at all you are using a self-hosted IR, you need to confirm that the agent service is running and healthy. On the database side, you have to check the resource metrics to ensure that the SQL is not overloaded, and the long running transactions or blocking could also cause the timeouts. Next, you have to tune the connection and command timeout settings in the linked service if appropriate, and implement the retry policies in your pipeline to handle the transient failures. So these are the some of the steps that you can follow in order to troubleshoot this particular kind of situations. The next question is, how do you optimize performance in Azure Synapse Analytics? So performance tuning in Synapse starts with choosing the right distribution strategy, hash distribution for large join keys, and replicated tables for small dimension tables to avoid shuffles, and round robin when no clear key exists. Apart from that, what you can do is you can also use column store indexes for large fact tables to improve the IO efficiency on analytics queries, and ensure proper partitioning to allow the partition elimination for date ranged queries. Apart from that, you can also monitor the query plans and statistics. Stale statistics can cause the poor plans, so keep them updated and consider the result set caching or materialized views for frequent run aggregations. Next, you can also tune parallelism and resource allocations so that you are able to scale your data warehouse units during heavy loads, and adopt the workload management by isolating the heavy ETL into separate tools. The next question is, how do you handle slowly changing dimensions or the SCD in Azure Data Factory? So slowly changing dimensions or the SCD track changes in dimension attributes over time. So the most common approaches are type 1 and type 2 and type 3. In Azure Data Factory, mapping data flow can implement SCD patterns by comparing the incoming records to the target keys, generating inserts for new members, and optionally closing the existing records for type 2, and by setting an end date or is current flag. So for big data sets, what you can do is you can use an efficient upsert or merge patterns. For example, Databricks merge into Delta tables so that you can perform the record level updates without rewriting the large tables. So for type 2, the typical steps are, first you have to detect the changes, then set the previous record's end date and insert the new version with a start date, and maintain the surrogate key for joins as well. The next question is, what is Azure Stream Analytics and where would you use it? So Azure Stream Analytics or ASA is a fully managed real-time analytics engine designed to process high throughput streaming data with SQL-like language for windowing, aggregation, and pattern detection. It ingests events from event hubs, IoT hubs, or blob storage and can output to multiple sinks like Power BI, SQL database, or Azure functions for downstream actions. ASA is ideal when you need low latency processing with simple to moderately complex queries. Examples include real-time telemetry monitoring, anomaly detection, or live dashboards. ASA supports sliding, tumbling, and hopping window constructs, which are useful for computing rolling aggregates like per minute averages, and it can integrate with ML models for scoring. Next question is, how would you secure sensitive data like credit card numbers in Azure? So securing sensitive data requires layered controls. Over here, you need to encrypt data at rest and in transit, restrict access via identities and network controls, and apply field level protections. For this purpose, what you can do is you can use Azure Key Vault to manage the keys and secrets, enable transparent data encryption or TDE for databases, and consider always encrypted or column level encryption for highly sensitive fields, so even DBAs cannot read the raw values. Apart from that, what you can do is you can implement dynamic data masking or create a masked views for reporting the users so that downstream systems can see only partial values, and use role-based access control and managed identities to ensure the least privileged access for services and users. Apart from this, network controls like private endpoints, service endpoints, and firewall rules reduce the exposure, and audit logs should be enabled to track the access and modifications for compliance. The next question is, what are the delta tables in Databricks and why they are useful? So basically, delta tables are transactional storage layer built on top of file formats that add the transaction log, schema, enforcement or evolution, ACID guarantees, and time travel for data stored in data lakes. So the core benefit is that you can reliably perform inserts, updates, and merge operations at the scale without locking or risking the inconsistent reads. So this makes production ETL and ML pipelines far more robust. So Delta's transaction log enables the version queries to inspect the historical data state and supports the compaction and optimization operations to improve the query performance. The next question is, let's suppose there's a scenario, and in this particular scenario, the interviewer wants to understand how would you implement data partitioning in Azure Data Lake for better performance. So over here, what you can do is you can use partitioning. Basically, partitioning is organizing files into folder paths based on commonly filtered keys. Over here, you need to choose partition columns that align with the query patterns like the date ranges that are most common, and avoid overly fine-grained partitions that create many small files because that causes the metadata overhead and increased task scheduling costs. Apart from that, you can combine partitioning with appropriate file sizes like few hundred MBs to a few GB per file depending upon the workload, and use the periodic compaction jobs to merge the small files. Apart from this, we can also use Hive style partitioning or partition metadata that your compute engine understands, so Spark or Synapse can skip irrelevant folders efficiently. For example, if most analytical queries filter on date and region, over here you can partition by year, month, day, and region to limit the reads to only relevant slices. Also, have an archival policy to move old partitions to coolest storage tiers so that you can optimize both performance as well as the cost. So guys, with this, we have covered the intermediate level of questions for Azure Data Engineer. And now the next 10 questions, question number 21 to 30, we will be covering the advanced questions for Azure Data Engineer. So the next question is, you need to design a modern data platform on Azure for a bank. So what services would you use? So guys, again, this is a scenario based question, and Over here, you need to answer this question carefully because this is a scenario based question, and these kind of questions, like if you answer them successfully in the actual interviews, so that is going to create a very good impression of yours on the interviewer. And basically the interviewer will also understand that you have the practical skills and not just the theoretical knowledge. So in this particular question, so guys, for a bank where security, compliance, and reliability are of utmost importance, what you can propose is you can propose a layered architecture. Now, what do you mean by a layered architecture? So over here, ingestion can be done via event hubs and Azure Data Factory for batch or stream capture, raw landing in ADLS Gen 2 with strict ACLs, processing in Databricks using data lake for transformations and feature engineering, storage of curated analytics in Synapse, dedicated pools for fast BI queries, and Power BI or a BI layer for visualization. Security layers include private link or private endpoints, VNet integration, or key vault for secrets and key management, RBAC and ACLs, and Purview for data classification and lineage to meet the compliance. Apart from that, what you can do is you can use managed identities for service authentication, implement encryption at rest or in transit, and establish DR with cross-region replications and failover groups for databases. For ML or the real-time scoring, deploy models in Azure ML or Databricks, serving with monitoring and explainability. For governance, you can include Purview Plus, auditing, and policy guardrails via Azure Policy. And finally, you can incorporate CI/CD pipelines, staging and user acceptance testing environments, and robust monitoring or alerting so that you can operate at a bank grade SLAs. The next question is, how do you manage the data lineage and governance in Azure? So here, what you can do is you can start by onboarding key data sources, running scans to automatically classify the data, and building a business glossary so that the stakeholders agree on definitions and owners. You can use purview lineage and classification to answer questions like which pipeline loads this table or which downstream reports consume this data set. So all of this is critical for audits and impact analysis. Apart from that, you can also combine Purview with access controls, RBAC, and tagging in Azure Data Factory or Synapse to enforce the governance policies discovered during the scans. The next question is, let's suppose your Synapse queries are slow due to skewed data distribution. So how do you fix it? So data skew basically occurs when one or few of the values dominate a distribution key, causing the uneven compute work across the nodes. So here, first and foremost, what you can do is you can start by identifying the skewed key through the query plan analysis and distribution statistics. Over here, the remedies can include choosing a different distribution column that better balances the data, switching to round robin when no good key exists, or using the replicated tables for small dimension tables that are frequently joined. Apart from that, you can also apply salting, which is nothing but append a synthetic salt value to the distribution key to spread hot partitions and then adjust joins accordingly. But salting complicates the queries and ETL logic, so you have to use it very carefully and judiciously. Another approach is to pre-aggregate or Bloom filter the skewed data or break the large joins into staged smaller joins to reduce the shuffles. The next question is, how would you implement CI/CD for Azure Data Factory? So implementing CI/CD by connecting the Azure Data Factory to a Git repository so that the developers work in feature branches and changes are version controlled. Here you have to use branching strategies such as the collaboration branch or publish branch and parameterize the linked services for environment specific values. And you have to store the secrets in key vault referenced by ARM templates rather than embedding the secrets. So whenever you're ready to promote the changes, you can publish the factory to generate the ARM templates, which can be deployed through Azure DevOps or GitHub Actions pipelines. And these pipelines should run automated validation tests, deploy to UAT, and run the integration smoke tests, and then promote to the production after the approval. Over here, you can automate the environment specific parameter substitution and safe rollback strategies by keeping a previous ARM artifacts. For example, a CI pipeline builds and runs unit tests for data flows, while a CD pipeline deploys ARM templates to the staging resource and triggers the integration tests before manual or automated promotion. So this approach creates reproducible deployments, audit trails, and safer production changes. The next question is, how would you implement real-time fraud detection using Azure services? So a robust real-time fraud system ingests transactional events via the event hubs, or the IoT hub uses stream analytics or Databricks, structured streaming for low latency feature computation and rule-based detection, and leverages a trained machine learning model for probabilistic scoring. So here the online features can be stored in a fast key value store like the Azure Cosmos DB or the Redis for quick lookup during the scoring, while longer term features are computed in Databricks from the Delta tables. So when a suspicious score exceeds a threshold, you can push a message to an alerting system to create an investigation ticket and optionally block the transaction via a decision service. So architect for both precision and latency, simple rule-based checks can be executed very fast, and heavier machine learning scoring can run in parallel or be approximated by lighter models for the initial stage. For example, a pipeline might compute real-time velocity features in stream analytics, apply a rule set, and then call a Databricks endpoint for machine learning scoring before taking action. Over here, the detailed events are persisted to the lake for post-incident analysis and model retraining. The next question is, what are the best practices for cost optimization in Azure Data Engineering projects? So guys, cost optimization requires both architectural as well as the operational measures. So right size compute, leverage auto-scaling and spot instances where tolerable, and reserve capacity for predictable workloads to gain the discounts. So to optimize the storage cost, what you can do is you can use lifecycle policies, compressing data, and avoiding small file sprawl through specific periodic compaction. For interactive or ad hoc workloads, you can consider serverless options to avoid standing capacity costs and implement the query and the data partitioning strategies to reduce the scanned data volume. Apart from that, you need to continuously monitor cost using the Azure Cost Management and set the budgets or alerts, instrument pipelines to track the compute or IO per job so that you can optimize the expensive workflows. The next question is, how do you ensure high availability and disaster recovery for Azure SQL database? So Azure SQL database provides built-in high availability and backup features, but for robust DER across regions, you should configure the active geo replication with failover groups, which creates the readable secondaries in another region and supports the automatic or manual failover. Over here, you have to complement the replication with automated backups and retention policies that meet your RTO or the RPO objectives, and regularly test failover procedures to ensure that the applications correctly reconnect and handle transient states. For multi-region availability, consider zone redundant configuration and use read scale out for load distribution of read-only workloads. Also, you have to plan the DNS and the connection string strategies so that the application failover is seamless and includes runbooks for post failover tasks like repointing downstream ETL and updating the firewall rules. The next question is, how do you handle the data quality issues in Azure data pipelines? So data quality should be enforced as early as possible in the pipeline. For that, you have to implement schema checks, null and range validations, pattern checks, referential integrity lookups, and business rule validations at the ingestion or transformation stage. Over here, you use a quarantine or the bad records store where the invalid records are isolated for inspection and remediation, and emit structured error messages and metrics to monitoring systems so that data engineers can triage the issues quickly. Apart from that, you have to automate the data quality checks in Databricks or ADF data flows and consider adopting the existing frameworks to codify the expectations and produce the human readable reports. Last but not the least, you can also create the SLAs for data freshness and quality and automated alerts for threshold breaches and a feedback loop so that the producers can fix the upstream issues. The next question is, let's suppose your Spark job in Databricks keeps failing with out-of-memory errors. So how do you troubleshoot this particular scenario? So first and foremost, you can start by examining the driver and the executor logs to determine whether the memory pressure is happening on the driver, the executor, or both. Next, you have to check the size and the number of partitions, as too few partitions cause large tasks that out of memory, while too many tiny partitions can cause overhead. So apart from this, you have to tune the parallelism by adjusting the spark.sql.shuffle.partitions or repartitioning the dataset into a sensible number of partitions proportional to your cluster cores. For that, you can use the persist or cache cautiously and avoid caching very large datasets unless the memory is sufficient. So for joins, you prefer the broadcast joins where one side is small. Otherwise, consider sort merge joins and ensure join keys distribute evenly to avoid the skew. Apart from this, you need to increase the executor memory or cluster size if computations are legitimately requiring it, or refactor the logic to reduce the memory footprint. The next question is, what is Lambda architecture and how you can implement it in Azure? So on Azure, you can implement the batch layer using the ADF plus Databricks to run periodical large-scale batch jobs, the speed layer using the Event Hubs plus Stream Analytics or Databricks structured streaming for real-time processing, and the serving layer using the Synapse or a store of a pre-aggregated views for dashboard and API responses. The serving layer reconciles batch and streaming outputs so that the queries can read a combined result that benefits from both accuracy and low latency. So here the patterns include storing streaming increments in a fast store and reconciling during the batch runs. So while Lambda provides the robustness and correctness, it also introduces complexity and duplication of logic, and many teams prefer Kappa where possible. For example, a retailer might use streaming to surface minute level inventory alerts and a nightly batch jobs to compute fully correct inventory snapshots. The BI layer then merges both to present a consistent dashboard. So guys, with this we have covered all of the 30 questions, and we have come to the end of this session on Azure Data Engineering interview questions. I hope you guys have enjoyed the questions. If at all you have any doubts or queries related to this session, then you can write them in the comment section and we will try to resolve them as soon as possible. So guys, thank you so much for being with us, and I wish you all the very best for your upcoming interview.